good to see me. I guess I could turn this bad boy on too. They were. How did they get in there? Hope it's not already started. Okay, I'm gonna throw on the video. They do? Oh my gosh. So you all are here very early, and we were doing some test runs right now. Should you cool with me doing the test runs? Is that cool? I mean, you all are in basically, this is the backstage, which is very cool. Um, oh, it's Sam. All right, Sam. Awesome. Dude, you're showing up very punctual. I like it. So, can we do this test run? I'm trying to see if the way that I do this video, it bricks out my computer or not, because last time we had some problems. So I'm gonna try this, and you all are gonna hopefully just enjoy, and I'll be back in a minute.
Everybody wants just a little redemption. Everybody needs just a little affection. Everybody hurts. Everybody heals. Everybody wants just a little connection. Everybody needs just a little attention. Everybody hurts. Everybody heals. A beautiful day. Freedom, freedom, freedom for a change. Freedom for a chance. Everybody wants just a little direction. Everybody needs just a little conviction. Everybody hurts. Everybody heals. Everybody wants just a little protection. Everybody needs just a little rejection. Everybody hurts. Everybody heals. A beautiful day. Freedom, freedom, freedom for a change. Freedom for a change. Freedom for a change. the 3rd of September. That day I'll always remember. Yes, I will. 'Cause that was the day that my daddy died. I never got a chance to see him. Never heard nothing but bad things about him. Mama, I'm depending on you. Tell me the truth. Mama just hung her head and said, son, Papa was a rolling stone. Wherever he laid his hat was his home. And when he died, all he left us was alone. Oh, Papa was a rolling stone, my son, yeah. Wherever he laid his hat was his home. And when he died, all he left us was alone. Hey, Mama, is it true what you say that Papa never worked a day in his life?
And Mama, some bad talk going around town saying that Papa had 3 outside children and another wife. And that ain't right.
Heard some talk about Papa doing some storefront preaching, talking about saving souls and all the time leeching, dealing in that and stealing in the name of the Lord. Mama just hung her head and said, Papa was a rolling stone, my son. Wherever he laid his hat was his home. And when he died, all he left was alone. Hey, Papa was a rolling stone. That coming, wherever he laid his hat was his home. And when he died, all he left was alone.
Hey mama, I heard Papa call himself a jack of all trades. Tell me, is that what sent Papa to an early grave? Folks say Papa would beg, borrow, steal to pay his bills.
Hey, Mama, folks say Papa never was much on thinking. Spent most of his time chasing women and drinking.
Mama, I'm depending on you to tell me the truth.
Mama looked up with a tear in her eye and said, son,
Well, 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 well. Hey, yeah. And when he died, all he left us was alone, 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 alone. Papa was a rolling stone. Wherever he laid his hat was his home. And when he died, all he left us was alone. I said,
How good is that? All right, backstage sound checks. This is awesome you're all here. I'm gonna go and prep for the next, like, 30 minutes and make sure that I have all of my ducks in a row before we actually start. I'm super excited to see that there's actually people that showed up already. So that is awesome. That is just very cool. It's not gonna be just me here talking to myself for this conference. And I'll see you all in, like, I guess 30 minutes if I'm looking at the clock. It's about, yeah, 40 minutes really. And I'm super excited because we just released this LLM in production report today. I'll throw a link in the chat right now. So those of you that joined early can have some reading material while you're waiting if you want to check it out. I spent a ton of time on this and I am so happy it's finally out. All right. There we go. So I will see you all in just a bit. I'll be back in 40 minutes and talk to you in a bit. And I realized something else. So this is what you get for coming backstage and signing on too early. Not polished at all. And actually, that's not just a early thing. That's going to be the whole conference. But if you want to meet people, so we got the chat going on, but on the left side of your event, let me just see if I can share my screen real fast and show you. There is actually some pretty cool stuff that's going on. If you want to hit the match button that is on the left side of the screen, and the platform that we're using, you see there's a match button, and boom, boom, boom. I'm gonna share my screen so that you can see it. And let's see. So I'll show myself. I'm sharing myself. Talking to myself. So right here, there's this match button, and if you click that and then you click get started, you can meet some of the cool people that are in the chat. So, or that are here right now a little early. So everybody that's in the backstage getting ready, all this cool stuff. And you can just hit get started, and then you'll match up with somebody randomly that is here with us. So that's it. Now I promise you, I'm gonna go get ready, and I'll see you all in a
heals. Everybody wants just a little connection. Everybody needs just a little attention. Everybody hurts. Everybody heals. A beautiful day. Freedom, freedom, freedom for a change. A beautiful day. Freedom, freedom, freedom for a change. Everybody wants just a little direction. Everybody needs just a little conviction. Everybody hurts. Everybody heals. Everybody wants just a little protection. Everybody needs just a little rejection. Everybody hurts. Everybody heals. A beautiful day. Freedom, freedom, freedom for a change. A beautiful day. Freedom, freedom, freedom for a change. Freedom for a change.
It was the 3rd of September. That day I'll always remember. Yes, I will. 'Cause that was the day that my daddy died. I never got a chance to see him. Never heard nothing but bad things about him. Mama, I'm depending on you. Tell me the truth. Mama just hung her head and said, son, Papa was a rolling stone. Wherever he laid his hat was his home. And when he died, all he left us was alone. Oh, Papa was a rolling stone, my son, yeah. Wherever he laid his hat was his home. And when he died, all he left us was alone. Hey, Mama, is it true what you say that Papa never worked a day in his life?
And Mama, bad talk going around town saying that Papa had 3 outside children and another wife. And that ain't right.
Heard some talk about Papa doing some storefront preaching, talking about saving souls and all the time leeching, dealing in that and stealing in the name of the Lord. Mama just went ahead and said, Papa was a Rolling Stone, my son. Wherever he laid his hat was his home. And when he died, oh, he left us alone. Hey, Papa was a Rolling Stone. That done it. Wherever he laid his hat was his home. And when he died, oh, he left us alone.
Hey mama, I heard Papa call himself a jack of all trades. Tell me, is that what sent Papa to an early grave? Folks say Papa would beg, borrow, steal to pay his bills.
Hey, mama, folks say Papa never was much on thinking. Spent most of his time chasing women and drinking.
Mama, I'm depending on you to tell me the truth.
Mama looked up with a tear in her eye and said, son,
Well, 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 well. All he left us was a lone, lone, lone,
Oh, I gotta think. What video can I make for that LLM in production conference? Gotta make some kind of promo video. What can I make? Come on, creative juices. Give me something original. Give me something unique. Don't fail me now. Oh, I know. Maybe I can make a deep fake of Mr. T saying something about using LLMs in production. That could be funny. That could work.
But I pity the fool.
What's your prediction for the fight then?
Prediction?
Yes, prediction.
Pain.
Nah. I feel like the LinkedIn algorithm these days, it hasn't been pumping my content. I just don't talk about all the ways you can use GPT for this or Chat GPT for that, or your favorite prompts, or the llama model, or what business I can start with GPT, or wait a minute, what if I...
little redemption. Everybody needs just a little affection. Everybody hurts, everybody heals. Everybody wants just a little connection. Everybody needs just a little attention. Everybody hurts, everybody heals. A beautiful day, freedom, freedom, freedom for a change. A beautiful day, freedom, freedom, freedom for a change. Everybody wants just a little direction. Everybody needs just a little conviction. Everybody hurts, everybody heals. Everybody wants just a little protection. Everybody needs just a little rejection. Everybody hurts, everybody heals. A beautiful day, freedom, freedom, freedom for a change. A beautiful day, freedom, freedom, freedom for a change. Freedom for a change. Yeah, they wishing and wishing and wishing and wishing they wishing on me. I've been moving calm, I'm still no trouble with me. Trying to keep it peaceful is a struggle for me. Don't pull up at 6 a.m. to cuddle with me. You know how I like it when you loving on me. I don't wanna die for them to miss me. Yes, I see the things that they be wishing on me. Hope I got some brothers that outlive me. They gon' tell the story, it was different with me. God's plan, God's plan. I hold back, sometimes I won't. I feel good, sometimes I don't. I finesse down Western Road. Might go down to G.O.D. I go hard on Southside G. I make sure that no side E. Still, she said, do you love me? I tell her only partly. I only love my bed and my mama, I'm sorry. 50 dub, I even got it tatted on me. 81, they'll bring the crashes to the party. And you know me, turn the 02 into the 03 door. Without 40 hearts.
People of Earth, we made it. We're doing it. It's official. The LLM in Production Conference Part 2 is officially kicking off right now with this. I think I may just be the most excited person ever because this has been quite the feat to wrangle 84 speakers all onto a virtual streaming platform. And since it is not anywhere near finished yet, ask me in 2 days how it went, because as most virtual conferences go, I can guarantee you one thing. And that one thing is that there will be some technical difficulties over the course of the next 2 days. We're going to have all kinds of fun, but I'm just setting the bar real low. All right? Expect technical difficulties because I've done enough of these to know that something's going to mess up over the next 48 hours. Now, if you came and you were looking for a very professional conference, you're not going to find it here. That is not what we are doing, all right? Do not expect any kind of professional conference. You've probably been to a ton of these since 2020 and everything moved online, as I have. And one thing I can tell you is that we do not have venture backing to pay for professional people to run this for us. So it's just me and a few people in the background, and we're doing it all very, very much with our whole hearts. And that's why I'm saying bar's going to be set real low, but the content and the quality of the content, I'm hoping, is going to be what carries us through. So you all probably saw the lineup. It's absolutely nuts. I recommend going through all of the different speakers, seeing who they are. I mean, shout out, we've got the person who wrote the Lima paper. We've got Mate coming up in a minute, who is a co-founder of Databricks. We've got Sarah, who is coming up tomorrow, and she leads the Einstein team at Salesforce. I mean, I could just go on and on. The list is unreal. I cannot do any justice to everyone that is coming. However, I encourage you to check out all the speakers, all the talks that are coming on. We've got 2 tracks. We've also got a workshop track. So if you want to get hands-on, you can code along in the workshops. There's limited amounts of seats in the workshops, and the workshops are free. So just letting everyone know, the workshops, the virtual workshops that are happening on like track 3, or AKA the workshop track. we named it that. Yeah, no better name that we could come up with besides the workshop track. So track 3 is the workshop track, and that is completely free. However, we have all kinds of in-person stuff that's happening as we go along, and I'm gonna just like get right into it. Let me share my screen and go through a few house cleaning items, because this is set to be quite the virtual conference. All right, and let me know in the chat if anybody liked that intro, because we worked real hard on it. Especially if the Soul Train vibe did not get you dancing, I don't know what will. This may not be the conference for you, all right? We got lots more of those funny interludes coming up and coming through over the next 48 hours. Anyway, let's go into this. Let me just share my screen, and we're going to talk for a minute about all the fun we're going to have. As you know, this is part 2 of the LLMs in Production conference. If you did not catch part 1, I have got good news. We recorded all of it, and it is on this very platform that you are streaming from. So you can just go to the events tab, and you'll see all of the replays. There was probably, I think there was like 20 talks from that. I can't remember. Don't quote me on that. But it was spectacular. And then I decided we got to outdo ourselves for this one. So that's why we're here. And talk to me in 2 days. That's all I'm saying. I want to make sure that everyone knows, though, about our lovely sponsors for this event. We've got Redis. They are the diamond sponsor, and we're going to have Mr. Sam Party giving a bit of a talk in about 2 hours, I think. So stick around for that. Huge shout out to Redis. And you can see their booth if you hit on the left, there is a solutions tab. And check that out. We're going to keep cruising. You can actually see all of our sponsors' booths in the solutions tab. So I encourage you to go in there, poke around. Lots of them are giving out swag, and you don't really have to do anything to get it. You just say, hey, what's up here? I'm here. Give me some swag, and check out their tools. So next up, I am going to mention that this is not a one-to-many type conference. This is a many-to-many type thing. And what I am going for is that I would love if you met with other people in the conference. And how do you do that? You just click on the match button that is on the left-hand tab, and you can just meet all these random people. So I'll tell you right now, as of right now, we have a lot of people that have registered for this event. There's over 6,000 people that have registered for this. And online, we have got, I'll give you the official numbers that I'm looking at right now. There are 1,000 of you that are attending. And hopefully over the course of the day, that number will grow. So during the breaks, if you don't want to listen to me talking, then feel free to jump over and hit that meet button, or match, sorry, and then you'll get to talk with some people. It's awesome. Oh, I see somebody in the chat saying that they met with somebody already. Yes, I love that. I love that. And the other thing is, you've got the sponsors booths. Go check them out. Get all kinds of cool stuff from them. See what they're up to. See what they're doing. It is absolutely incredible. Again, thank you to all of our sponsors for giving us support, because we're a community, and with the sponsors' support, now we can do more stuff in the community, like this new report that we just came out with. And this came from back when we did the first ever LLMs in production roundtable, and there was so much interest in that event that happened in March this year. So about 3 months ago, 4 months ago, where are we, in June? Yes, we created a little bit of a survey. We sent it out, and I'm going to go over all the results just in a minute, because I think it is, well, basically, I'm just going to tell you straight. It's my hard work, and I want somebody to look at it. I put like 3 months into it. So you're all going to have to suffer through it. If you don't like it, then just mute me for about 20 minutes or 15 and start it back up when Matt Tay comes on. But I think you're going to like it. We have a lot of really cool insights when it comes to people using LLMs in production or not using them and why they're not using them. So I'm going to get to that just in a sec. But first, I want to mention that we have, back by popular demand, created the I Hallucinate More Than ChatGPT shirts. So if you are interested in checking out this shirt, I'm going to just put the QR code up, and feel free to throw it on, boom, boom, boom. There we go. I Hallucinate More Than ChatGPT. For the low cost of $22, you can get yourself one of these shirts and be the coolest kid at wherever you go. I know that when I wear mine, I tend to get a few comments from people. And so you get some head nods, you get some comments. Feel free to go grab a shirt. Last time that I did it, I will say, I messed it up. I'm not the best business savvy person because I put the price way too low, and it wasn't until after the conference I realized I lost money because of the shipping costs. So we had to raise the price just a little bit on this one. I tried to keep it affordable so that everyone could enjoy the I Hallucinate More Than ChatGPT shirts. Get them if you're interested. But if you just want some free stuff, tweet at us. LLM Ops is just ML Ops at Burning Man. And we'll send over some of this incredible sponsor swag. Oh, look at all this good stuff. We've got mugs, we've got shirts, we've got socks, we've got stickers. I mean, what more could you ask for? Let's go. Let's do this. All right. So if you're interested, tweet at us. Make sure you say that LLM Ops is just ML Ops at Burning Man. We're all getting ready for August. Burning Man's coming. And if you get the joke, it's because these LLMs hallucinate more than your average burner. All right. Next up, I want to mention that in case you do not know, we've got a podcast. And if you like what we're doing here at this conference, there's all kinds of stuff that we do in the podcast that comes out weekly. And I think you will enjoy it. We talk to some incredible people, and it is a ton of fun. So feel free, scan that code right now. I'll also throw it up right here so you can have it periodically throughout the event. And we're going to keep cruising now. Hopefully everyone has joined Slack. Hopefully all of you that are in here have joined Slack. If not, feel free, scan this. I'll also put it in the chat so that people know it is right here. Throwing it in right now. And we're having all kinds of conversations that are happening in Slack. We're also having all kinds of conversations in the channel that is called Community Conferences channel, all right? But if you're too lazy for that and you just want to talk in the chat right here on the platform, that's totally cool too. I understand that some of you may have Slack fatigue. If I showed you my Slacks and all of them that I'm a part of, you would probably faint. And last but not least, before we get into this good old report that I want to share for a minute, let's talk about our in-person community because it is blowing up right now. There's this number, I mean, it grows by the day. So that was 16,000 members. There's actually probably more like 20,000. And in conjunction with the event that we have going on today and tomorrow, we've got some satellite events happening to complement it in person. So if you're in Amsterdam, there is a meetup happening tonight, and some of the speakers that are on the feed and that are speaking today in this conference, they're going to be speaking hybrid in Amsterdam. We've also got a hackathon happening in Berlin. So if you are in Berlin and you want to join us for a vector database hackathon, we will leave a link to that in the chat right now. It is super exciting. And that's not all we've got. We've got a watch party happening in London in case you happen to be in the good old United Kingdom. And last but not least, there is a workshop that is starting right as we are ending in San Francisco using Ray and learning how to deploy and scale LLM applications. So those 4 spots right now, killing it. Amsterdam, London, Berlin, and San Francisco. In case you're in any of those spots, check out what we're doing in person. And now let's get into this report. I think we're going to talk for a minute about the report because, as I said, I'm very proud of it. I did a lot of work to make it happen. A lot of people helped me make it happen. And so I want to just show you all what exactly it is. And you can grab the report in case you do not have it already. I will drop a link in the, let me just make this, whoa, that's not gonna work, is it? Let's see if I can do it like this. No, oh my God, here we go. I think that's as good as we're gonna get. What about like, there we go. That's the aspect ratio I'm looking for. Let's get rid of this guy. And as I mentioned, if you're looking for a well-polished conference, may not be the one you're looking for. This may not be it. So the report is right here in case anyone wants to grab it and follow along with me. You're gonna lose me for a moment, and it's just going to be the report up. And so I want to just talk about it for a second with you all. I think that is a good one. Grab the report. in the QR code. I'll also throw it in the chat if you do not have it already. But this report was created when we did the LLM in production roundtable. From there, we were able to survey over 100 people and see how are they using LLMs in production, how are they not using it, why are they not using it, what are some of the main challenges, what are the tools that they're creating around LLMs in productions, and then what are some questions and concerns that people have. So, of course, we have some supporters. We want to give a shout out to them, and even more than that, this report would not have been possible without so much help from the community. So huge shout out to everyone that helped me along the way. This has been, as I mentioned, 3 months in the making. I'm going to skip over the introduction and I'll let you all read that for yourselves when you download this report. I will mention that the majority of the people that participated in this report were ML engineers, ML ops engineers, of course, I would expect in the ML community, data scientists, head of data, head of ML, head of ML ops, all that kind of stuff, founders, CEOs, CTOs, and then product people. And you had the occasional cloud engineer, marketing manager, analytics engineer, consultant, all that fun stuff. And out of all of these different titles that we had, over half are senior or hold executive positions. So, you know, there's no messing around. All right, that's how it looks. Real easy, real nice. And we broke it up and we said, hey, there's like 7 key takeaways that we've got from this, right? The 7 key takeaways are that there's some common use cases that are starting to form. And from these common use cases, we can see that LLMs perform very strongly on these use cases. And then there's other use cases that maybe they're not as good as we thought they were, but people are trying to use LLMs as much as they can. And they're using them in all different creative ways. And that's cool to see. The other thing is that it's still unclear what the ROI of using these LLMs is. And that is something that a lot of people talked about. Not only is it cost, not only is it when it comes to the serving costs or just hitting API, it's also the resources that you need to invest in learning about this tool and learning about this new technology. So number 3 is all about hallucinations. As we mentioned, where is it? Come on now. You think we aren't going to talk about hallucinations? I hallucinate more than ChatGPT. Yes, of course we're going to talk about hallucinations. Judging by my college antics, I couldn't let that one slide. And side note, like researchers have the best terms. Can we just all admit researchers created the best terminology? There's hallucinations, and my favorite is catastrophic forgetting. Who created that term? That term is amazing. Give that person a medal. Catastrophic forgetting. It sounds like something that you would read in the ancient Greek epics. That's what it sounds like. Ulysses and the Odyssey. Come on, catastrophic forgetting. Anyways, back on track. I digress. Hallucinations are huge concerns. They could ruin your brand. They could mess things up. So people noted that in the survey. Then inference speed, we all probably have felt that, and there's going to be a lot of people talking about that in this conference. So this basically right now is kind of like the primer for what you're about to see over the next 2 days in this conference. I'm telling you what people said, and now over the next 2 days, we're hopefully going to hear from a ton of people, and they're going to talk about how they are dealing with these challenges. All right. And this was an incredible insight. I'm just going to mention this. Boom. Larger questions, such as which part of the current workflows will be replaced completely by LLMs versus augmented. And that is not clear. What part of my workflow do I replace and do I not need to be involved? What part can I augment and I still should be in the loop? All right. I just saw somebody put in the chat that their wife created the term catastrophic forgetting. No, that's not true, is it? Sean, if it is, DM me. Let's talk, because wow, that is epic. No way. Kudos to your wife, Sean. All right. Number 7, prompting, valuable skill. We all know that. We've all messed around. Even if you just dibble-dabbled with some image creating tools, you know that things can go off the rails and you need strong prompting. But here's the problem. You cannot force the model to give consistently correct output. The obscurity around the probabilistic nature of LLMs was cited quite a bit. So here's the people that were using, here's the people that weren't using, just as a quick one. But I want to get into this using OpenAI real fast. This is a nice little design. I like it, and you should check it out. But right now, we're not going to check it out that much because I want to talk about, so here's all the use cases. You can go into those more. I'm going to leave, again, if you want to check, if you want to download this and follow along, there's the QR code right on the screen right now. Just for a moment, you can scan that QR code. And I want to mention that this is the amount of people using OpenAI and the correlation, because I thought this was fascinating. And hats off to Jeremy for helping me find this last minute. And hats off to the designer Marissa for incorporating it last minute. We literally did this last weekend as everything was supposed to be done and we were getting out the door. Then we found this correlation in the data. It was so cool to see. And what it says is that making sense of OpenAI data. All right, so you can see that there's people using open source versus people using OpenAI by company size. And what you can see is that if you are a smaller company, you're not using, there's less people that are using OpenAI. And if you're a bigger company, there's less people that are using OpenAI also. If you're in the middle, then most of the people that are in the middle are using OpenAI. So what are the takeaways from that? Well, this is one theory that we had, and it's that if you're a big company, you may not trust OpenAI with your data, and you probably have the resources to do your own thing. And so it's more likely that you're not going to be using OpenAI and you'll try and roll your own. Now, if you're in the middle, you're just trying to find that product market fit, you're trying to really grow, you're trying to scale, and this whole like escapade trying to add AI to the product may not be your core business. And so you want to get up and running as quickly as possible. And it's okay if you use OpenAI in that one. And last but not least, if you're a smaller company, then you're probably thinking that, oof, I don't know about using OpenAI because it is my IP. It's your core competency. So then you're not using OpenAI. Let me just preface this. It's 100% theory. Nobody actually said this that clearly, but this is trying to grapple with the data and figure out what could some of this be, right? So the other quick thing here, of the 11 respondents who were using LangChain, 100% of them were using OpenAI. How wild's that? How wild's that? All right. So there's some cool insights in this report. I encourage everyone to check it out, get down with it. And I'm going to leave with a few of my favorite quotes from the last parts. I'll just let you read it yourself so I don't get banned on YouTube where we're streaming. So, all right, go ahead. And, you know, of course we had to. Of course we had, what is a report without a market map, right? You can't make a report and not put a market map in it. But what we are seeing is a stack that is coalescing. There is the foundational models piece. You need a vector database. There's a lot of those coming out, and they're going to be talking at this conference. We've got Redis, obviously the key sponsor. We've also got Chroma talking, and we've got Zliz, aka Milvis, and they're going to be giving a talk. Then you have this foundational model tuning and model building. Got some of that happening. You've got your developer SDKs and tools that you can stick on top of the stack with your Llama Index and LangChains. And last but not least, on the very top, you can get some foundational model ops, FM ops, some monitoring and experimentation with something like Portkey or weights and biases, all of that good stuff, Arise maybe. And that is the stack we're starting to see, just like the mean stack or the MERN stack is happening. It looks like there's going to be some kind of LLM stack, and whoever came up with the word catastrophic forgetting, if you can come up with an incredible name for the stack, I will greatly appreciate it. Let's make it epic, like catastrophic forgetting, right? Let's do it. So last thing before I jump in, I'm going to let you all read this on your own time. Again, I'll drop the link to this in the chat, but I do want to mention that when it comes to cost, this was an interesting correlation. 25% of people that were not using OpenAI, they all cited cost versus 15% of people that are using OpenAI. So if you aren't using OpenAI, you cited cost 25% of the time, which means that potentially people are not using OpenAI because it is not cost effective for them. We all know that OpenAI is coming out with new cost or new pricing plans like every week. I think just like 2 days ago, they came out with a new pricing plan. So that may render this whole thing obsolete. And that's why I want to do another one of these really quickly, because as soon as we do them, it feels like the week after the data has now changed and things have moved on. This is just like a snapshot in time for what people are going through. And here's some challenges from people that aren't using LLMs in production. Again, hallucinations are a really big deal. They can mess things up, especially getting your company's reputation on it. So beware of that. And now not this one, but this part I think is also really cool. What areas are people most interested in learning about? This is basically why we're having this conference right here. A lot of people said fine tuning, a lot of people said embeddings, a lot of people said inference, and then a lot of people said working with open source models. And what this tells me is that if people are interested in fine tuning and embeddings and also the, working with open source models, you know what that means? It means that the OpenAI offering isn't good enough. It's like people really want to go deeper and they have not found what they're trying to do when it comes to OpenAI's offerings. So I thought that was fascinating. That was really awesome. And of course, boom, we're holding this conference today to talk about all this fun stuff. So that is what I'm going to give you for the LLMs in production survey. Again, if you want to check it out, here is the QR code. Jump in, have some fun, and look at it. And now we're going to keep cruising. Look at that. Oh my God. Perfect timing, because the show is about to actually start now. Enough of me. Let's get the real deal on stage and talk with somebody that's actually doing this for real. And where is he? I'm going to bring Mate to the stage. Paging Mate.
Hey.
There he is.
How's it going?
Dude, it is great to have you here, man. I am so excited. This is like something that, of course, it's always a pleasure talking to you. And as I mentioned when you came on the podcast, for I think the ML world and the ML ops world, you're like the DJ Khaled of our industry, because you just keep dropping hits and hits. I mean, before, let's just give it, in case, for like the two people that do not know you, you created Spark, you were co-creators of Spark, you also had your hand in ML Flow that everyone knows and loves, and is starting to play around. ML Flow now supports LLMs, which maybe you're going to talk about, maybe not, but we should talk about that later. And then since we talked last, man, you dropped Dolly. So, I mean, wow, And then you've got your name all over all kinds of cool papers. Frugal GPT. If anyone has not read that paper, that is incredible. I really love that you're still keeping your roots in the academia and putting out papers. And so, man, last thing I want to announce to everyone before we get started, and I'm going to let you take over and drop some wisdom on us. In 2 weeks, on June 26th in San Francisco, you and we're going to meet face to face. We're going to be in person at the LLM Avalanche meetup that we are both doing. And that is, it's like the sound check, or it's gearing up for the data and AI summit that you all are putting on. And so I'm super excited for that. If anyone is in San Francisco for June 26th, let us know. I'm going to drop a link to that in the chat, and I'm going to hand it over to you, Mate, man. It's great to have you here.
All right, thanks a lot. I'm just excited to be here. Let me share. Ooh.
Now the fun part starts. Now
this requires AGI to figure out.
This is not your regular Zoom call, man.
Yeah.
All right.
Okay. Do you see my slide?
I do. I see it. Yep.
Okay. Perfect. All right. So I'm going to talk about this emerging area of LLM ops and some of the things that I'm seeing in industry at Databricks, both building our internal LLM applications, which we have, quite a few of, and, helping, our customers with them. And I'll also talk about some research that I've been doing at Stanford, even kind of before ChatGPT became really popular, on using LLMs more reliably. That is also, I think, relevant to this field. So it'll be sort of a tour of a bunch of things, I'm also going to list a bunch of stuff that I'm not working on at all, but that I think is cool. And hopefully it gives you, a little bit of a perspective of how to approach this problem. Okay, so large language models are super amazing. They can, generate text as very fluent, often very grounded in reality. You can do a lot of cool applications with them, all the way from the traditional, few shot classification type of stuff to new things like chatbots where you can ask questions. They know about all kinds of recent research and stuff like that. They can even do programming. So very cool. But if you look at these answers a little bit more closely, there are actually, a bunch of problems. So for example, this first one, we asked ChatGPT when was Stanford University founded, and it says 1891, but that's actually wrong. That's just when the first class came in, but the university was founded earlier. Colbert, this is a model that my research group developed, so we were super excited that ChatGPT knew something about it, but it says it was developed by Salesforce Research, which it wasn't. It was developed by us at Stanford. And finally, this code here, you can't see, it's not showing all the code, but it's saying to parallelize this code, you should use thread pool executor. But the problem with the code was actually that it's some kind of serial algorithm. So you need to change the algorithm. So you can't just throw in thread pool executor. So there are definitely challenges with the quality of responses in LLMs, especially if you want a production-grade app. And on top of that, there are also other operational challenges with cost, performance, privacy, and just the need to update your model and your application. So here are some examples of things that can go wrong. Of course, these models are expensive to run. Early on, they used to go down some of the time because of the load. Another interesting issue that people have been talking about is prompt drift, which is the models are changing, over time as they're being trained, and they might get worse at some tasks they could do before. Now they're worse at it. And then there are also issues with timeliness and with privacy that affect a real app. So even today, if you ask, all these OpenAI models about, events past 2021, they don't know. So, and obviously it's expensive to update them. Otherwise, they would have updated them by now. And if you have an application with privacy, with the emerging sort of rules around privacy, you might also run into issues there where a user wants to remove their data. So for example, ChatGPT seems to know something about where Bill Gates lives, but if Bill Gates was a European or a Californian, he could ask them to remove that data about him, and then it would have to forget this information. So the question is, how can we make LLM apps reliable? This is this area that people are calling LLM ops, and I'm going to talk about like three things in this area. The first one is, how do we extend what we currently do in ML ops to work well for generative AI? And I'll talk about what we're doing in MLflow specifically based on our experience. The second is new programming models for these kind of applications, which is one of the things I've been doing at Stanford. And then I'll talk a little bit about other emerging tools too. Okay, so let's start with the basics. So I really think that for anything you're doing with language models, even though it's a really cool new kind of application, if you want it to work very reliably, you want a way to improve it, you need to start with the basics, and these are the same as in MLOps the way it normally was. So one of the most basic things you need is a way to swap and compare different models or even pipelines of models, because a lot of this is done using chaining now, for an application, and just say how are they doing at different stages, how do they compare on different metrics. So you should set up your development infrastructure to support this simple kind of comparison task. Second thing you need is to track and evaluate outputs, and have this historical database of what happened so that you can kind of search. You need a way to deploy pipelines reliably and see what's happening. And you need a way to monitor these deployed applications and analyze the data once they're actually out to see what's happening with them over time. So we're trying, we're basically implementing all of these in the MLflow open source project. And then the part that ties with data, we're also integrating into just Databricks as a platform. If you want to have kind of a consistent platform across data engineering and ML engineering, we're designing it so it's very easy to do both of these things. So let's start with the first one, swapping and comparing language models. So in MLflow, if you're not super familiar with it, one of the key concepts there is this model abstraction that can wrap a model. So the rest of your code doesn't need to know how it's implemented. You don't need to know, what framework is it using? Is it a local model or something I'm calling over the network like OpenAI? Is it, a single thing or is it a pipeline actually of multiple steps? You just basically have this function. For example, a function from string to string could be a call to OpenAI or a local model or some kind of pipeline. And we've created integrations with a lot of the popular LLM tools to let you manage them as models in there. And the same thing with pipelines. Specifically, we've been focusing on LangChain for that. So you can easily wrap all these things into these model objects, and then in your application you can swap them. In your evaluation code you can compare different ones. You could imagine like routing some percent of traffic to one versus the other, and so on. So then you can just call these general functions on each one. So that's very basic but important, and we're seeing this come up a lot as people want to try different options in this space. A second thing that we're doing for the experiment tracking is extending what we call auto logging in MLflow. So in MLflow, the idea is, you develop your machine learning code, and we have some lightweight calls you can make that cause MLflow to record what's happening, wrap it into these kind of generic formats like the model I talked about, and make it easy to evaluate and compare and track results over time. So one of these is, you can just do MLflow.start run, and then you can train models and log them and so on. So we've extended this auto logging for OpenAI, so you can remember basically a prompt and other parameters you used in OpenAI and wrap that up and call it later with model.predict. And we've also extended it with LangChain, so you can set up a chain with local models or remote models and save it, and again, load it later and call stuff about it. And once you've run these, the other thing we've done is in the UI, we've created, a new view in the UI that works well for evaluating long form, like generative outputs, like these texts from these models. So basically, you can run all these models on some evaluation data set, some questions or whatever, some input text, and then you can see for each one side by side, you can see what they each producing. We're also going to extend this so you can actually add ratings like right here, or import ratings from a third-party labeling service. So you can compare all of them. And of course, once you've saved these models, you can also evaluate them programmatically. We have this function MLflow.evaluate with a lot of common metrics people want to run. And we've put in a lot of the metrics you want for LLM applications, like the Rouge metrics for summarization, and various other ones, some metrics on toxicity, various things like that. You can also easily extend this to have your own. So that's basically like working with the models themselves. And then, of course, you also want to deploy the models and check what's happening after. And the way MLflow works, you can deploy a model to a variety of different serving layers. We want to make it portable across them. So you can pick your favorite one here. And once deployed, you can get these predictions out of it. And this is like one of the areas where on Databricks specifically, we've integrated this very closely with what you do for data engineering. Like basically, as your model runs, you just get a table that's automatically created, and you can run alerts on the table. You can basically have a SQL statement and say, alert me if whatever this SQL statement ever returns, true or something like that. So it's easy to do that, but you can use whatever deployment tool you want with this stuff. Just a little bit more on some of the things we're doing with this at Databricks. We've also released some reference applications, like for example, how to do a customer support bot that includes a vector database, language model, and the ability to say, it doesn't know about certain topics and so on. So some kind of filtering. And we've also released this free course on edX on LLMs application to production that covers, what we've been seeing at different stages of this workflow, not just LLMs themselves, but all the peripheral things like monitoring, searching, vector databases, chains, and stuff like that. So that's kind of the basics of MLOps, and they will definitely help you like get from a demo, which is usually easy to make with these LLM tools, to something that like works reliably, 80, 90, hopefully eventually 99% of the time or more. But it's still, it's still a lot of work to make these happen. So I also wanted to talk a little bit about what the future of programming with these models could look like. And this is one of the projects that my grad students have been doing at Stanford. It's called DSP, or Demonstrate, Search, Predict. So today, if you look at not just LLMs, but foundation models in general, these pre-trained models that on large data sets, there are so many different tools and techniques you can use. Just for language models, there are different ways to use them. There's instruction, prompting, chain of thought, agents, fine-tuning, and so on. And in addition to language models, there are different retrieval models, your favorite vector index and database, task-specific models, and maybe models for other things as well, like vision and speech that you want to combine. And most people want to build these into pipelines. So we're seeing that, you've seen it if you've used LangChain, or probably it's just a very natural way for you to work with these. So the idea is you break down your problems and delegate smaller subtasks to the models. And I'm showing a couple pipelines from the research literature on the right that are, that kind of did this by hand. So in principle, it sounds great that you can just make a pipeline. But in practice, it's actually pretty hard to connect all these pieces and then to optimize the whole pipeline. If you want to get from like whatever default accuracy it has as you hook everything up to increase your accuracy and, say eliminate like the some type of bad output it's producing or something like that, you've just got all these models sitting there, maybe with prompts or with like some Python code to glue them together. And it's quite hard to, to fix that. And every time every change you make to the pipeline affects everything in it, all the other models. And for example, if you want to, if you were training one of the models or fine tuning it to deal with like whatever input format you're going to give it from above, you'll have to retrain it if you change what you're doing above. So we want developers to be able to step away from this and just think about their system design and components, not about gluing and optimizing all these stages together. So that's what we're trying to do in this programming model, DSP, or Demonstrate, Search, Predict. So DSP is a declarative programming model for these pipelines. Basically, think of it a little bit like PyTorch, how in PyTorch you can hook together layers that are different, operations, and pass, data in the form of tensors between them. In DSP, the layers are actually different foundation models, like language models or retrievers, or potentially other things, a calculator, maybe some other, string-to-string function. And then the stuff you're passing between them is text objects, it's not tensors. So there are three types of functions in DSP, or primitives you can use on your program. There's demonstrate, which is how you tell it what to do. This can be basically providing some training data or other ways to specify constraints. There's search, which is breaking down problems and looking up useful information. This is where something like a vector database would come in. And then there's predict, which is different strategies for using the information you pulled out, checking the quality, asking, is this really the right answer, and so on. And you set up your program, but once you set up the different steps in it, you delegate to the DSP runtime to figure out how to implement each component. And it sees the whole pipeline, and it tries all these techniques I had on the previous slide, the few-shot prompting, chain of thought, different ways of selecting data for each step to automatically tune the whole pipeline, so you don't have to do that yourself. So let's just show a little bit of an example here. This is from this research project we did called Baleen, which is a system that can answer complicated questions using multiple searches over text documents. So for example, over Wikipedia. So one example of the kind of question you could ask was, when was the creator of Hadoop given an award? So Hadoop is a piece of software that was designed by Doug Cutting, and then Doug Cutting got this O'Reilly Award in 2015. But to answer this question, if I gave you this question as a person, you'd have to do a bunch of research, a bunch of searches over Wikipedia or whatever to figure this all out. So this is how you write that in DSP, and hopefully you see it's very simple. So basically, you have this example. The example is what holds our state. You can have different fields on it, and you can say, hey, you can have a maximum number of searches or hops it's doing. And what you can do is you can say, hey, first generate a question from this example, like some query that I want to run on my search engine. For example, who was the creator of Hadoop? And then search for that and take the top 3 examples and stick them in this array called passages. And next, generate a summary of everything I've read so far in light of the question and append that to the context. So that's the strategy. Just keep doing these searches. And finally, once you've done this many hops, generate an answer. So it seems a little bit crazy. By the way, these things, the question to answer and so on, think of them a little bit like prompts. So it seems a little bit crazy that this would just work out of the box. But if you set up the prompts, it can work sort of okay. Not all the time, but a bunch of the time. Just an aside on how to set this up, we actually make the prompts somewhat declarative. So basically, you just say, for each step, I'm going to have these inputs, like a context and a question here. There's a text description, and then I'm looking for an answer, which is a short sentence. But the DSP framework can figure out how to actually word the prompt to make it give you this. And this is one of the cool things that lets you, evolve your program and optimize it over time. So if you just ran this program, DSP would generate a prompt that looks like this, as it's going along. So let's imagine it did the searches correctly and it found some stuff. It would have these passages here. What is Hadoop? Who was it created by? Whatever. and it uses these items, like it says, hey, I'm looking for a short sentence, so it says answer with a short sentence, right? And it even automatically does chain of thought. It says, hey, fill in this stuff. So this is kind of the prompt it does, and the part in green is what the model fills in, and in this case you get the right answer. But this is like basically zero shot. I prompted everything, but it probably won't work all the time. Let's say it only works like 30% of the time or something. How do I make this program better? So this is where you can feed DSP additional data, and it will automatically tune the program to make it work. So one of the things you can give it, and this is this function called DSP compile, you can give it a bunch of like labeled examples of a question like this and the final answer. You don't even have to show it the searches it should do. And DSP is going to like try running each of them multiple times and figure out if it can create a path, like get a path that actually, basically do some searches and actually give you the right answer, because it just knows the right answer for each one. And for the ones where it does, it will use them as few-shot examples in your prompt. So for example, to teach your model, like let's say the final call here is to something like OpenAI, to teach it how to use this kind of context and question and rationale, we gave it this one, but maybe we have an example from the training data where we found that we could answer something. There was this question about which award did the first book of Gary Zukav receive, and we did these searches and we found some stuff. So we automatically found an example that we can put in there, or maybe multiple examples, and we've just gone from instructions alone to few-shot prompting, which works a lot better. And the other thing that it can do here, if you've got enough examples, it can actually fine-tune a supervised model for each part. So instead of trying to do it with chain of thought and so on, you can train a model that's good at answering these kinds of like trivia questions, or at generating the searches for them, which works in a similar way. So that's the idea here. We want to separate the your specification of your pipeline from the optimization, and to work on them separately. So what this gives you is a great way to do iterative development. It's super easy to get started, and it does something out of the box with instructions, which is probably what you would have done on yourself. It's modular because it unties the system design from prompting and fine-tuning. You can, as we update the DSP software, those parts get better, and you don't have to rewrite your whole program. And it also enables optimization, because as we make new releases of the DSP compiler, for example, it benefits all the programs. And another really cool thing is that it actually works really well in practice. We've been evaluating this on a lot of research tasks, especially these knowledge-intensive tasks that require looking up information. And compared to other few-shot methods, where you don't tune on like millions of examples, this is basically competitive with all of them, and it's this very simple interface. So in this plot, it's showing a couple of different data sets, and all of these things here are different implementations with engines, and you can see the scores here on different data sets. And the score with DSP, with the same number of examples, I think it's like 10 or 20 examples, is better than all of them in this case, because it automatically searches for how to optimize this. So this is DSP itself. I'll skip this one, but another thing we can do is even feed in unlabeled examples, and basically use those to train a cheap model that does the same thing our expensive model does, and to get basically even better performance after you deploy. So these are a couple of things, but there's quite a bit more in the LLM ops space that you should look at. One cool thing is constrained generation. There's this project LMQL, and there's also guardrails and JSON former that force the model to output stuff in a specific syntax that really helps in some applications. Dimitrios mentioned Frugal GPT, which is something we've been developing that can combine multiple models and route queries to them, or combine the results from several models to get better cost performance, like the same, better performance than GPT-4, and even lower cost while achieving that performance. And then there are all kinds of ideas for reasoning, post-processing, filtering stuff that further improve quality. And definitely, if you want to learn more about these, I do encourage you to check out the Data AI Summit, which is like free to view online, and to check out the LLM Avalanche meetup that we're organizing as well. Cool. All right. So I can't hear you for some reason, but let's see if I can fix.
Yeah, that was on my side. And
Okay, there we go.
For anyone who came to the first one of these knows that I spent the first like 10 minutes talking on mute to myself.
Oh no. Yeah.
And yeah, having a blast. And so I'm waiting for some questions to come through in the chat because there is a bit of a lag between when we talk right now.
Yeah,
and
makes
when
sense.
people ask questions, but one has already come through, and it's about the latency, and it's asking, do these searches take a lot of time, from Joel Alexander?
Yeah, great question. So it depends a lot on what you use to search. So in DSP, we actually used our own search index, which is called Colbert over Wikipedia, and so the search is very fast. It's like basically like maybe tens of milliseconds for each search. It's comparable to like the cost of calling the model. So it doesn't have to be. It depends on your setting. Like if you called out to like Bing or Google search, it would be slower.
Mm-hmm. Yeah, that makes sense. That makes sense. And while we're waiting for more questions to come through the chat, I just want to bring up that there is a whole meetup going on in Amsterdam right now, and we've got a live feed of them. And
Oh, wow.
so I'm just going to let somebody jump on screen. Look at that. So they don't know they're on live yet. And now they're going to get it about 20 seconds later. So we're going to take them off before they even realize that they're on. They get to do the, yeah, we're on, we're live.
That's
And
cool.
I'm also going to grab. Oh man, this is great. So we've got Chip coming up next, but before I bring her on, there is a question that's coming through. So DSP is better than is DSP better than GPT-4? Is this a correct assumption?
So it depends on the task, but for the tasks we were doing, which are these complicated like knowledge tasks, like this Wikipedia one, it's definitely better. Yeah, like out of the box, GPT-4 won't do that if you just ask it the question. Of course, you can use GPT-4 as the language model in DSP, so you can kind of benefit from everything it's doing. If you use a better language model, the whole program will do better. But the combining like search plus some strategy, I didn't show it, but it can also do things like take a majority vote across answers and stuff like that. Does do better than just the language model alone.
Oh, that's awesome. So the stream just hit the chat because the chat blew up. Now there's so many questions, man. I gotta actually like point to them and figure out what the best one is. So are there any downsides to using DSP versus alternatives?
Yeah, I mean, so definitely it depends what alternative, but definitely this idea of breaking down your application into many steps will add cost and latency as you run each step. So again, in DSP, the hope is that there you can optimize it, or the most important thing is to get the right quality. But you can. It will add some cost. Although, so when we started DSP, like no one was using chaining at all, so everyone was worried like, where it's some cost. But now if you use something like LangChain or agents, it's very similar cost. So you can think of DSP as a way to like take that programming model, but try to figure out how to auto optimize stuff in the background.
All right, I got one last one for you, and then we're gonna bring Chip on, and we'll all have a little chat before she gives her presentation. Question for Mate: how does DSP evaluate its optimizations? Does it do them before deployment or even during execution?
Yeah, great question. Yeah, the stuff I showed, the DSP.compile stuff is all before deployment. So there's nothing like online, and you can give it, some examples where the right answer. We're also working on other ways of doing it, where you can give it just other metrics or things. You tell it avoid this, this situation. So it's all offline, and then you deploy, and you can collect more data and pass that back in.
Oh, killer, man. So, uh, I knew it was going to be great. I did not realize it was going to be so good. You do not disappoint. Now let's grab Chip. And what's up, Chip? How you doing?
Hey there, Demetrius. How could you put me like right after Mate? I can't top that.
I just wanted to get us all on the same screen for a moment because we're all going to be at this LLM Avalanche event in 2 weeks. So if you're in San Francisco, I'm going to say it again. I hope to see you there at the LLM Avalanche event. I'm flying to San Francisco specifically for that. It's going to be a blast, and I'm going to get to meet both of you in person, face to face, for the first time after we've been hanging out virtually for the last like 3 years.
Yeah, should be fun. Yeah.
Yeah, I can't wait to put the picture with you both on Instagram.
There we go. Matt Tate, thank you so much for talking to us about DSP and all this great knowledge. I look forward to seeing you in a few weeks, man.
Yeah. Thanks a lot.
See ya. So, Chip,
Hey, oh my God, I'm still very nervous. Whoa.
I know that it's gonna be incredible. Do not feel nervous at all. I just want to say that every time I like try to write something about something that's happening in MLOps, whether that's like real-time streaming or now this report, it feels like you beat me to the punch, and then I see what you write, and then I go, oh, how am I supposed to even do anything now? This is so good. So if people do not follow Chip's blog, we're gonna leave a link to that in the chat because I imagine there's only like 2 people on here that do not know who you are and do not follow your blog. It is so good and so refreshing whenever you drop a so like in-depth research really is what you do, and the way you can put it all together and explain it, I love it. So that is my that is my
Demetrius, I
introduction.
already like you. You don't have to say so many nice things about me.
So that's what I'm gonna do right now. I'm gonna leave it at that, and I'm gonna let you jump on and give your full talk, and
I
then
have
I'll
a
be back in
question.
like
How do
yeah.
I see the chat from the audience?
So it is on the I'll post the link for you on the behind the scenes stuff so that you can just jump in, and then people can talk to you through that. And also, I think so. I did not do your Slido thing yet, but I'm going to, and I'll let you know when that's ready. I will try and do that right now as you're talking. So Chip's got a little interactivity with her talk, and if I can do my part, then it's gonna be cool. And so
Yeah,
I'll
no,
let you
don't
know.
worry. It's not a big part. I usually love like talking to the audience and see like questions and stuff. Okay, but cool. Don't worry about the Slido. Thank you so much, Demetrius.
Yeah, I'll text you when it's ready. Don't worry. I'm gonna make it happen. This is all me. I'll see you in like 20 minutes, 25 minutes, however long it takes.
Cool,
All
cool,
right?
cool.
See ya.
Yeah, thank you. See ya. Okay, so can you all see me? Cool. Wow. That's an interesting experience not being able to see the audience. But hi, my name is Chip. Thank you, Demetrius, for this very warm welcome. And I love the community. You guys are amazing. So much more organized than our community. So we do run a little bit of like MLOps Discord community. So here's a link if you want to check it out. So the talk today is a little bit different from the talk, the original title. So I thought that would be more fun to just go over like open challenges because I think everything is changing so fast. So I just worried it's like everything I talk, if I show people like okay building applications gonna go outdated. So I'm just trying to like focus on some of the few challenges that I see today. So this ranks by like how I perceive as important, and I would love to hear from everyone like how you guys are thinking about the space. So challenge one is like consistency. So whenever we use an applications, users expect some certain level of consistency. And the second aspect consistency is just like how to ensure downstream applications can run without breaking. Because like a lot of time when we use LLM, we don't just use LLM and get the response back, but we might want to process the response for downstream applications. So I think this is like pretty well-known problem at this point. So like for LM, for because of its stochastic nature, sometimes you can have the same input and different output, and you can enforce deterministic determinism by saying something like set temperature is equal to 0. However, it doesn't really fix the cases when you can just have a small changes in the input, and it can lead to like very big output changes. For example, here is just I'm just using ChatGPT, very simple prompt. You like get a review score from like 1 to 5, and you can see just like it just changed the output a little bit, change input a little bit, and the output is like completely different. And it's just like part of the stochastic nature of LLM. And of course, there's a part about like how we might use downstream applications on top of LM. And I was using this, and I want to like use LM to like generate a score, and I want to use an application to parse the score. But then I realized that this is really hard because there's no way to enforce the output schema of LMs. The second challenge is hallucinations, and I would say I see that as the biggest one of the biggest challenges that prevent companies from adopting LLM. So this is very interesting. So like there's a teacher who used ChatGPT. So like he used ChatGPT to write essay and then assigned his student to correct the essay. And they found out that like every single one of these essays have had hallucinated informations. So this is this is very dangerous for on the task where factuality like is very important. So one example is that one example is of course like on the tasks that require legal HR, a lot of contract processing, but also like on the tasks that involve some kind of like code writing. So for example, today LM actually perform very poorly on text to SQL generations. So here's a BERT SQL leaderboard, and you can see that the best model achieved like under 50% accuracy, which is like very bad. So there are multiple reasons like why there are we don't I don't I haven't met anyone who knows for sure why LMs hallucinate, but there are hypotheses. So one by DeepMinder said that like it's due to the models like the understanding of the cause and effect of their actions. And another hypothesis that pushed by several people from OpenAI is that it's due to the mismatch between LM internal knowledge and the label sorry, this is like early event for me, so I haven't had enough coffee and I'm just like tongue twisted all the time. Okay, so between the LM internal knowledge and the labeler's internal knowledge. So imagine in the face of like when we try to fine tune the model, and you will want to ask a labeler to annotate the answer, for example, question answer, and the labelers might know things that the model doesn't know. So that like so if the labeler if we teach the model to like generate responses based on the information that the labeler knows, but the model doesn't know. So we're essentially teaching the model to hallucinate, and it's just like really hard to correct. And like we can go actually I go more in my blog post, but we probably do not have time to unpack this in this talk. But feel free to reach out if you want to chat more about this. Another challenge is privacy. So it's challenging in both like whether you build or buy. So say if you want to build your own chat, say like if you want to let the users talk to your data, how to ensure that the chatbot doesn't accidentally reveal sensitive information. So here's an example. I didn't update it to the new one. But there is like it's a spot to jailbreak ChatGPT, and you can see a lot of examples like that. So companies like companies that provide APIs, like OpenAI or other companies, spend a lot of effort into making sure that like the answers do not accidentally reveal informations. But like if you build a chatbot in house, that is your responsibility. Need to make sure that you don't just accidentally reveal some PII. And then if you buy, then you have the whole challenge of like you have to depend on the AI providers compliance. So right now OpenAI like retains the data for 30 days, and it really depends on the industry whether it's acceptable to you or not. Another big challenge is context length. So I think we have a lot of discussions on like whether prompt engineering is gonna go away. So I would say as a way sees it is that like I don't think that context learning will ever go away, but there will certainly be there's certain hacks around prompt engineering that might not last. So the reason why context learning will never go away is because it's like a lot of conversations or questions as like very context dependent. So it's a very interesting study on the paper like situated QA, and they found it's like roughly like 16.5% of on the questions like require context. So for example, it might be asking just like what is the best restaurant, Chinese restaurant. So it's the context here might be very much dependent on like the locations, like where you're asking, is it in the world, in the US or in China, and like or if there's no context provided, what is the assumed context, like what could be the default context for the questions. So this is very common in like use cases like document processing, summarizations, and use cases that involves like genes or proteins. So here's you can see on the table there's some study on like the 90th percentile input length, and you can see that like for some use cases the context length can be like up to like hundreds of thousands of tokens. And I noticed there have been like a lot of studies to like making the model can work with long context length. However, there's still like questions about like, okay, a model might be able to take in 100,000 tokens as the input length, but how efficiently can that model use on this token? I think this is like still a open question. One thing that's like generative AI is that I'm really glad about is just like ChatGPT made everyone realize the importance of data drift, because we'll be asking question, it was like, oh, because our knowledge cutoff is like blah blah blah, that's why I cannot answer the questions. So so also the same paper for simulated keyword, I think it's a really good paper. And so the good showing is that like for the models that trained on data collected in the past, just fail to generalize to answering questions asked in the present, even when you provide the evidence in the context. So like the performance drop is about like 15%, and this is quite significant. And here I think we have a pretty interesting breakdown of like what kind of like how quickly things go outdated. So like from like 1 week, 6 months, 2 years, 50 years. Here's some example. So this leads us to the next challenge, which is like, so say like the model has drifted, the data have drifted because the world changes, right? And now we might have like the same model, new data, or another case when like there might be a new model architectures, a new tuning technique. So transformer architecture has been incredibly sticky, but how long is it gonna last? So in many cases, we're gonna have like new models. So imagine that you have a company that you are using a lot of prompts, and the prompts have been tested to work with the current model. So like if you swap out the model underneath, then how often, like how well can the prompt still work on the new model? And I think there's very little study around this area right now. And actually, it's pretty funny. I just saw, I think Hacker News a couple of days ago on the front page, so we were discussing this. Um, so another very big challenge is also like LM on the edge. So I see that's like there are like a lot of use cases when like users don't want to send data outside of the locations. For example, like in a lot of we will talk to a lot of healthcare companies who just have like a lot of different like medical centers, and you just like either because of the data is sensitive, you don't want to send a patient data, or just because of the many of these medical centers is located in the regions where the internet is not reliable. So like in the life and death situation, you just don't want to like make somebody else, someone's life depend on whether the internet's gonna go through or not. Also like autonomous vehicles, there are going to be a lot of cars on the road, and like each car may have its own like compute compute engines to be able to like run their own model, and so I drive through voice bot. And I do think that's like there's a very big dream that I see a lot of startups are trying to do, is like or build everyone a personal ChatGPT, so it can be trained on their own data and can run on their own MacBook. And the dream here is that if the LM runs on their own MacBooks, then you're not worried about like sharing with this or sensitive information, and it can be more open and it can be more helpful to you. However, for this, there would be a lot of like challenges as well. So, so first thing is like this model one has to be able to like run do inference on device. So the device has to be powerful enough to support the model's inference, and then maybe you can have some like a lot of techniques to like quantize or make the model run inference faster on the device. So another challenge is also like on term of like training. So it's one thing to do inference on device, but like how would you like update the model, because we have established that the world just changes. So so say like maybe there's a newer model training technique comes out, and it can improve the model performance, then how would we update each model on device. So on device trainings is like today's still bottleneck, but it really depends on the model size and model architecture. But a lot of it is like still bottlenecked by compute and memory and technology, like for continual learning and evaluations. And then if you train on servers and you go into like if you don't want to do inference on server due to like sensitivity, then how would you then you put it on into the same problem if you want to send data back to a server somewhere to train the model. And another thing is just like maybe like I have used a model, I have fine tuned it on a lot of my like data on device. So like if I somehow like update the model, the base model, how can if I have a new base model, how can I still like update how I do still like continue fine tuning this new model on the data I have generated in the past. So I think that there's a lot of I was at a panel recently and there was a questions on how is there a way to do like federated training, so learning, so that you can update a model on data on device without having to send the device back, and it's a very big challenge. So another question like choosing a model size. So I think it's related to on device because if it's a dream, it should eventually run a model on device. So we probably need to think carefully about whether how big the model should be. And I think that there are a lot of factors to consider as well when considering a model size. So I've seen that like there's usually a sweet spot between like a model performance and cost. And of course, I would say this like this changes over time a lot. And also, I just want to bring up a point about counting model parameters. So today we just like assume it's like 5 billion parameter, 10 billion parameter, and it's just like said is as in like the number of parameters is the only thing that matters. But I think it's like highly variant. So first of all, it also depends on whether a model is sparse or not. So like say like 100 billion 100 billion parameter sparse model is going to be very different from 100 million billion parameter dense model. So I haven't seen a lot of research about sparse and dense model in LM, but I would be very interested in learning more about that. So another things that I haven't seen people talking about as much is the LMs for non-English languages. So you can probably guess by now, through so much of my tongue twisting in this talk, is that I'm not a native speaker. So I'm from Vietnam, and one of the first thing I tried with ChatGPT was to use it for Vietnamese, and it didn't perform well at all. So one thing is that like when I try to translate generative AI into Vietnamese, it's actually translated it into reproductive AI. So there are many examples of like it's not doing well. So here I think it's a very interesting paper. Actually, there have been several papers on the study of like LM's performance on standardized tasks, but in different languages. And you can see that like it doesn't perform well for a lot of non-English languages, especially for low resource languages. Another big challenge is a tokenizations process. So here's a very interesting study by Yenny to show that the median token length for different languages on GPT-4, and you can see that like it's pretty bad for languages like for low resource languages like Burmese or Amharic. And so say like if the same for a given input, if the tokenizations that produce a lot of tokens that can affect both the latency and cost. So yeah, so I would be interested in seeing like how much of more cost and latency increase for different languages. Um, yeah, so a lot of APIs today charge people by the output token length. So like if a language just like have a lot of tokens, and the cost is clearly gonna be a lot higher. Another very interesting questions I have seen a lot of people discussing is the efficiency of chat as an interface, or more generally like of chat as a universal interface. I was meant for this to be more of a discussions, but I can't see you guys. So yeah, so so maybe answer in your head, which do you prefer, search interface or chat interface? So I see that people have been complaining, telling me this like, oh, they find the chat is not very efficient, right? So like if you want something, you have to like, oh, make a small talk. No, maybe not make small talk, but like you have to give it context, and you have to like go back and forth to get exactly what you're looking for. Whereas for search, you have learned the DSL of search, and you can just like find exactly what you're looking for. So I think it's like this is I do agree that I do think that like chat is not efficient, but I do think that it's a very very robust API. And the reason is just like for chat you can just like type in anything, and you get back a response. It might not be a very helpful response, but you get back something. Okay, this is probably going on a tangent here.
Chip, sorry, I think the stream might have stopped. I don't know if people missed out on it. I'm gonna see. Oh, so yeah, where we last saw you was on challenge number 5, data drift. And I am going to start the stream up again just to make sure that we're all good. But sorry about that.
No
And
worry.
I'm now on my phone, so we may have to do some in a minute. And
Wait, is that my
so,
internet? What happened?
no, it's all on my side. Don't worry. It's my internet went out. All right, it works. We can see. We can see. We can see, and people are back. They're back online. Cool.
Oh my god, people! I just said so many intelligent things on the spot. You just totally missed it.
No,
Um,
no, don't worry. I think everybody said it was fine and they saw it all. Okay, it was just me that went out. Oh, I'm
oh, okay.
overreacting, and so we're all good.
Oh
The chat is saying it was,
no!
yeah,
Just
they
kidding. I
saw.
didn't say that many intelligent things.
Yeah, so they heard it, they appreciate it. I'm gonna get off the stage before I continue to look like an idiot. I will say though that the Slido is not going to happen because I need you to grant me access to that.
Okay.
But we can do that during Q&A, and then we can do the Slido. All right, see you later. Go ahead. Sorry to break the flow.
Yeah, no worries, no worries. Okay, so I think let's talk about like chat is not efficient, but it's very robust. You can take in pretty much any input and give you back some output, even if the output is not that helpful. So yeah, so sorry, I see some Slack messages like we'll see everything. That's great. Cool. So yeah, so I think about like the tangent I was going into is evolutions, and if you look back, it's like it's not. So we have been saying it's like it's a survival of the fittest. But I don't think like humans are actually optimized for being efficient. Humans are actually optimized to be robust, and I think like survival is not of the fittest. I feel like I probably do not have time to go into this in detail, or but basically like there's a lot of discussion about like this is not what was really important is to have an interface that is robust. And I have seen actually so the discussion of chat as a universal interface is not new. It has been around, like you can see like this. Dan Grover has great discussions back in 2015, because like in China and a lot of countries in Asia, people are very very familiar with chat as a universal interface, and they do everything in chat. And also like there's a few studies that have seen, I can't name them because they are confidential, but basically people have studied like the how people prefer to search or the chat interface really depends on how much the users have been exposed to each interface. So for example, for a country where a lot of populations have not been exposed to like internet for a long time, they actually prefer the chat interface because it's just like feel more natural and easier to use. Okay, so the large challenge is big is a data bottleneck. So we have seen just like a lot of models use a ton of data, and it seems like there have been some study, for example, by DeepMind that shows that a lot of models, like a lot of data, is just still underutilized. So like the models still has the capacity to even learn from like even more data. So and we seem to be running out of like internet data. So this is very interesting study showing that the rate of training data set size growth is much faster than the rate of new data being generated. So at some point, I think this is marked as like 2026 that we will actually run out of publicly available data. And on top of that, like the internet is being rapidly populated with AI generated text. So there so if so for the future, if you crawl internet data to like train a new LLMs, it would likely be trained on like text generated by the existing um, LLMs. So yes, that's something like definitely a think about. So if anything that we have seen through generative AI is that data is very essential to to any companies that want to leverage AI. And we have seen like over the last since AI came around, 70 years ago, there have been many hype cycles. So maybe today is like generative AI is a hype, but we do not know like in the future what is gonna be the next new hype. So one thing that consistent through on this is data. Like data is just very important. So we see that a lot of companies in the face of generative AI, the first thing they do is to like figure out the data story, like consolidate existing data across departments and sources. When I update like data terms of use, you can see like Stack Overflow and Reddit responded pretty fast, but like not fast enough. Like just maybe they could have done it like years ago. Or like put guardrails that are data quality and governance. So yes, that is pretty much it. And here is a summary of all these challenges. And do reach out if you have any questions. I'm on LinkedIn, Twitter. I'm also on Discord all the time, and I have a book. But yeah, that is for me.
Awesome. A lot of people were saying that they had your book and they loved it. And I wholeheartedly agree. I think it is amazing. And I always wonder how you're able to write so much and also run a company. It is amazing to me. It's super cool. So I think there's going to be some questions coming through in the chat. I don't want to cut you off because of my little interlude, and I want to let people do it. Luckily, I learned the first time that we had this conference, there is a little bit of cushion now on the brakes, so we can have more flexibility when it comes to the timing. All right,
Yep.
so I can ask you some questions, and also in the meantime, do you want to give me access to that Slido and
Oh,
while you're answering the question?
I don't have a
Or
Slido.
no,
Uh,
no, sorry. You give me access to the
Slides.
document. Yeah, the
Yeah.
slides. And also, people were asking about the slides and if the slides are going to be anywhere. So, yes, we are most definitely going to have the slides for
Yeah.
everyone to check out. And we will throw those in the recording, right in the description of the recording once it's out.
Yeah.
So while there are questions coming through, who's got questions in the chat? Feel free to. Oh, somebody's asking if there's going to be a next edition of the book.
Perhaps. Yeah.
Uh,
Oh my God, I was so sorry. I think this is a new talk. I got so nervous about going after Mate that I was like couldn't sleep last night. I was like, I need to come up with something. Yeah. Sorry for. And I
well,
was like, what happens when I don't get enough sleep? You just do not speak very well. Somehow like on this like immigrant side in me just came out when I do not sleep. So
it was perfect. And I thought it was funny, the idea of drinking coffee beforehand. The other thing is,
yeah.
I mean, you did mention in the talk, in the part um, that I was on for because I got kicked off and thought everyone got kicked off for a little bit and was afraid like, oh, the conference stopped. But I saw that you were talking about how there's not, what was it? There's not models that are useful in other languages, and especially like the languages that are less spoken or that have less speakers of the languages. It's much harder to find LLMs that are useful with
I
them.
think I want to correct that. So
Yeah, you
so I
tell me.
think it's not proportional. So there are languages that have a lot of speakers, but they're not represented equally in the corpus of like training data. So for example, there are languages with like hundreds of millions of speakers, but they account for like what under 1% of like or like sorry like 0.0 some percent in like say common core corpus. So yeah.
I see. I
Yeah.
see. Okay, good. Well, should we get into some questions, Chip? You want to hear
Yeah.
what the chat has to say?
Yeah,
Um,
but then so just want to follow on the like non-English
yeah, yeah.
models.
Go, go, go.
Yeah, I noticed like so I typically just like I think it's like I like to go on a tangent. I see this like the evolutions of like language model, right? So you start going from like what both architecture wise like methods wise. So we went from like counting method to like neural network. So we went from like single task to like multiple task, right? Like with like single task before we had one model to like do machine translations, another do sentiment analysis, and now we have like models as generalized to like multiple tasks. And there's a send another access actually like go from like a model for each language to like a model for like multiple languages. So I think it's very funny to say like a language model and not languages model. It's like a language here is singular. As I was trying to write about like language modeling, it's really hard to say, okay, this is a model to model language or like languages, because it's somehow it's like made everything is like one single language that LM can understand. So
Mm.
yeah, but it doesn't understand some language as well as other. And I see a lot of
Mhm.
countries are showing working really hard to build language models that work very well for that language for their language.
Yeah, it's super. See, somebody was asking if you know any projects that are going on in that field.
Oh, I think Japan is very big on that. I think Japan is like make this like a government priority. Vietnam. So I'm from Vietnam, so I'm more aware of the effort there. I think they're like if you're Vietnamese, you should certainly check out. Um, ping me. There have been a very big push both by companies and like open source community in Vietnam.
Hmm. And have you tried LLMs for annotating articles? What do you think about that, if you have?
Entertaining article. What does it mean?
Yeah, like I think it's annotating data basically from articles, like newspaper articles or stuff like that.
Like to summarize articles or fact check?
I think it's for the actual like data labeling. That's what I understand from the question. But John
Oh yeah,
Roberts
like
asked the question. Feel free to put more context around that if I'm not saying it correctly.
yeah. So you
Yeah,
mean
yeah,
like
go
to
ahead.
like synthesize data? Is this about data synthesis?
Yeah, I think so. I guess from what I gather from the question, so this is the question word for word, and then I'll tell you how I interpret it, and then you can go ahead and interpret
Yeah,
it however you want to. Have you
yeah.
tried LLM for annotating articles? What do you think about that? And the way that I interpret it is that it's like you're using LLMs to data label for your data labeling for training later another model.
Yeah. I think that's pretty common. I think like there's a whole. I think it's like knowledge distillation. There's a whole premise behind the alpaca, right? Like you use a large, better model to like generate output, and then you make smaller model to just like copy that behavior. So I think see that's a lot. I,
Cool.
I,
So now we've got some,
No, I think it's funny because I was talking to a friend about I was asking him like how do you think about the future of like prompt engineering? And he was like prompt engineering matters as long as human to human communication matters, right? Because it's just like for human human communication sometimes we still need to put in a lot of context for like the other person to understand. So the same thing with prompt engineering is like the matter of like putting in things so that like LM can understand.
awesome. So we have a panel coming up, but there are some incredible questions that are coming through the chat. Now it generally happens like that, right? It gets a little bit delayed and then people are typing. And so then it's a little bit even more delayed, but I want to ask these questions because they are awesome. Do you think that LLM developers are cooperating adequately with experts from other disciplines such as linguistics, sociology, and ethics?
That is like a very big question. So how would we measure that?
Yeah. That-
So I do think
they
it's
were asking me, not me.
I mean, like NLP is an example of like how different disciplines came together, right? Like linguistics and computational, science, computational scientist. So if you look at the history of like NLP, it is not, it's definitely like already like the merit of like statistics, computer scientists, and linguistics. So it's a very incredible, fascinating field, and I could see that like these adoptions in like other fields as well. So I think I'm very excited for like gene sequencing, right? People are treating it like language model, and I can see that's like if we can bring a lot of like life science scientists, it could be pretty cool.
Yeah, completely agree. So there's all kinds of other incredible questions that came through the chat. And Chip, you have the link to the chat, I think, so you can jump over there. Also, Chip is in Slack, in the MLOps community Slack. And if anyone wants to ask any questions to her, just tag her in the community conference channel if you're in there and you want to start a thread. And I think that's it. Chip, I'll see you in a few weeks for the first time,
Oh
right?
my God, yes! I cannot wait for it. I don't know why, but like whenever I see Demetrius, you just seem so much fun. You just seem like a fun person to party.
Uh-oh. Those are some
He's
big shoes
big,
to
yes,
fill.
yes.
I got lots of expectations. I don't like to keep it up here. Let's lower the bar, please.
Better start practicing the dance moves. Okay, see ya.
Yeah. All right. See you, Chip. Thanks for
Thank
this.
you.
This was awesome. All right. And we're going to keep on cruising because now we've got a panel coming up all about evaluation. So I'm going to bring our host with the most onto the stage. Abby, how's it going?
Hey, what's up?
I am excited for this panel that you are going to lead right now. And before we jump on and do the full panel, I just wanted everyone to know that Abby's like one of our most frequented co-hosts on the MLOps Community Podcast. So if anyone wants to check out the podcast that we do, there is a QR code. Go ahead and take a shot of that, a snapshot, or just scan it, and you will see all the different podcast episodes that we have. Abby, if I had to put you on the spot and say your favorite podcast that we have recorded, which one would it be?
I think I'll have a hard time picking from two. One is by Alex Ratner from Snorkel, and the other is from two people I'm very good friends with now, which is Maria and Bashak.
That one just came out. So
Yeah.
if anyone wants to check out, they had this really cool MLOps framework and maturity assessment test that you can do if you are wondering where you're at with ML in your organization. They talked in depth about that in one of the most recent episodes. So I'll leave a link to that in the chat and let everyone dig in. That was a really good one, I must say. And so I just want to mention too, because there was a few technical difficulties. In case anyone cannot see or your stream got paused, like my stream did, just go ahead and refresh and it should normal, hopefully. And if it's not getting back to normal, let us know in the chat so we can troubleshoot. But you should be good. Now let's bring on the rest of the guests. First up, Josh Tobin is here with us, Mr. Full Stack and Deep Learning, and also the surprise guest of our in-person workshop that is going on in San Francisco later today. So it's good to have you here, man. I'm glad that we are getting to do this and this is happening. We've also got Sohini Roy coming up. Hello. And this is where I get to say the last person, then Abby, I'm handing it over to you to take over, all right? And where's Amrutha, you there? Yes, there it is. Okay, so now there's too many people on the stage. I will remove myself and let you all take it from here.
Okay, hi everyone.
Hello.
Well, so very quick intro for Josh, Amrutha, as well as Sohini. Josh is the founder and CEO of Gentry. They're working on tools to analyze, explore, and visualize. And so you can improve your models using Gentry. They have an SDK that is available. Amrutha is the CEO and co-founder of Structured.io. They're building their engineering tools for LLMs, so everything from your ingestion to your data processing pipelines, they've got you covered. Sohini is the Senior Developer Relations Manager at NVIDIA. And there's a lot to mention about her. She's been very active in the MLOps as well as LLMOps community, where one of the things we want to talk about today is the open source toolkit that they've recently released. NEMO guardrails at NVIDIA, or any more work that they haven't released on LLM-based conversational systems. So I want to start with all of you first, because you've been in the space for quite a while, all of you, from ML to now in LLMs. How do you think, but also because now you have a company in this space, plus you're leading in for Amruta, for Sohini specifically, you're talking to a lot of enterprise companies right now. How do you think about evaluations at your company?
Ooh, who goes first?
So Josh, Sohini, Amruta in that series.
Beautiful. Will the expert talk first?
Yeah, I have a lot to say on this. I mean, should I just do my whole thing, or I can do the short version? Yeah, I think for those of you who have been in the ML world pre-LLMs, there's kind of a way of thinking about evaluation that we're used to, which is based on the fact that in the pre-LLM world, most of the time, the project that we're working on starts by building a data set. And most of the time, since we're training a model, we have a clear objective function that we're trying to optimize on that data set. And so that makes a naive pass at evaluation really easy, because it's like, okay, you hold out some data from your training set, you use the same metric that you are training the model on, and that gives you an evaluation of how your model is doing. Now, that hides a lot of complexity under the rug, but I think moving to generative AI and LLMs, some of those assumptions are violated, and that's, I think, what's making this so difficult for a lot of companies to figure out. So first of all, when I start an LLM project, I usually don't start by building a data set. I usually start by thinking of what I want this thing to do, and then just coming up with a prompt to try to encourage it to have that behavior. And so that means that one of the key challenges for evaluating LLMs is what data do we even evaluate them on? How do we know what the right data set is to test these models on? And then the second question comes from, or the second challenge comes from violating the other assumption that we have in traditional ML, which is that oftentimes in generative ML, we don't have a clear objective function, right? Like, let's say that you're building a summarization model. How do you measure whether two summaries of the same document, whether one is better than the other, or whether one is adequate? It's really not an obvious question. And so those two challenges, I think, are at the core of what makes this really difficult for a lot of companies. And I'll pause there, and I think there's a framework that you can use to think through how to do this well. But I'll save that maybe for a later question.
Oh man, what a cliffhanger on that. I would say there's so many things to think about when it comes to evaluation. I agree that thinking with the end in mind first. That's definitely what we got our clients to do. Similar to what Josh was saying. But also it's really tough when you're creating something for such a generalized environment. I think a good example of where this was interesting. Actually, you know what? We'll pause on the example because I think that'll be helpful later. But just coming back to more broadly, what do I think about evaluation? I think ultimately it comes to accuracy and speed, right? But accuracy is so dependent on what the actual goals are. Thinking about, I guess, more detailed questions. Is it helpful? Does the model actually do what you instructed it to do? And when it comes to accuracy, does the model actually answer something correctly? Is it coherent? Those are two very different ways of measuring, how accurate, how well, things are set up. I think hallucinations is another really important thing to be considering. So do the model make up any part of the response? How are you putting controls in for that? Are they deviating? Another part I think is context. So does the model actually remember what you're talking about? Are you staying on topic? And I think also for my particular realm, when we talk about the framework, NEMO guardrails, which I'm sure we can get into in a little bit for how it can actually support, but is it safe? Is it secret? Kind of like when Gandalf shakes Frodo, that's kind of what I keep reminding my clients. Are we, is it secret? Is it and is it safe? Are we going to execute malicious code? Is it going to call an external application? Is the data set robust enough to prevent individual identifications, especially when thinking about healthcare and privacy codes, toxicity bias? I mean, there's so many different factors, but if you really had to sum it up to the top two, is it accurate and what's the speed? and latency for it. But so much to talk about. This is a really great session. Amrita, what do you think?
Great answer. So one thing I always think about is when you're doing evaluation for, let's say like a classifier, there's also some notion of like what ground truth looks like, what a correct answer looks like. If you're building a classifier of like, oh, cat versus dog or red versus blue, like there's a ground truth that you can always operate from and like evaluate against. I think with LLMs, one thing that I notice is because everything is so qualitative, even from person to person, like thinking about what does a good answer look like, what does a bad answer look like, what is the expected length, how concise should it be, what kind of tone should it have. There are like I think attributes of like what a good answer looks like, and that varies from like based on the expectation of the user of the model. So I feel like there's an opportunity to build an evaluation mechanism that is highly personalized, and I think the primitives of how to build that are things that are still up in the air right now, and really excited to find that.
So I think I really love the collective perspective here, but I wanna ask you more so about how do we think about that perspective for different companies? So right now there are two different kinds of interest groups when it comes to large language models. The first are the model builders, and the second are the people who are developers who are building their own application on top of these large language models. What would an ideal performance mean for both of those interest groups, and how do you decide how to think about building an evaluation framework when you're probably on each of those sides?
Yeah, I mean, I think one thing that you're pointing out is one big change that I've seen in the industry in the last 6 months or so is call it the ChatGPT effect, right? So in the old world, the olden days, back before many of you, even ML was even a twinkle in your eye. Machine learning projects were these like just really technically complex, high effort projects in most companies, right? Like I personally don't know of any examples in large companies where a deep learning project took less than, call it 6 months, and most of them took more than a year. Now, in the post-ChatGPT world, all of these companies, like you see these announcements every week or every couple of weeks from companies that are announcing their, ChatGPT powered feature. And if you talk to these folks, the amazing thing is a lot of these products were built in like weeks, like 3-4 weeks. So you ask yourself, like, how does that happen? And the answer, unfortunately, for those of us on the ML side of the house is the reason why they ship those things so quickly is because the ML people on the team didn't build them. It was the software engineers that built them. And that's not to say that ML folks don't have a role to play going forward. I think actually evaluation is one of the critical places where ML folks have a role to play. But what ChatGPT did is it really kind of lowered the barrier to entry, and also I think what's really critical is like the level of intimidation that most folks in the org have about interacting with these systems. So if you're like an exec in a company and you're sponsoring a deep learning project, you kind of like hire the nerds, the PhDs, and you let them do their thing for 6 months and you hope that something good comes out of it. But now if you're building like a ChatGPT project, you've been playing around with ChatGPT on your own. You know that it's not that difficult to get it to do what you want to do. And so what we're seeing is that a lot of folks in non-technical roles are a lot more involved in the process of building these applications than they were 6 months or a year ago. And so the implication that has for evaluation, I think, is actually really positive, which is that one of the key things for evaluating LLM-based applications is that it's I think the thing that we need to find as an industry is the right mix between automated and human-based evaluation. But the great thing about having more stakeholders involved is that you can involve those stakeholders in the process in such a way that they are helping you progressively evaluate the quality of your model as they go. And so I think, I really see like the non-technical stakeholders, sometimes are actually doing a lot of development in prompt engineering sense, but they're also like the producers of evaluations, and then the technical folks are more the consumers.
100%. I mean, like I think that's a really great to think that it. The line is also, I think, for domain specific information, like grabbing people who've been in the industry or for that particular domain for 20, 25 years, right? And bringing that information and layering and sitting down with, software engineers, ML engineers, and actually layering that in. It's a delicate balance, I think, again, between human evaluation and automated evaluation. It's an interesting question. I have to mull a little bit on that. I don't know, Amrita, any other things to add? Josh, it's so great that you're going first. I feel like you're getting the right framework in for us.
Yeah, I don't think I have too much to add on that one.
Yeah, I think that was a very, very comprehensive answer, I'll say, which is basically like, I guess it depends, which is most of this, at least my personal experience has been talking to a couple of companies, is none of the large language models, at least at big companies, have been deployed in production. We're not really talking about OpenAI. We're not talking about Google and all of those companies, but let's say about banks, which were huge when it came to financial modeling and as such, or were the adopters for machine learning models and as such. And it's great that we have reduced that time for everybody to get started and have more stakeholders, because that was one of the problems with machine learning, which is like bringing everybody together on a single table and say, let's assess what you really want out of this model. So my second question here is, we're seeing so many evaluation benchmarks right now, from Helm to to a couple of others, and there are so many leaderboards that are available. How do we create stable experimental setups to be able to evaluate and monitor the accuracy of our applications during and post deployment, LLM-based applications during and post deployment?
Maybe I can kick off on that one. So one thing I often think about is, how do you, like, anytime you have an experimental setup, you want to keep all the variables the same as much as possible. And I think, like, in this case, like having like a set of prompts that you test against and benchmark against on like a continuous basis is like super important. So one thing we've noticed, even from experimentation that we've done at our company, is you can put the same input into like GPT 3.5 Turbo, like, and it gives you a different answer like 1 hour later versus like 1 hour before. And I think that, there's like a lot of reasons for that, and it's like not like deterministic in the way that it answers. And so it's the outputs are, they're going to be different even if you have the same inputs. But I think that, like, if you do a qualitative evaluation where you keep the inputs as stable as possible, and like maybe have like some sampling and ongoing measurement of the system health, and like perhaps alerts if it like drops too low, you can turn this into like a observability problem as well in a lot of ways. And I think that building those kinds of systems will help, like help us respond when the quality of the output goes bad.
Yeah, I totally agree with that. I mean, not to do the founder thing, but that's definitely one of the things we're betting on at Gantry is observability playing a key role here. But one thing I would want to add is, I think if your role is a researcher, then or if you're in a really early stage of a project where you're kind of deciding what model to choose, then public benchmarks are helpful. I tend to prefer the sort of ELO-based benchmarks. I think they correlate a little bit better with my subjective experience of interacting with models and how they seem to perform. But if your job is not a researcher or prototyping something, but your job is building an application with language models, then you should not rely on public benchmarks. Like, they are basically almost the equivalent of useless for you in that role. And the reason for that is they are not evaluating the model on the data that your users care about, and they're not measuring the outcomes that your users care about, right? And so if you think about like measurements in machine learning in general, there's kind of like, I think of it as like a pyramid of usefulness versus ease of measurement. The most useful signal that you can always look at is outcomes, right? Like, is this machine learning is the system that this model is part of. Is that solving the problem for your end users? Difficult thing to measure, but really, really valuable to measure. And then, easier to measure, but less useful than that are things like, hey, are there proxies that we can look at, like, accuracy, or asking another language model if the output of this language model is good, that correlate with the metric that we ultimately care about. And then all the way at the bottom of this pyramid, really easy, really accessible, super low hanging fruit, but not very useful, is like looking at publicly available benchmarks. You're just not really going to learn that much about your task by doing that.
Yeah, my 2 cents, like Amrita said, standardization is king when it comes to this kind of thing. Automated testing, I think, setting up monitoring systems and those custom dashboards through that observability stack, I think is getting really exciting. I've seen a lot of really interesting tools that are doing this really well. I'm actually curious to dive a little bit more into Gantry's response to this as well. But I know Fiddler, shout out to Arise. I think their CEO or CPO is doing a presentation on this later. I think their stuff is really interesting. Hugging Face also did some custom evaluation metrics that I think make it much easier for the proper setup and making sure you're standardizing and evaluating consistently throughout. I think, Josh, you mentioned earlier doing user human feedback for iterative development ongoing, I think is going to be continuing to important for how we set up the evaluation and monitoring the accuracy long term. But you're right. I think those public standard benchmarks is probably the base, and then continuing to evaluate and use your own metrics will be super important. Yeah.
So one of the questions I wanted to ask you, because we're going into the domain of talking about, we need to have very domain-specific, company-specific benchmarks. What are the popular use cases for large language models that you've seen in production right now?
I think one example that might come to mind is, I think, Google's, I don't know, is it PaLM, MedPaLM, PaLM, however they choose to say it. They released their second version, I think, back in April, and it's a really interesting case study on how to develop something that's very domain specific, because I like it because it's very much designed for purpose. I think Josh said in the beginning about how do you design the prompts and the testing data appropriately for the outcome in mind, right? How do you design for the end goal in mind? They used data sets that were in Q&A form, that were long and short answer form. The inputs were, search queries for biomedical scientific literature and robust medical knowledge. So that was actually a really, really great example of a good foundation. But I think they had metrics that also aligned, and they tested it against, I think, the US medical licensing questions as their metrics for actually determining is it successful. But in addition to that, what I liked is they reached out for human feedback, not only from clinicians to answer the accuracy of the specific responses, but also from non-clinicians from a range of backgrounds, tons of different countries and languages, to make sure the information that was coming out was accessible and something reasonable. And I think that's actually, everyone's gone on a Google spiral asking medical questions. So I think it was actually very relatable, and the results were really phenomenal in their ability and the results to answer those medical specific questions in a strong way. I hope I've kind of dug into that, but I think that's one particular example where I think that was done really well. I think another one is actually the Bloomberg GPT. I don't know if that's being done out in production, but I think as far as domain specific benchmarking and assessments for financial specific questions, that one was a really strong example.
I think the use cases that I found really compelling are in like the customer success and customer response categories. And I think like it's one of those things where being able to respond to your users quickly is like a huge win for companies, and being able to scale like customer interfacing roles is like a big challenge and can be expensive. But I think with LLMs you have like an opportunity to really like leverage like knowledge bases that you might have and expose that in a way that can like, you know, enable your customers to like interact with your product in a more meaningful way. And I think that's really powerful. There's also like a really good built-in way to evaluate the quality of responses here, because you can just ask the user like, oh, did this solve your problem for you? And you can also look at like you know, other metrics like, oh, how often are they coming back, like how many messages did it take to resolve this issue. And there are like a lot of really great ways to kind of proxy the quality of the responses, and so I think that's a good one.
Josh, you want to add on that?
I mean, how can you, right? Sorry, he might be frozen.
I think Josh got frozen, but in the
Stunned in
meantime,
silence. I know.
Am I having a connection issue?
By the way,
no, he can move. He can move.
Okay. Yeah. my internet
Josh,
is,
we were asking if you want to add on that.
No, I mean, I think there's kind of like in terms of real use cases, there's trifecta. It's like information retrieval, search, question. You know, one category, information retrieval. So it's things like search, document question answering, things like that. Then second category is chat. So a lot of companies are building sort of chatbots into their products. Use cases like customer support, product features. And then the third is yeah, like text generation, sort of marketing, copy type use cases. Those are the three that we see the most.
Which one do you think is like most robust right now, or is doing like meeting the needs like the best right now?
I'm
asking because I get asked this all the time, and I
Yeah,
never.
it depends, right? Like it's for all of these, there's such a range of complexity, right? It's like really easy to just kind of dump, you know, ChatGPT API into your product and call it a chat app. But then how well do you actually need it to work for it to be useful? It depends a lot on the context of your product and what you're trying to get it to solve. So I would say all of them are relatively usable, depending on the broader product context. And I think this is kind of like a general point on how to think about machine learning applications in general is like, I don't think I just made the mistake that I don't encourage other people to make, which is like, I don't think makes sense to think of ML use cases grouped by like technical use cases. It's really, you should think about them in terms of product use cases, because that has a lot more of a role in determining the difficulty and challenges that you're going to face when you're building this application than, you know, what model you're using or what set of techniques you're using to glue models together. Because ultimately, at the end of the day, like things that make the thing that makes building products with ML hard is that machine learning models don't always get the answer right. That's always been true. It'll always be true. It's the nature of the technology. It's probabilistic, right? So it's not always going to be right. And so the question is like, how do you build a product in the context where, you know, one of the components of your product is going to get the answer wrong? Like, you know that it's going to get the answer wrong. And so the broader product context of like, what does it take to actually work around that limitation is more important for the difficulty of the project than what set of algorithms you're using.
I really like the way you said that. Yeah.
Yeah.
No, go ahead.
One of the things I also wanted us to touch upon, maybe probably the last question that we'll get before we open up the panel to audience Q&A, is as you're building the model, you need lots of data, and all the data may not be good. There are techniques like early stopping to be able to filter the right kind of data sets. And after that, yes, you've built your model, you're now trying to deploy it, but you're also putting some checkpoints and doing some sort of logging as well throughout the process. How do you guys think about evaluating the performance at those specific points? What tools have you seen being used, and what are the gaps that you've seen in terms of the tooling industry? when it comes to Ruta, for you very specifically, when it comes to datasets, what are the gaps that you've seen? And Josh and Sohini, for both of you, I want to understand more so from like the perspective of the model checkpointing itself, as well as the prompt, as well as like the prompt drifts and stuff. So I'll let Amruta go first. Let her cover the data side of things, and then we cover the model side of things.
Yeah, absolutely. So in terms of like data set quality, it definitely makes a really big difference. I think a lot of systems are very garbage in, garbage out, and like, if you start off with like a bad like baseline, you're going to be kind of disappointed with the results. And I think like oftentimes like curating the data set itself is like a really big challenge. I think like sometimes like having like rules or heuristics about like, oh, like this is like understanding your data set, like, okay, this is like the missing data, the quality of the data, like this is what's incomplete, this is what's perhaps inaccurate or not in the same form as like the rest of the data. I think like some standard data set cleaning techniques make a big difference, but then I think also curation makes a big difference. I think with a lot of these problems, like what you are looking for, you like hypothetically wouldn't really need a model as well. Like if you could define like that with words perfectly, it would be difficult to, you wouldn't really need a model to do that. It could just be like a bunch of if statements. So, you're kind of dealing with like ambiguity around what you're looking for. And so there's also ambiguity around that like curation of that data set. And so I think it's like actually an iterative process. And so like the evaluation isn't really like a one-time thing, but it's something that you have to iterate on and like try to find over time as well. Not sure if that was like fully what you're looking for, but just general thoughts in that space.
Yeah, I think that does answer. Josh, do you want to add on top of that and go into the model side of things?
Yeah, I think I'll take a slightly different position. I think I totally agree with what you're saying, Amrutha, if we're talking about machine learning, but this is the LLMs conference. And so my strong contention is if we're talking about LLMs, most of you, like most of the people in this room right now, you should not be thinking about training a model. There is very low likelihood that you're going to get better performance on an NLP task by training a model than you will by prompting GPT-4. That's just, that's unfortunately just the truth. It's a new world that we're living in. Like we've talked to like many companies at this point that had kind of ongoing NLP projects, 6-month projects, 9-month projects, year-long projects that they're able to beat their performance by switching over to large language models, calling an API, doing some prompt engineering, maybe some like few shot in context learning in a matter of weeks, right? So I think if your goal is to build products with machine learning, especially with NLP, then I think the rule of thumb is like no training models until product market fit. Like if you haven't built this thing out and demonstrated this thing can be really good using models that you can get off the shelf for NLP, then it's not going to work. Like you're not going to be able to do better by training your own model. For other domains of ML, I would have a very different answer to that question. And then on the tooling side, I think, yeah, you should just come talk to Gantry. We've got good solutions for all the problems that you just described.
Tell us about it. Give the pitch.
Yeah, I mean, the pitch is, I think the way that machine learning evolved is like, there's so much focus on training models. And our thesis kind of from the beginning, and I think this is doubly true in the LLM world, is that training models is not the hard part anymore. The hard part is you have this model, you've trained it, and you've gotten over the hump of like, the statistic that like every MLOps company used to say of like 85% of models never make it to production, which is like a BS statistic. And it's definitely not true if it ever was true, but you've gotten over that hump, you've gotten this model into production. That's when the hard part actually starts, right? Which is like, okay, how do we know if this thing's actually working? How do we know if it's solving the problem for our users? How do we maintain it, right? Like I think really common issue is, as you start to scale out the number of models per ML engineer or per data scientist on your team, the percentage of time that ML engineers spend on maintenance increases and can, quickly dwarf the amount of time that they're spending on actually building new features. And then lastly, even if you have models up and running in production and you're maintaining them, you're leaving a lot of performance on the table if that's all you're doing. Because if you think about like what distinguishes really great machine learning powered products from average ones, it's like if you look at like ChatGPT or Tesla or things like that, the thing that they all have in common is that they're maniacal about building this loop around the model building process that involves like looking at outcomes, looking at user feedback, feeding that back into the training process, right? So if you're not doing that, your machine learning powered product is just not going to be great. It could be okay, it could solve the problem, but it's not going to be great. And so what Gantry does is we basically have infrastructure, like an infrastructure layer that supports opinionated set of workflows that teams of folks working on machine learning powered products can use to collaborate on this process of taking a model that's been deployed and using production data to maintain it and to make it better over time. And so we make that a lot cheaper, easier, and more effective for machine learning teams to do together.
Sohini?
It's hard to follow that. I mean, longtime fan of Gantry, longtime fan of your blog series. So it's kind of nice to hear your perspective on it. I think for me, for tool sets, I know there are a couple of ones about prompt engineering that are coming out. I have to play with them a little bit more to know which ones are the most effective. I'm getting an inkling on which one's going to be the best. But I think from the NVIDIA standpoint, obviously we talk about guardrails a lot. It's our new open source framework that came out. We talk about, I mentioned a little bit, like how do we make sure that even if the data in, data out problem is already, something that we're gonna, it's challenging, right? But I think if you create the right guardrails for it, so making sure that we stay on topic, making sure that, when someone asks a chatbot about your product different offerings, are you going to go and talk about competitor offerings instead of your own, right? Also making sure that you've got, I talked a little bit about like secrets and malicious code and management of external application access and interactions with, to leading to misinformation and toxic responses and inappropriate content. That's all something that we're all going to have to work through. I think guardrails will get you part of the way there. I think we're still experimenting with kind of some other tooling that can help with the rest of it. But definitely, I would say check it out. It's open source. Nemo is open source. I think it might, supplement a lot of the other tools that kind of were mentioned today. I can't see any of the questions, by the way, Abby, so we're gonna have to trust you to.
So I have one question. I think that's probably I don't know, Demetrius is here. Are you going to kick us off, or can we ask
I'm gonna start playing the music.
Can I make a plug for this workshop I'm doing tomorrow? Yes,
do it. And then
so doing like a hands-on workshop for a full hour on this exact topic. So if folks want to learn more about it or chat more about it, I'll be there tomorrow at some time in the morning, PST. I don't remember what time, but it's on the schedule.
It's gonna be really cool. Can't wait.
So, as much as I would love to continue this panel, I sadly have to cut it off because we are running short on time, and as you know, that is my one job. It's to keep us on time. And so I loved everything you all were saying, and there was a ton of questions in the chat that were coming through. So all of the panelists, it would be awesome if you jump in the chat, respond to some of these questions that came through, and I will leave it here and get you all out of here, but ask you to stick around and say a few things in the chat. Now, let's see, kicking you all off. Thank you. I mean, I did not say thank you, but I am very thankful that you are all here with us. I am just also going to stop. So the reason I had to kick them off right now and use this time is that I need to take 2 minutes to restart this stream and change my internet because my internet went out and I think it messed up my stream. And so I just want to take a minute the stream's gonna keep going. Everything should be fine. I'm gonna put some music on, and then I'm going to play some music when I get back. So I'll restart my stream. Everything, you shouldn't even notice anything. But when I get back, I'm gonna play some music. I got my guitar here, and I am actually going to ask the chat, because you all have been so vocal, let us know in a specific key. Which key should I play in? All right, so I'll be right back, and then I will hopefully have a key that you all want me to play in, and we'll start rocking. And also, give me some prompts. What should I sing about? This is gonna be fully improvised song right now, and I cannot guarantee the quality, but it is going to be improvised. That's the only thing that I can guarantee. So give me some prompts. I will sing about what you are talking about and asking me to sing about. Here we go. Give me 2 seconds. I'll be right back. Let's go. I think I'm back on. I think the stream is working. Let's see. Hopefully you can see me. Yes, I'm getting some yeses in the chat. Sweet. So that worked. Yes, I love it when it works. I love it when it happens. Okay. I'm also getting some, oh man, this is good. I'm getting some stuff going on in the chat. All right, and we're gonna sing a song about GPT writing songs about LLMs, or yes, catastrophic forgetting. I can't get you out of my mind. That is what we are going to sing about right now. And then I'll bring Sam on, and I am going to have him give his talk. So let's just get a time check. I've got 2 minutes for the catastrophic forgetting song, and then we're gonna get going. And oh, by the way, Amsterdam is in the house. Let's see, Amsterdam, what's up? So cool to see that this is happening right there. Look at that. Amsterdam going off at the live meetup in Amsterdam. And I'm bringing them off, and I'm going to say, Sam, yeah, your slides are sharing. I see that they are here. You're all good. Let me sing you this catastrophic forgetting song. Can you give me a nod, Sam, if you can hear the guitar? Give me the nod. All right. Oh boy. Catastrophic forgetting. It's all I think about. All I think about is you. But I cannot forget exactly who you are. This is a catastrophe. Because you have forgotten me. And I cannot forget you. Let's let what will be. And it is catastrophic forgetting. You have forgotten me. I can't think of another time when I wanted to forget thee. You are the love of my life, they say, but I cannot get you out of my mind. Forgetting me, just forgetting me, forgetting me. It's catastrophically, you're forgetting all about me. I cannot see, I cannot believe. Why does this got to be right now? I don't know if I can handle it. Sadly, I have been forgotten. And not in the good GDPR type of way. Not in that way. It's you that's forgotten me. It is you that has forgotten me. Catastrophically, I cannot believe it. If you were more than just a machine learning model, trained with billions or trillions of parameters, I might actually want to know what is going on. That song is called Catastrophic Forgetting, and whoever gave the title for that, you need to reach out to me and get John Russell. Reach out to me. I got a ton of swag for you. I've got so much swag, and I realize I have not been a proper MC host for you all. There's so much swag that I need to give away, and because of technical difficulties, I've been forgetting to do that. So now, what I am going to do is I'm going to give away some swag before I bring on my man Sam. Let's just say that, I mean, Mert, you've been awesome in the chat. I've been seeing your name. Reach out to me, man. Neve, also, reach out to me. I got swag for you. And Sterling, I saw your questions. Let's get it. Get some swag. Reach out. Bruno, you are complimenting my ego. Reach out to me. I got swag for you. That's right. Avocados all the way. And then there was some, Angelica, thank you for being so participatory in the chat and in Slack. Reach out to me. Got swag for you. And that's it. That is, I think, all of the swag that I'm going to give out right now. But don't worry, it's going to be a long day. And there's a lot of swag to give out. So if you didn't get this time around, I'm probably going to randomly give it out to you next time around if you are active in the chat or in Slack. All that good stuff. Now, wait a minute. What is this? What's going on here? Uh-oh. Excuse me. Do you guys know who Sam Party is? Anybody? Anybody? No? Dude, they don't know you. They don't know you. What is going on, Mr. Party? They don't know you. Uh-oh. I can't hear you, though. Uh-oh. I think Mr. Party... I'm not sure if it's my side or...
How am I supposed to call
go.
you? How am I supposed to call you? That just... It's impossible to go after you in anything. You're just...
The good thing
what
is,
am I supposed to do here?
The best part is that I'm not sharing the top quality vector database content like you're about to bring. So I think people came more for the vector store talks than they did for the random LLM improvised songs. But, you know, both of them together make a nice little sandwich.
Hey, well, look, it's going to be some good content. It's going to be a little bit more advanced than the last one. So if you didn't see the last one, definitely go check out the last one. It's going to fill in some blanks.
There we go. But before I share your screen, I just want to make sure that you saw this. Excuse me. Do you guys know who Sam Party is? Anybody? Anybody? No? Why do they not know you, Sam? I don't get it.
It's because I'm known. I'm irrelevant. That's
gonna change right now because we are about to make you famous. Everybody's gonna be saying your name after this talk right here. All right, I'm sharing your slides. Let's hope it doesn't crash. Let's go, baby. All right, I'll see you in.
I hope it doesn't crash. Right. Okay. All right. So as I said, this talk is a continuation of my previous talk. So if you didn't go see part 1, it's going to lay out it in a little bit easier of a way than this one will. But I'll start where a little bit further than where I started last time and go over this. I show this slide almost every talk I do, but I feel like it's important to start here so that everybody kind of gets on the same page. I'm going to rush through this. So once again, definitely go watch my previous talk and you'll get some more information. All right, so what are vector embeddings? Vector embeddings are essentially lists of numbers. I say this a lot, but think of it like, and I've recently used this analogy a lot, it's a list of groceries. And it's every single one of those groceries is something that you need to go get. Well, in this case, it's a list of numbers where each of those numbers means something about some piece of unstructured data, audio, text, images. And it's highly dimensional, sometimes sparse, but usually dense, and highly dimensional in the sense that, as again, each one of those items means something. So in that list, you can say, if you think about like convolutional neural networks, how they pick up on, filters, if you think about the MNIST, the curve of every digit, each one of those dimensions in the list actually means something about that input data. It's never been easier to create, and there's APIs to do so. Our friends at Hugging Face, OpenAI, Cohere, congrats to Niels and Co on the round, but it's never been easier to actually create these embeddings. So again, I'm going to be blitzing through this, but if you didn't watch the last talk, or if you need more background, you can go down to that MLOps community blog post that I did. The way that we search through vectors, each of those important data points, you can subtract essentially, or use something like cosine similarity to compare the distance between them. If you use 1 minus the distance, you get their similarity. And so in this case, we were able to see an example of 3 sentences and a query sentence, where that each are turned into a semantic vector, meaning not lexical, something like a BM25 search, but actually semantic. And that implies that we're looking for the meaning of the sentence rather than the words of the sentence. And so in this case, we're calculating the difference in meaning between all of these sentences. And we can see that that is a very happy person is the most similar to that is a happy person, which makes sense. Semantically, those are the most similar. Obviously, vector databases, as I explained in my last talk, are used to perform similarity searches. So you can create a search space within a database that has CRUD operations. And then with those embedding models supplied by our friends, take unstructured data, index them inside that database, and then perform searches against them. Obviously, I work at Redis, and Redis does this in addition to Redis Search. And so when you combine those two things, you get a pretty powerful vector database. And I obviously am going to be skipping through this, but if you didn't know, Redis is a vector database. We have a bunch of integrations. Shout out to Tyler Hutchinson for doing a lot of these. And we have 2 indexing methods. Our ANN is HNSW, which should be HNSW, not HSNW. And then flat. And then we have some distance metrics, L2 cosine internal product, support for hybrid queries, support for JSON. I explained a lot of this in my last talk, but we're going to get to the fun stuff now. Okay, so now here's where I'll slow down. This is design patterns. So these are things, as I've said, and I said to a bunch of people that when I was giving this talk, if you saw Chip's talk from the ML Learners group, I did some of this, but I've expanded upon it. These are design patterns that I've seen that I've deployed for either customers or in practice or in demos for LLM usage with vector databases. So not all of these apply to every case, but they're things that I've seen out in the field once again. And so it's important that everybody kind of gets on the same page with them. One interesting thing I thought would be to start is this Sequoia LLM survey. I'm sure most people have heard of this VC, but 88% of the surveyed group believed a retrieval mechanism was essentially a key point of the architecture of their LLM stack. everybody knows that I'm not going to go for LLM ops or vector ops, Daniel Spinova, but I do think that in this case, the LLM stack together, a vector database and a large language model, it's clear that there's a synergy here, and you'll see that throughout the design patterns. Again, 88% believing that there is some retrieval mechanism necessary for their large language model stack. So the first one and the one that you see the most is context retrieval. And I showed this in my last talk, but it is the most important one. And that is kind of an overarching group and a design pattern here. But the whole point here is that you have some question and answer loop or some chatbot or some recommendation system. And your goal is to retrieve contextually relevant information from within your knowledge base to be able to supply the LLM with more information such that it has contextually relevant information at the time of generation. This is cheaper and faster than fine tuning. It allows real-time updates. So very importantly, if you have a very constantly changing or rapidly changing knowledge base or source of information, you are not able to change the model and redeploy in such a speed or such a velocity that it actually is represented in the end result. So the only way you can do this is by having vector databases and injecting that context into prompts when you find semantically or otherwise relevant information to include in those prompts. This also protects you from sensitive data scenarios. So say that you use something like, you're like a bank, for instance, and you have multiple sets of, say, analysts, and you want to be able to say, this group of analysts is allowed to access these particular documents, and these particular group of analysts are allowed to access these documents. Well, if the model has been trained or fine-tuned on those documents, you can't guarantee that. You can't say, I'm positive it will not say this particular piece of the knowledge base. But with a vector database, you can. You can use things like role-based authentication control, RBAC, with vector databases like Redis, and say that this particular user does not have access to these particular parts of the index. And that allows you to then segment your data accordingly. And so that allows you then to say, have different, more interesting application architectures protecting your sensitive data. This is good for all types of use cases, not just question and answer, but it's the one that's the most easily recognizable. There's a couple examples, and honestly, many of the examples that I have are going to be on Redis Ventures. That's our github.com/Redis Ventures. It's our team's repo, so go check that out. One more advanced thing on context retrieval is something that I've done a couple times now called HYDE. I think it's hypothetical document embeddings. But essentially the point here is that you're going to end up using summarization on top of context retrieval and then use that again as the context in a prompt. So there's actually two invocations of a generative model here. So the first is you have this context retrieved from the queries, and then you take those and you use that actually to then get the context for the LLM that is going to answer the question. And so this because it takes multiple trips as an LLM model is slow, and it may take seconds to do. And so the way that we've used this in the past is actually, if you're familiar with asynchronous Python programming, you can do what's called a gather or even just two asynchronous calls that both go complete some action. So the first one would be go do this without HYDE, go search for context. And you can have either a threshold, or you can have something like some similarity score metric that you are counting on in that case to say, is this context good or not? Obviously, if nothing's retrieved, then you can go to the second asynchronous call, which would then be the HYDE approach. Since it's going to take a little longer, you can wait and say, okay, did that first one return anything? If not, then now let's wait for the HYDE approach to finish. And so that is one way that we've seen that you can get around the problems of context maybe not being perfect for a specific question. I do recommend going and checking out that paper. There's a lot more to talk about here, but I don't have that much time. Okay, so feature injection, really cool one. Shout out to Simba and Co at Featureform for putting in the ability to actually use Redis as a vector database in addition to a feature store. This is something that we've done a lot of since Redis is commonly an online feature store. So when you're able to use both of them in the same context, pun intended, you're able to then use the qualities of both of them at the same time. So what do I mean by that? Well, say that you have a e-commerce website and a user logs in, and that user has bought some product from your e-commerce solution. Well, say that chatbot is, its whole thing is designed to help the user with issues, right? Well, if the user says, I had a problem with my last order, what you could do in that case is then go have, semantic representations where you're bucketing and you're saying, I'm identifying that this is a user asking about ordering and doing a lookup. But instead, in this case, you can have this such that a prompt can recognize when you need to go and retrieve features from the database and then retrieve that contextually relevant information at the same time. And so this allows for real-time inclusion of that entity information, whether it's a user or a product, such that that model beforehand had no idea that that user had bought that product. But now it's able to go and look up specific things about those users and then include that in the context window. So every time the user does something in that context window, you may have last 10 items user bought, or last, type of user, active user, rewards user, thanks for being a rewards user. And so all of those specific things can now be injected into the prompt because your feature store is allowed to be in the same loop, included, I guess, in the same loop as your vector database and your LLM. And so, especially with Redis, you're able to do this with the same infrastructure, which is really nice because you can co-locate metadata with your vectors, so your features with your vectors. Go check out Featureform on that. They're able to do both. It's pretty cool. They just released it, so go check that out. Semantic caching, talked about this one last time too. This one's getting even more popular. And so basic concept here is everybody think about typical caching, right? Hash an input, it's used as a key, right? And that, you do something like search 16 or, something similar to decide what hash slot things go to. And then you can do a lookup by saying, okay, I have a new input. Is it the same as that one that I've hashed? Okay. Well, in this case, what if, going back to the product scenario, someone said, can you tell me about X product? And then the next user said, can you tell me about X product ? Well, technically those aren't going to hash to the same thing, but the similarity semantically might be 99.9%. And so shouldn't that return the same answer? And you can set that threshold. You can say, oh, I only want 98 or 99% similar to be returned. And you can even caveat it and say, this was a pre-written response. Even better, some people are, if you have a very set of questions and answers, like an FAQ, and you're having a bot to answer all of them, you can just go through and answer all of those questions and then have them cached. The benefit of this is you're not invoking an LLM. You're not incurring the cost monetarily or computationally, and it's going to speed up your application. So QPS wise, it's going to get a lot better if you've embedded all of those answers and queries. So basically query gets, you embed the query, and then every time something's answered, you store it in the database such that if a new user does it, you get that same answer back according to some threshold. And so this is becoming very popular. And if you want to try out kind of an alpha of this, definitely let me know, because we have some stuff coming. So another one that was talked about earlier actually is guardrails. And vector databases can be used as such. One really cool example of someone who's doing a lot, not necessarily in vector databases, although it does integrate with LangChain and can do retrieval, is Nemo guardrails from NVIDIA. Really interesting way to have this like Golang definition of what you should be able to do as a bot, and defines how that bot can express itself, defines the flow for it. And these are really important for large language models, as it allows the ones that are really prone to hallucinations, especially the ones that are very large, to be used in ways that are much more contained or strict. And so vector databases in a similar fashion, not necessarily in this case, but vector databases in a similar fashion, you can say, okay, if no context is returned, return said answer and have a default answer. Or if no context is returned, choose another path. And so you can think of a downward facing directed acyclic graph, right? And you can branch from there. And vector databases like Redis are so fast, you can do multiple context lookups and have that chain all the way down, such that you don't necessarily have to incur as much cost going to the LLM every time. You can just simply have that tree of options for yourself. And so getting really interesting with how you actually pre-compute all of those embeddings and make that directed acyclic graph of options for your model to go and explore in the case where no context is retrieved is a really interesting way to handle putting like a barrier on your LLM or guardrails. The way I like to explain this sometimes is it's like bowling. Sometimes LLMs, they get stuck in the gutter, right? I know I shoot it in the gutter all the time. I'm awful at bowling, but guardrails, just as they sound, they're like bumpers. And so you can be a 10-year-old or you can be me and you slam the ball down the alley way too hard and it will still run into the bumpers and most likely hit something at the end of the alley or lane or whatever they call it in bowling. All right. So long-term memory, talked about this one, I think last time as well, but this one's a really interesting one. Now that context length is a lot bigger, it's, somewhat like people immediately assume that this kind of thing might be irrelevant. But even as context windows get bigger, from practice that I have, it's not necessarily best to always just slam everything in the previous history into a context window. So if you have every single thing in the previous conversation in a context window, there might be tons of irrelevant information. And so doing a different type of lookup that's actually based on, a specific user or a specific topic or a specific query is going to end up returning much better results. Thinking about things like how many tokens go into each embedding, and I'll get into this in a little bit, so I don't want to get into too much here, but how many tokens go into each embedding? How many specific pieces of context do I retrieve for each prompt? And so thinking through and going through each of those things is really important. And it's not just, oh, there's 100K tokens now, let's slam everything up into the context window and get charged a bunch for, really computationally expensive invocations. It's better to be, work smart, not hard, essentially. So that's that topic. Common mistakes. So I thought this would be an interesting one to go over. So these are things that I've seen people do or talk about that, make me think, people are just not, they don't really care. They just want to do demos and then leave it. And so this is like common mistakes specifically for production uses. Okay, the first one is pretty obvious, which is laziness. I know it sounds funny that I was kind of just talking about context window too, but it doesn't solve everything. And so as I said, I was going to get into this in a little bit. You see a lot of use cases where someone just takes, and I have all these integrations over here. You have all of these integrations and there's a lot of defaults that are in them. So defaults for things like, prompt tokens, LLM tokens, or, specific chunk sizes, or, ways that actually tokens are parsed or taken from documents, or there's a lot of assumptions that are made, and people using them without understanding them often don't really realize how their data is chunked up, and they've never actually inspected it inside of their database, so they've never actually looked at it after it's chunked, or looked at, when you actually go to answer a question, what's in that prompt. And so thinking about all of these things is really important. And you'd be surprised how you can use worse models for the generative side and actually improve upon these factors and do something which I've been doing recently, which is It's like k-fold, if everybody's, remembers that traditional machine learning exercise. In this case, you take the variables here, context window size, number of retrieved pieces of context, number of tokens per embedding, and those types of variables. And then you can grid search for a good one. And then k-fold, which is you take each one of those and do it on different chunks of your data set. And that's a really interesting approach to make sure that you've reached the best variables that are the factors listed here. And there's obviously a lot more, but for your specific problem. And for undefined problems, sometimes this is really hard. If you have a really open-ended problem in the case where, its generation could be a number of things, like think more creative problems, that's going to be really hard to do this on. But something like I was talking about earlier, where you have an FAQ and there's questions and answers that are there and supposed to be correct, this is something that you can do and is something that I've done a lot. So I don't think that was to me. Okay, sorry, the chat distracted me. Index management. I don't know, let me check my time. Okay, I gotta get going. Okay, so how do I set up an index if I have multiple use cases? This is one that people specifically don't really, I don't know, I'm not sure if they don't know or it comes up like a ton. Is like, imagine if I'm Shopify and I want to have a per shop, set of embeddings, right? Well, think about this. There's a couple different ways to do it. You could do one gigantic index and then have some type of metadata or filter on each one of them for the store. So the first thing you do is actually filter it down to just ones that belong to that store and then do a vector search. But how many total embeddings are in that index? How many, what's the size of those embeddings? Does your database charge money per index? How does it charge you? And does that database support hybrid in the first place? Is it efficiently supporting hybrid, or is the metadata stored somewhere else, which I'll get into in a little bit? Those specific things are actually super important. So I called this index management, but it's really index architecture, I guess, which would be a better way of saying it. What I've typically done, and this is specific to Redis because Redis does not charge per index. It's just, you get memory. And so in this case, a lot of times the multi-index scenarios, there is some overhead to having multiple indices, but the multiple index scenarios, if there's, under, let's say, 1,000 indices, it's better to have multiple small indices. And then as soon as it gets over something like 1,000, maybe 10,000, something like that, really depends on the size of your index once again, and a couple other scenarios. But in that case, then you can move to a large index or specifically grouped indices where you can do search at the same time and asynchronously. And so you can kind of split it up in that way. So thinking through how your indices are grouped and specifically set up in terms of which approach you take is really important, not only for things like QPS to recall, but it's also so important for how much you get charged and how much you are able to spend or use moving forward as your use case grows. So do that ahead of time, project your cost, test performance, and mock scale. Make fake schema, make fake embeddings. So just, go through that stuff and, really dive into that, because that is something that I've seen people go, wow, okay, I've reached an untenable cost now because I get charged per index and I don't know what to do. I have to change all of my backend code now. So think through all of that. Okay, separate metadata. So this specific 2 plots here come from actually a recommendation system. How's it going, Demetrios? Am I over time? I'm over time.
Way over, and there's so many amazing questions in the chat, but don't.
All right, well, let me just get through it. I'm gonna blitz. All right, separate metadata comes from a Rexus use case. You see on the left-hand side, you have before 2 network hops. Metadata in this case is, stored. It's not actually, but stored separately. It requires 2 network hops to go get. Now, if you can use the KNN search to go and get those specific things, then you have a huge boost because you are eliminating a network hop. There's a lot more here, but go check out the ones there. I spoke about it at GTC. Architecture considerations, I'm gonna skip that one. Okay, there's a lot more here. Go check out Chip's talk if you want an explanation of this, but all of these things are very important. If you want to go to Eric Bernhard's repo, check out that one. Providers, I'm going to skip it. Example architectures, I wanted to get to this. Okay, example architecture 1, you have, this is for AWS, an example architecture for question and answer. Vector database, Redis Enterprise, you can use inference on SageMaker, LLMs, Cohere Multilingual, monitoring Prometheus, Grafana, API layers, Fast API, CSV, AWS, chatbots, Q&A, et cetera, et cetera. We have Terraform for it down there. These slides will be on my website, party.io. Azure-based document intelligence, very similar thing, all in those repos there. So go take a look at that. But that one is actually like one click to deploy Terraform. Shout out Anton, thank you very much. And then a general on-premise one, which is really interesting. This is one that was actually set up by us. And so in this case, it's all on-prem. This can be deployed anywhere. There's also a K8s version of this. If you're interested, I'm sorry I didn't get to more of the meat of the talk. I talked too much. Apologies. But hopefully I can do it again or something, and I'll host it again.
Yes. Well, that dude, why couldn't you talk that fast the whole time? That's what
I felt like I was talking fast.
Oh, that was classic. There's so many incredible questions in the chat, man. So anyone that is asking these questions in the chat, I think Sam will probably go in there right now and answer them. But also, he's in Slack, and we have that channel, Community Conferences in Slack. And so tag him directly, and we can start threads with that, because then more people can chime in. It's a little bit more organized, and Sam knows, okay, we're talking about this, and it doesn't get as chaotic. The chat is great here, but if we're really trying to have deep conversations, throw it in Slack, and we'll do that. Anyways, Sam, for everyone, I think the main thing of this talk is, you know what you're talking about. People should know you, and especially the horses and cows around my neck of the woods. They are going to know your name next time I come with the questions, aren't they?
Yeah, and I'm too passionate. I'll talk about it forever. So I just took too much time. But anybody who has specific questions, do tag me, like Demetrius said, and I'll get to it, I promise.
And so the other thing that people can do is, if you click on the Solutions tab on the left-hand sidebar, there is a whole Redis section, and you can go super deep, and you can see that Redis has all kinds of cool stuff on offering. And so that is very worthwhile. You can enter their virtual booth and check it out. So Sam, sadly, we have to part ways. Yeah, there's. Oh, are you sharing something else on the screen that I should share? Wait, what is this?
Well, I was just gonna say, go follow me at SamParty or on LinkedIn for slides and the talk. Once Demetrius gets to it, which you never know with Demetrius, obviously. But I'll repost them on my website as I do for a bunch of my talks. Go check out the cookbook, Redis Ventures. It's all up there. Take a screenshot and hit me up, Twitter or LinkedIn or something.
Yep. So luckily this time you guys are the, oh, I got you off, not your slides. I wanted to see your face when I say this one. You guys are the diamond sponsors. So you're going to be the first talks that I edit. You're going to be coming out like in a few days, hopefully, if we can get to it. But in the meantime, I'm going to kick you off, and we're going to see each other in 2 weeks when I'm in San Francisco for this LLM Avalanche meetup. Love having you. And he said something, but I kicked him off before he could say it. So that's all good. Next up, I need to give away some swag to people, because this chat has just been on fire. And so I see that we've got, oh man, there's so many good questions in this chat. It is a monstrosity that I could not ask them all. Michael Griffith, incredible question. Reach out to me, get some swag. That is awesome. And people making fun of Sam's speed at the end. AJ Singh, reach out to me. I got some swag for you. We've got some special Reddish swag. And I see some other... Somebody... So... Thewind Mom wrote, Eminem is crying right now at Sam's speed at the end of that talk. So I'm going to agree with him and say, reach out to me. You get some swag. I feel like Oprah right now. because I get to give away all kinds of swag. And I think that's it for now. We've got another speaker coming on, though. Where is, let's see, Inez, calling Inez to the screen. Where are you at? There you are. What's happening, Inez?
Hello, hello. All
is
good?
Great to have you here. I am so excited. So now we went from these 30-minute talks, and now we're going to go lightning style, and we're going to be going 10-minute talks. And so if anyone has questions in the next 30 minutes over the next 3 talks, please hit them in Slack or in the chat because the speakers will be answering them there. Inez, I think you need to share your screen. I don't see it. You might need to share it again. And then I'll give you the 10 minutes. I'll be back in 10 minutes and let you go. Of course, I am a huge fan of what you are doing at Number Station, and I'm so excited for this talk. So I'll let you go right now. Take over.
Awesome. And thank you so much for having me, Demetrius. Appreciate. All right. So today I'm going to talk about some of our work on leveraging foundation models in the modern data stack. And most people here know about generative AI. Before I dive in, I just wanted to do a very quick recap of what foundation models are and why they're so exciting. So at a high level, foundation models are very large neural networks that are trained on massive amounts of unlabeled data like text or images from the internet. And the idea is to use a technique called self-supervised learning to train the model. So for instance, an important category of models are autoregressive language models, which are trained to predict the next word in a sentence given the previous words. And this idea has been around for a long time in NLP, but what makes foundation models really unique is their scale. And with this increase in scale, model size, and data volumes, we started seeing some very exciting new model capabilities. So what are these model capabilities, which we call emergent capabilities? Well, because these foundation models are trained on so much data, they can generalize to many downstream tasks via a capability called in-context learning. And the idea is to take any task and cast it as a generation task by crafting a prompt, and then use the foundation model to perform the task by completing the prompt, which is what the model is originally trained for. And I can then reuse the prompt on many more input examples, or I can craft many other prompts for different tasks. But the key here is that the same underlying model remains. All right, so we clearly see, and everyone here in this workshop knows, that there's a revolution happening in this space, and there's a huge paradigm shift compared to traditional AI with foundation models. And it means that pretty much anyone, not just AI experts, can rapidly prototype ideas and build AI applications with this technology. So what we're going to focus on today is applications specifically to the modern data stack. And you may have heard this term, but it's essentially used to describe all the set of tools to process, store, and analyze data. And starting from where the data originates, which is typically apps like Salesforce or HubSpot, the data gets extracted and loaded in data warehouses like Snowflake. It can then be transformed and modeled using tools like dbt. And ultimately, once the data is clean and prepared, it can be visualized with tools like Tableau or Power BI. And even if these tools are amazing, they've drastically improved things like scalability and knowledge sharing in organizations. There's still a huge problem, which is that there's a lot of manual work to do throughout this process. So the good news is that it's possible to automate a lot of this work with AI, and even more so with foundation models. And that's exactly what we do at Number Station. Essentially, we're bringing this foundation model technology into the modern data stack to accelerate time to insights. So now let's talk about how that works in practice. And I'll start with a simple example that you probably have seen before, which is generating SQL code. So in modern organizations, anytime a business user needs to answer a business question, they have to send a request to their data engineering team. And these ad hoc requests usually require multiple iterations and can take a long time to fulfill. So with these foundation models, a lot of this back and forth can be avoided by using the model to generate the SQL queries from natural language requests. And this works amazingly well for simple queries, but there are some caveats to use this for more complex queries, especially for complex query when there's some domain-specific knowledge that the large pre-trained model may not capture. So for instance, if there's multiple date columns in my table, which one am I supposed to use? That's not something that the models know out of the box, and I'll touch on this point later in this talk. Another exciting application is data cleaning to fix things like typos or missing values. And typically the way to address this problem is to create a bunch of SQL rules. So this works well overall, but is a very long process to derive all the cleaning logic. And many times the rules break because of some edge case that was not captured during the rules development process. So with foundation models, there's an exciting alternative to this rule development process, which is to use the model itself to do the correction. And the idea is to create a prompt with a few examples and then reuse this prompt over all the data records to clean the data, which is what is shown in this figure. And this is obviously very exciting because the model can derive the patterns automatically from the in-context examples that we provide. But there are some caveats to this approach as well, especially issues around scalability, which I'll discuss later in this talk. And another exciting application is data linkage. So the goal here is to find links between different sources of data that may not have a common identifier. Say like my Salesforce data and my HubSpot data, I want to link my customers. There's no ID to create a join on. And similar to data cleaning, engineers need to spend long iteration cycles crafting rules, and sometimes these rules can be brittle and break in production. So with foundation models, we can create prompts for the specific data linkage task and alleviate some of these issues. The idea is to feed both records to the model and then ask it, are these two things the same in natural language? And in general, we find that both for this problem and the cleaning problem, the best solution is to compose rules with the foundation model. So if there's some very basic rule that can solve 80% of the problem, we should use it. But then for these last mile examples that are more complex, we can call the foundation model. All right, so now that we've shown some of the possibilities for using foundation models in the data stack, and there's many more, I just had to scope it for this lightning talk. I want to share a few caveats as well as solutions that we've developed throughout our research at NumberStation in collaboration with the Stanford AI Lab. So the first caveat, which we touched on briefly, is the scale. Foundation models are extremely large models, and depending on the application and how we use them, they can be very expensive and slow. And if I'm using a foundation model with a human in the loop for things like SQL Copilot, then the scale is not so much an issue. We care more about latency in these cases. But for other data applications where I need to use the model itself to make the predictions on, let's say, an entire database that has millions or billions of rows, this is just impossible. And it's going to be extremely expensive, extremely slow compared to using a rule-based solution. So how can we address this? There's many possible solutions, and one of them is model distillation. So essentially here, the idea is to take the big model for prototyping and then use that big model to teach a smaller model to do the task. And this actually works really well with good prototypes and good fine-tuning, and we can easily bridge the gap between these large and smaller distilled models. There are also other solutions to address the scale issue, which I linked in this slide, one of them being as I mentioned, to only use the foundation models only when we really need to. So if the task is simple enough that it can be solved with a rule, we don't need to use the model itself to solve the task. We can instead use the model to derive the rules based on the data, which is always better than handcrafting rules. All right, so another important challenge here is, as everyone knows, prompt brittleness. So for instance, if we format a prompt differently, it will predict two different responses in this cleaning task. And the demonstrations that are used in the prompt are also really important. So in this example on the right, we ran an experiment and we saw that picking manual demonstrations versus random demonstrations had a huge performance gap. And this can be particularly problematic for data applications where users are used to deterministic outputs, which is the case in the modern data stack. They're not comfortable with potential errors and brittleness, even if that can save them a lot of hours of manual work. So how can we solve this? There's a few methods, again, to approach this problem. One of them is a method that we proposed in the AMA paper, which is linked here. And the high-level idea is to apply multiple prompts to the input and then aggregate the predictions to get the final result. This worked quite well. We noticed some good improvements compared to the traditional prompting method. And there are, of course, other solutions to address this prompt brittleness issue, such as decomposing the prompts with chains, as well as being smart about how we sample demonstrations. And the last caveat I wanted to touch on here is the lack of domain-specific knowledge. So foundation models are trained on public data, and they lack some knowledge that is sometimes crucial to solving enterprise data tasks. So for instance, if I'm asking a foundation model to generate a query to compute the number of active customers in my database, there might not be a perfect isActive column. And then what I need to do is rely on some organizational knowledge that defines what an active customer is to generate that query properly. And so to approach this domain knowledge problem, there are two types of solutions: inference time and training time. So for training time, the idea is to leverage the untapped knowledge that is stored in organizations' documents, logs, metadata. And what we can do is continually pre-train open source models on this data to make them aware of this domain knowledge. And we have some work on this, which I linked as well on this slide. Another solution is to bring the knowledge at inference time by augmenting the foundation model with some external memory that can be either accessed through a knowledge graph, a semantic layer, or a search index over the internal documents. So that's pretty much it for this talk. I'm sorry, I know it was rushed. I tried to condense everything in 10 minutes. I wanted to thank a few of my collaborators from Stanford and NumberStation. And if you're interested about these applications, feel free to reach out to me, check out the blog, send an email. I'd be happy to discuss more.
So good. I love it, Inez. Thank you so much. That was awesome. So two things. If anyone has a question, throw it into the chat or into Slack. Inez, I think, is in both of them. I'm super excited about what you're doing at NumberStation. And I believe that you're working out of the factory offices, or you stop by there every once in a while? Because I'm gonna
a good part of our team is there.
So, all right, now that I've got you on screen right here, now I can catch you. I'm gonna be visiting Diego, who you're working with, at the end of the month in San Francisco, and I want to stop by the factory office and hang out, and maybe we can record a podcast or something, and you can go deeper into this. Does that sound good?
Yeah, anytime. Sounds great. And thank you for inviting me again.
Awesome. Well, I am glad we got that. I'll reach out to you on the good old email or Slack, and we'll make it happen. And now we'll keep it cruising. So thanks again, Inez. And next up for the illustrious lightning talks, we've got Stefan coming on. What's up, dude?
Good. Thank you for having me.
Here we go.
I copied your look, you know. I love the Hawaii shirt, so I figured I'll also go for the summer look today.
That's what I'm talking about, man. That is what I'm talking about. I love it. I am so glad that you're feeling the vibe. If anybody else is feeling the vibe and wants to get Hawaiian on us or tropical, send us a selfie or post it in Slack or post it on Twitter and tag us, and I will send you some swag. I will promise that I will send some swag. We might even send some Genius Cloud swag your way. If I can talk, if I can put words together, that will be what we will do. So Stefan, man, I have been wasting a ton of time right now, and my only job is to make sure that we are on time. Therefore, I'm going to hand it over to you. I'm going to let you get cracking with your 10-minute lightning talk, and then I'll see you in 10 minutes, dude.
All right. Thank you so much. Okay. First of all, thank you for joining. My name is Stefan Ojanen. Here representing Genesis Cloud. We have a fun project to showcase. As soon as I get my slide changing. So the topic of the talk today is AI meets memes. So how do we take image flips? This meme does not exist to the next level using a large language model. All right, it's lightning talk, so let's go. First of all, what is a meme? I think everyone is familiar with the memes, but yeah, it's usually about mimicking something, right? So it's taking something that exists and making small variations of it. And over the years, you get layers and layers of meta. Why memes? It's kind of interesting topic for large language models because in general, humor is something that's not very well understood by or explained by humanity yet. But so first, a brief history of meme generators using AI. Back in 2018, there was a paper from Stanford researcher called Dank Learning. So they used a long short-term memory model then to generate memes. But while it worked somewhat, it didn't really work for the structure of the memes. And this is something that the authors acknowledged. Then 2019, so Dylan, the founder of ImageFlip, did this himself using a deep convolutional neural network, and this is the basis for the AI meme, or this meme does not exist service that's available on ImageFlip. And then going forward from 2020, and with the advent of GPT series of models, yeah, I've seen various hobby projects and even some commercial services generating memes. But you can also do it yourself, and we are gonna show you how. So how did we end up here? First of all, let's just be honest, I really like memes, so it's a fun project for me. Then we at Genesis Cloud, we are a provider for AI infrastructure, so it's really important for us to understand from users' perspective, how does our infrastructure is to use for them, right? And given the, with the advent of ChatGPT and the great public interest, therefore, on the large language models, it really just seemed like a fun project for us to learn from. And I believe that the technology exists for generating memes, so why not? So here we are. So how I got started, I wanted to do a quick reality check. So back then, when we got started with this, ChatGPT was still based on the GPT 3.5 model. But for me, it was the most advanced model at the time. So I just wanted to check, would a model like this understand the meme context? So we got started. So what we already, in the first response, we saw some hallucination. It did not really understand how the meme template is for a Velociraptor meme. Asked for a caption. First one, not really great. But the second one, yeah, that's actually pretty good. So yeah, I put it in a template, and yeah, it's the meaning of life 42, because that's the only answer I'm getting no matter how time I ask Google. Yeah, I think that's somewhat funny. And as comparison, an actual human-generated popular version of the meme, if the opposite of pro is con, it's the opposite of progress Congress, right? So there's silly but smart questions. That's the idea of the meme. So I believe that there is really something there. So we went ahead with the project. Then, so attention, no, data is all you need, right? So we figured, okay, to make this happen, we need a meme data set. Who has the biggest meme data set? It's ImageFlip. So they kindly provided with a huge data set, so 650,000 meme templates. Most of them are like same but different. So the number of unique templates is actually unique templates is a lot smaller. And there are like 40 million individually created memes by the users of the service. That's what we are working with. So the goal was to showcase how a contemporary LLM can create quality memes. And we wanted to expand the existing service to cover more templates than it does currently. And 255 would cover like 60% of all memes created. So that's the number we settled on. And we wanted to demonstrate how Genesis Cloud can serve such an LLM for millions of monthly users. First, we tried what you usually do is try the BERT. It's a kind of well understood model. Didn't get good results, so we moved on from that pretty quickly. And yeah, with the BERT, we get a little bit better results, but this is the time when the Llama series of models came out, and these are like instruct models, and this is where we turned our attention to. So, but the problem with this Llama version is that it had a license that forbids commercial use. To note, OpenLlama has been made available since, but there's another set of families. So you have the Red Pajama and Pythia. Yeah, we tried it, but it really, even though it was sometimes funny, it just wasn't good enough. It really struggled with the format. A lot of the responses were just nonsense. But stable ALM, this is where we struggle. So we found out that this worked easily the best. It's not as good as GPT-4, admittedly, yet, but close. And I think we can make it equally good. So now we have instruct models, right? So we tried all kind of approaches, and this is what we found to work the best, right? So first you have the instruction for the model. This is the overall context. You know, you need to tell the structure. Is it 2-part? Is it 3-part meme? So forth. Then you have the input. So the specific context of the meme. This is the prompt engineering part. So you actually, it worked the best when you do this for each template, we found out. And then you have like the actual data. So this is not the generated meme. This is kind of the training data used for fine tuning. We basically used the Lit Parrot project with the LoRa and adapter, and we only needed 3 epochs. Just make note that this is a proof of concept data set. So, but we only still needed three epochs for the model to converge, and we expect not to need more than 10 epochs with the full data set. And the training time, it was really fast. So using a 4 GPUs, it was only 21 minutes to fine tune it. And yeah, it's pretty easy also from the ops perspective. So we basically were able to max out the GPUs and not waste any resources. Then the results. So we basically use all of the three models mentioned earlier to create seven iterations of the 3 templates. So it's not like a big data set to cherry pick from. And I kind of graded them myself, and 76% were actually funny to me. So it's just my subjective judgment. So have a look at yourself. And these are now by the model that we built. So waste time eating fruit, make useful multivitamins. Of course, you take that. True self, true love. Oh, that's a tough one, but I guess that's a compromise you sometimes have to make. Dismemory and beloved character, sending text messages. Okay, that's a pretty grim choice, I have to say, but sometimes life is like that. Work hard or drink. Okay, yeah, that's good. Then living with parents or to eat dinner. Yeah, tough economy can be like that for sure. And then lastly, so only out of 7 examples this came out, and I swear that this is not cherry picked or anything, right? Write a meme talk or laugh meme. Okay, that's funny. Then how do we serve these memes? So first we're gonna fine tune the all-out model for the 256 templates. So we did, based on the initial work, we made some assumptions. We measured that we get 6 tokens a second from the 3090. We roughly expect like 10 tokens per request, and based on their site behavior, so roughly for 5 million monthly requests. So we calculated that without seasonality, you need roughly 4 GPUs to serve this. We still haven't properly calculated this, but we expect the peak loss to be around 10%. So we need like a scaling setup up to 4 for the GPUs. And the setup, yeah, it's pretty standard stuff. It's very, very similar to NVIDIA's reference architecture. So just use Kubernetes for scaling, put some monitoring in there, and use Triton then to serve the model itself. And basically, we provide then like an API that ImageFlip can consume for their website. Yeah, why not use just GPT-4? Yeah, it's a black box. Open AI API becomes a single point of failure for your AI application. That can be a real problem. You don't control your data. Maybe less important for memes, but can be important for some. You have also limited control over the model, right? And it's expensive at scale, like really expensive. The fine-tuning this costs roughly $1 using Genesis Cloud, only $1, right? Then over a month to generate 50 million tokens. Yeah, it will, depending on if you go on demand or long term, it's $300 to $500 US over a month. So not too bad, right? And if you would use the OpenAI API, it's 10 times. It would be $4,500 US. So I don't want to trash OpenAI. It's great they do absolutely amazing work, But sometimes when you do it yourself, you can get something similar with much less money, right? Okay, what's the problems we expected to face to keep it lean, right? So what will be the minimum infrastructure needed while meeting an SLA, mitigating latency? There's some naive approaches like looking at GPU utilization, but I think GPU queue time is a better leading integration. This is something that we will really investigate, and yeah, just how to deal with a ton of concurrent requests. Yeah. Okay. So that's the proof of concept. So it's working. We will continue. So there will be another talk with another time how we handle the training for the complete data set. We will by then we will showcase the actual live production setup when it's up and running, and the actual challenges we face, not just the ones that we anticipated. And then, of course, show some more memes when the model is also a little bit further developed. Yeah. So thank you very much for listening for this quick lightning talk. For any questions and feedback, you will find us in Genesis Cloud's virtual booth. And special thank you to Dialan, the founder of ImageFlip, for providing us with this amazing data set, and to Marouane for doing the actual modeling work. I'm here just to talk.
Dude, shout out to you for being the first and maybe only person that I know that is using Stable LM. That is pretty impressive. Every time that I talk to it, it hallucinates more than my college roommate.
Yeah, so in this case, I think it's like it depends on the use case, you know. So it's worthwhile to try them all. It's really amazing what they've done with the lit parrot. You know, it makes easy to find these models. So all of the 3 models are part of that. So I'd say like just try it out, and depending on the use case, your mileage may vary. You know, awesome. And yeah, and I think it's like meme is very contextual. Humor is difficult, right? So if I'd say with relatively little effort and with simple setup, we were able to fine tune a model. I think you will be also able to do the same for your business use case that might be less meta. Yeah.
Awesome, dude. Well, thank you so much for coming on here. And anybody that is interested in everything that you all are doing, like we said before, you can click on that little left sidebar that says solutions, and you can, I think they can get some swag directly from you, but I'm also going to be able to give out all kinds of swag to them too. So I'm pretty sure you guys are giving out some socks or maybe some mugs. I can't remember exactly what, but
T-shirts and socks. So join our booth for those.
There we go. Get over to that booth and claim your free swag. So, dude, thanks so much, Stefan. I am going to keep it cruising, and I'm going to bring on Mr. Transitive Bullshit himself. What's up, Travis? How you doing, dude?
I'm good, Demetrius. Thank you very much for having me. It's a pleasure to be here.
Dude, can I just say this in front of everyone? I'm going to declare my love for your email.
Thank you.
That you have. And I don't know if we want to put you on blast and say it to everyone, but let's just say that your email is probably the best that I have ever seen. And if anyone is not following you on Twitter, I highly recommend that. You are such an incredible follow. And you do all kinds of Twitter spaces to talk about what's happening in AI and ML all the time.
Yeah. Something that we're all learning about this space. It's so new together, and just have a good group of people that we like to discuss the latest weekly news. Working with Ben's Bytes newsletter as well, and just try to distill it down and make it accessible for people.
That's it, man. So it's super cool to have you here. As you know, I'm a fan, and now you're on this agent kick. I'm going to give you 10 minutes on the clock, as if I follow the clock strictly, as you know. But that's the fun of having big cushion breaks at the end, so I can be a little bit more liberal. I'll share your screen for you. You should be good to go. I'll be back in 10 minutes, man.
Awesome. Thank you, Demetrius. Yeah, so as Demetrius said, I am Transitive Bullshit, otherwise known as Travis Fisher. Quick background on me and why I'm chatting about agents today. So I have a strong background in open source, and the AI space has been changing exponentially, as I'm sure most of you are aware. When ChatGPT released 6 months ago, I released the ChatGPT NPM package, and then released this Twitter bot, ChatGPT bot on Twitter, that has about 130,000 followers now. I also run a Discord called ChatGPTHackers.dev, which has about 10,000 AI developers in that. And I've just been building a lot of open source experiments and demos to really maximize my rate of learning around this space. And more recently, I've started to really focus on AI agents. And let's talk a little bit about that. So there's been a lot of hype around agents recently. AutoGPT, as an example, in this GitHub star chart, is the fastest growing, most GitHub starred repo of all time, which is just insane. I mean, a month after AutoGPT launched, it had more stars than like Docker, Kubernetes, like some of these just massive traditional open source projects. And there's a reason why there's so much hype around it. People are enraptured by the possibilities. At the same time, right now, the vast majority of these AI agents are actually just toys. So let's be really clear about what we're talking about. What actually is an agent? I'll be clear that there are a few other definitions of agents coming from traditional machine learning and reinforcement learning. Agents are a term that is not super well defined, but from within the scope of this talk and the type of agents that I feel like there are the most promising, I'll define agents are either autonomous or semi-autonomous programs, which in particular use the reasoning abilities of AI models to accomplish tasks. So, currently the AI models that we're talking about are LLMs, and it really only became possible to start viewing these language models as reasoning engines fairly recently, with large foundational models like GPT 3.5 and GPT-4 really just exponentially pushing the bar forward in terms of their ability to do reasoning, and then certain prompting techniques such as chain of thought or self-reflection, just adding even more robustness around their ability to actually reason. And I would define an agent as having a couple of key components. So an agent is, you can think of it as you give an agent a very, very well specified task. You give it some resources for accomplishing that task. Those resources could be things like compute time. It could be actual financial money. It could be tools such as access to access to your browser, access to your user accounts. It could be more traditional tools like access to APIs or proprietary data. But so you give an agent a task, you give an agent some resources to accomplish that task. Generally, the implementation of the agent is going to involve some planning or decomposition of the task into subtasks. And when you do that, there's a need to do some scheduling and prioritization around these subtasks, and ultimately it ends up looking very much similar to an orchestration or scheduling in like a traditional operating system, where you have, let's say, a lot of threads or a lot of work that need to happen, and you need to prioritize and actually schedule those tasks to be executed. Now, this can get very complicated very quickly. Oh, and there's also the whole external memory. This would be things like existing databases or vector databases. The main difference being that vector databases are kind of fuzzy. And for a lot of what agents are going to work really well with, or where their strengths are going to shine, the key advantage is that You don't need to have as specific of rule-based and exhaustive programming that makes things really explicit. They shine in areas where you can be really flexible, and that's a reason why vector databases, even though there's a lot of hype, there is this flexible aspect to them in terms of their using them for retrieval. So I view agents very much as a spectrum. I think when a lot of people say agents, they jump straight to the right side of this graph and think about fully self-driving programs. I think of agents as a spectrum where you start off at the very bottom. You have let's think of the large language model as a CPU or as a reasoning engine, and for the purposes of this talk, we can think of them as a black box. That and they're great at understanding and generating natural language, but the thing that's really game changing about more recent LLMs is their ability to reason. And that's where if you start to think about them as CPUs inside of a fundamentally new paradigm of compute, and then you can ask yourself, well, what does the world of programs look like that are built on top of those language models as reasoning engines, built on top of those CPUs? And I view those programs as agents. And on the one hand, you have very traditional deterministic programming. You can think of this as programs that are written by a human. The human is definitely driving the bus. And on the other hand, other side of the spectrum, you have fully self-driving programs. These are things like AutoGPT or Baby AGI. And the idea is you give the fully self-driving agent or fully autonomous agent a task, and it just goes off and completely on its own accomplishes that task. And one of the things that I really want to drive home is that just like with self-driving cars, trying to jump straight to self-driving programs is a mistake. It's amazing from a marketing perspective. It's amazing from the perspective of showing people like what will be possible soon. But this is LLMs in production. We're talking about what's possible today, and my main point that I want to make here is that we really want to start kind of more towards the left-hand side of this graph, but it's really a spectrum. And the question is, how can we start with more deterministic agents and slightly more constrained areas, just like we've done with self-driving cars. There's a spectrum there, and then gradually move towards more self-driving programs over time. So some of the key challenges, and I'll go through this kind of quickly here, would be one, agents have a tendency, the more autonomous you get, they tend to get stuck in loops or diverge away from the original path, and they don't oftentimes have a good ability to reflect and actually get back on track. There's something known as a composability gap, where even if an agent is really good at solving like one subproblem, the original problem, which is composed of many subproblems, the kind of probability or reliability of that overall agent decreases very, very quickly. Another thing is, like, if you just give an agent a task and say go off and do this, this becomes a very challenging UX problem. So it's not just on the algorithmic side, it's not just on the developer side. The UX of actually, from a user standpoint, understanding what these agents are doing and being able to interpret them, and also being able to keep a human in the loop is really important. And that requires really a lot of work on the UX side. Another challenge is kind of the latency and cost. Most of the current AI or agent frameworks default to using large foundational hosted models, and the cost there is something where when you have recursive calls, like that can add up really quickly. Finally, safety is of paramount importance. If you're actually giving an agent right access to the world on your behalf, making sure you keep some guardrails on that is super important. So I'm just going to go through some advice for building towards reliable agents. The first and most important piece of advice is to actually constrain the types of tasks that you're setting out to accomplish with agents. Anything that is too generic or too large, I think you're going to run into problems with. In my opinion, agents are a really good fit today for more of very repetitive tasks, robotic process RPA type tasks, tasks that you would want to have be always on in the background working on your behalf. Another approach is to constrain the set of tools that you use. So instead of giving an agent access to 1,000 tools, if you know that there's only a couple tools that you need for a given task, just constrain it that way. Keeping a human in the loop as part of the feedback process. This is one area where if you compare agents to kind of traditional workflows, this is an area where agents can fundamentally improve because they're built on top of machine learning models, and you can build in some human feedback loops that improve and learn and get more better at solving the task over time. So this is something that I think is a fundamental key primitive here. Another approach is to kind of build up an ecosystem of very reliable primitives. I'll talk about this in a second. Wherever possible, preferred deterministic code, and you might start off with a very generic, like say GPT-4, but move towards deterministic code eventually. One thing I want to say is multi-agent systems are distributed systems, and there's a lot that we can learn from traditional distributed systems in that context. One example here is a recent paper by NVIDIA and some researchers called Voyager that is solving various Minecraft tasks. And one of the key insights here was that the AI would generate code-based skills on the fly and evaluate those skills as kind of subroutines and have them build up this library of skills over time that it could keep referencing backwards. And I'm running out of time here. So last thing I want to say, if you view kind of the ideal agent as this fully autonomous single entity given a single task, I am advocating for more of a kind of scripted agent workflow that breaks up a task into subtasks, and in particular, if you think of the solution here as a series of nodes, every one of these nodes is something that you can reason about, no matter how intelligent the underlying language models become. The ability for humans to reason about the steps is fundamental. And whether this graph on the right is generated statically or whether it's generated on the fly, like I still think it's very important to be able to have this level of interpretability, because you can also then start to think about, well, this graph is kind of a higher level programming language, and we're moving away from like traditional, I'm writing Python code, to I'm writing in these higher level primitives. And in that world, we can apply lessons from traditional software engineering. At the node level of this graph, what does a unit test look like? What does writing an eval to maybe start off with a very, maybe a node starts off with GPT-4, it's a very generic model. You run it 1,000 times, you get 1,000 inputs and outputs. You distill that down into a very fine-grained model. These are all lessons that I think we can take from traditional software engineering and apply in this context. Anyway, I super quick version of this lightning talk, but that's it on my end. So yeah.
Awesome, dude. Thank you so much. This was incredible, as I knew it would be. Agents are so hot right now, and it is so hard to figure out how you can get them to work, and you are deep in the trenches. I know that I was talking to a friend of mine, Brian, and he was like, yeah, I tried AutoGPT, and all I was left with was a $200 OpenAI bill, and I did not get it working the whole time. So it's good to see. Another friend of mine was like, pretty sure AI Twitter is gaslighting me because this shit never works when I try it.
Yeah. I mean, there's definitely a lot of hype and a lot of excitement around what will be possible in the future. For today, I think you want to be more on the left hand of that spectrum, where you're writing more deterministic code driven and using LLMs as little pieces instead of big pieces of fully autonomous, at least for the time being.
Yeah, we're not there yet. All right, man. I gotta kick you off because we're keeping it rolling.
Thank you, Demetrius.
Thank you, Travis. I'll talk to you later, man. And I'll see you in San Francisco, maybe, if you're.
Yeah. I'm over at HF0. Would love to meet you when you're out in SF.
All right, sweet. Talk to you later, man.
All right.
So we're gonna keep rolling, and I am going to bring on my good friend, Mr. Raza from Human Loop. Where you at? There he is.
Demetrius, pleasure to be here. How are you doing?
I'm good, man. It is great to have you here. I know that the Human Loop team is helping coordinate the live meetup that's happening in London right now. So shout out to everybody that is watching from London. We've got a London local giving a talk here, and Raza, and Human Loop is doing some incredible stuff. I want to let everyone know that in case they want to go deeper into Human Loop, remember, we've got the Solutions tab on the left-hand side of your screen. You can click on that and find all kinds of good details about Human Loop. And speaking of live in-person events, we are tuning in right now to Amsterdam. That's a live view of people having some drinks and pizza by the bar and watching us live 20 seconds later. So they're not going to realize it, but we are putting them on screen, and they're going to see it in just a moment. And by the time they see it, they're not on screen anymore. So Raza, man, I'm going to hand it over to you. Feel free to so you got your screen shared. There it is. All right, cool. Now I'm giving it to you, and I'll be back in 20 minutes, 25 minutes, man. Talk to you soon.
Awesome. Thanks very much, Matt. And nice to meet everyone who's virtually out there joining us. What I wanted to chat about today was some of the pitfalls and best practices that we've seen from putting LLMs in production or helping others do that at Human Loop. So maybe just to start off with, why are we sort of in a position to talk about this? So Human Loop is a developer platform that makes it easier for people to build reliable applications on top of large language models. We've been doing this for over a year now, so not just post ChatGPT, and we've seen several hundred projects both succeed and not succeed in production. And through that, we've gotten a sense of what are some of the things that really work, and also what are some of the things that seem like they might work or feel like good ideas, but actually end up being pitfalls or are kind of things to avoid. And so that's what I'm going to try and talk about today, which is what are some of those lessons that we've seen and how can you apply them to try and get to more reliable, robust LLM applications in production. So before I kind of dive into the pitfalls, best practices, etc., I think it's helpful for all of us to kind of be on the same page about what we're talking about. What are the components of an LLM app? How do I think about this? And so the way I think about it is that LLM apps are composed of traditional software with blocks, what I call an LLM block, which is the combination of some kind of base model, could be Anthropic, could be OpenAI, could be a custom fine-tuned open source model, and then some sort of prompt template, which is a set of instructions or a template into which data is going to be fed, and some selection strategy for getting that data. So it's becoming increasingly common to do things like retrieval augmentation followed by generation, where a user query comes in, you search for something, and that gets pulled into the context. GitHub Copilot grabs code from around your code base and puts that into a prompt template. In ChatGPT, it's the history of the conversation that's there. But in either case, you've always got these three components. And then, if we have agents like we just discussed in the talk previously, then you'd be chaining these together in some way or putting this in a while loop. But fundamentally, in order to get something to work well, you've got to get all three of these pieces right. And so we're thinking about what is the right base model? How do I come up with the right prompt template? What data goes into it? What's the selection strategy? Where is that coming from? And the challenges to building strong LLM apps are that getting each of these three parts to be good is still difficult. Prompt engineering, which is the art of coming up with that template or set of instructions to the model, has a big impact on the performance of the model. So small changes can have quite large differences in performance, but it's difficult to know what those changes are unless you do quite a lot of experimentation. And then, hallucinations, or the bullshit problem, as I call it, is something that comes up quite a lot. How do you stop LLMs confidently answering things incorrectly? Evaluation is harder than traditional software because it's often very subjective. And then if you're using the largest models, then they can quickly become very expensive, or they may not be appropriate for situations where you need very low latency. So how can you go beyond some of those things? And related to these challenges is just a host of questions that you have to start thinking about once you get into the weeds of building this. You start off with like, okay, what model should I use? Should I be going open or closed? How do I find good prompts? Should I be using chains or agents? Do I use tools? Do I stick to prompting? Should I fine tune? Should I not fine tune? It goes on and on. And actually, there's a lot of small decisions that you got to get right in order to get good performance. And so what I want to talk about across this is sort of, how can you get the right structure in place to get those decisions right? And what are the differences between the people who succeed and the ones who don't? So that kind of naturally leads me into talking about the pitfalls and best practices for building LLM applications. And there's really four that I'm going to talk about here. There's a fifth one I'll sneak in later, but four that I want to talk about. And I'll go into detail on each of these across the next slide. So I won't dwell here for too long, but I've left this slide in here so that you guys will have a summary at the end and we can come back to this. But the first one I want to talk about is objective evaluation and the fact, the necessity for objective evaluation. So one of the pitfalls that we see is that for some reason, when people come to build LLM applications, especially because prompting feels different to traditional software, they don't put into place as systematic a process for measuring things as they might otherwise. So they start off in the OpenAI playground and they're eyeballing a couple of examples, they're trying things out. If they do have a retrieval augmented system, then even if they do have an evaluation system in place for the whole thing, they maybe don't look at evaluating the quality of the retrievals versus things that are a result of the prompt or versus things that are the embedding. And the mindset for some reason seems to be a little bit different to how you might go about doing traditional software. I think it's very natural to end up in this because it feels like you're just programming in natural language. And then related to this, people don't plan ahead for when things are in production. What are the feedback signals they're going to need to be able to monitor things or measure performance? And they ultimately end up trying to shoehorn this into traditional analytics tools like Mixpanel, or they dump logs to a database with the intention of looking at those later for driving performance improvements. And they end up not looking at them or not really having a sense for how things are working. And the consequence of this is that either people give up, they try something and they think, oh, it doesn't work. So we've seen a few companies, different companies running in parallel, some of them achieving a goal and others like mistakenly reaching the conclusion that it's not possible with LLMs. Or you see people just trying a lot of different things one after another, changing the retrieval system, trying chains, trying agents, doing different prompting strategies, and they don't really have a sense of whether or not they're making progress. And so that's the kind of risk here. And I also wanted to talk about, okay, what are examples of getting it right? And before I do that, actually, it's just bearing in mind that evaluation matters at various different stages of building these applications. And so some people have it in some of these, but not in all. So the place where it's often missing the most is actually during prompt engineering and iteration. You're tweaking things very quickly. It's very easy to try a lot of different changes without versioning them or seeing the history. But it's also actually important to have good evaluations once you're in production, so you can monitor what's happening and whether or not your users are actually having a good outcome. And then finally, if you make any changes, it's hard to avoid regressions. These are the same problems you have with traditional software, but now if you're going in and changing a prompt, or you're upgrading from one model to the next or something like that, how do you know that you aren't causing problems or causing regressions? It's not as easy as it is for traditional software. So maybe to look at one example of an application that really gets this right is, I think, GitHub Copilot. And it's an interesting one to look at because they also took evaluation really, really seriously when they did this. So GitHub Copilot, most people are familiar with, coding assistant, one of the most successful applications of LLMs out there, well over 1 million users, and serving a quite critical audience, software engineers. And one of the things that they do for evaluation is they rely very heavily on end user feedback in production. So they're looking at when you get a suggestion from GitHub Copilot, was that suggestion accepted? But not only was it accepted, but does it stay in your code at various different time intervals later? So they're really getting a very strong signal of, was the code they generated actually useful to people? And that allows them both to monitor the application well, but also take steps to improve it later. And just the amount of thought and engineering that's gone into this, I think speaks to the importance of having appropriate evaluation tools in place. And it's not just GitHub Copilot that does this. I think the best apps that we've seen out there, and I just put a handful here, ChatGPT, Find, Sudowrite, others, try to capture both explicit and implicit sources of user feedback in production, in addition to human feedback during development, and use that for monitoring improvement and development. And so, one thing that the pattern that we've seen to work out really well is trying to capture these three types of feedback. Votes are like the simplest one that you'll see in applications, things like thumbs up, thumbs down, but also actions. So implicit signals of what is and isn't working. And then finally, corrections. If users are able to edit a generation, then that's a very useful thing to be able to capture. So if you take the case of GitHub Copilot, being able to capture any edited text is extremely helpful. And then so that's the first sort of pitfall, but also best practice, right? Which is the importance of having objective evaluation. If you can't measure things, then you can't improve them, and kind of everything else in terms of all the effort you pour into your applications can go to waste. The next one that I think is underappreciated is actually the importance of having good infrastructure around prompt management. We have all of these new artifacts floating around that affect the performance of our applications, but it's easy to not give them the same seriousness as you would to your normal code. And so it's very common to see people starting off in something like an OpenAI playground and then using Jupyter to kind of push the experimentation a little further. Maybe prompt templates end up being stored in Excel, or if they're collaborating with non-technical teammates, they maybe put them in that in Google Docs as well. And the problem with this is it's really easy to lose histories of experimentation. So you're trying lots of stuff. You're implicitly learning a lot in that process that your teammates then don't have access to. So you're not accumulating learnings. We've seen companies actually run the same set of evaluations with external annotators on the same prompts multiple times because they hadn't realized that across teams they basically tried the same thing. And so a lot of effort gets spent trying to solve this. And then I think people also underestimate how hard it is to get the right tooling in place for this. So it feels like maybe you can hook together a Streamlit app and Jupyter notebooks with spreadsheets and get something that works quite well. But the challenge is that they become the maintenance burden becomes really high, and it's difficult to have the right level of access controls to who can deploy things to production or not. So you often either have a lot of friction with getting things from that system into code and into production, or you end up in a situation where if you do what might feel like the most natural solution, which is let's just keep everything in code and use Git for versioning and management, right? These are prompt templates are fundamentally just text artifacts. They're like code. The problem that we've seen with that is that unlike traditional software, there's typically a lot more collaboration going on between domain experts who might have an ability to contribute to prompt engineering and software engineers. And so if you put everything into Git, and you should definitely do that, but you don't also have a way for the non-technical experts to contribute to that or change it, you end up creating a lot of friction in sort of how well the team can sort of work together. And so, the solutions here, there are many options. Human Loop works on this. You don't need to use Human Loop, but I think there are three things that you want from a system like this, whatever system you choose to have, that makes it work well. Which is one, you want it to record a history of everything you're trying throughout experimentation, right the way through from when you're playing in the playground to when you're doing more quantitative evaluation. And you should be storing what was the history alongside the model config and making it genuinely easily accessible so you can draw conclusions from that. And it needs to be accessible to both non-technical and technical team members. Because if you separate this into code, then you end up alienating a really key stakeholder in this process. So that's kind of where I want to leave that one. The next one I want to talk about is actually avoiding premature optimizations. And this relates really strongly to the previous talk that we just listened to. So I think the phrase was used, my friends on Twitter are gaslighting me with how good these AI agents work. And actually in practice, that's what we've seen happening with people who've tried to put this in production as well. So we've had a number of customers who have tried across a wide range of use cases to try and build with agents or chains, and sometimes moving really quickly to quite complicated sets of chains or agents to try and get things to work, and later on having to rip these things out. And the problem with doing that too soon, and I'm not saying that chains of models don't work or agents don't work in certain circumstances, they definitely do, and we've seen positive examples of it. But if you do it too soon, it makes it harder to evaluate what is and isn't working, because you have multiple different places that you're changing things, and so you have this combinatorial complexity. Or I have 5 different prompts in a chain, so which one of those is affecting outcomes? It becomes harder to maintain things over time, because as much as you might try to modularize this, changes in one place often affect things down the line, and it's also harder to evaluate. So the kind of advice on this one is actually to start with the best model that you can get your hands on. So typically this is one of the largest LLMs, GPT-4, Claude from Anthropic, whatever it might be. And don't over-optimize costs and latency. Don't over-optimize the complexity of stuff early on. Focus on the limits of what you can do with prompt engineering initially. Push that as far as you humanly can. And then once you've done that, the next thing that I might consider would be fine-tuning smaller models to try and improve performance or latency. And I would only go to agents or chains if you're in a situation, more complex chains, if you're in a situation where reasoning is really important and where you have explored these other alternatives and found them to be wanting first. With one caveat to that, which is there is like a very common chain, there are 2 caveats, I guess. One is chat. You can think of as chat as the most primitive agent, and that obviously works well. And the other is retrieval augmented generation, where you're first kind of calling from a database of some kind, putting that into a prompt template, and then calling the model. Those chains work, but more complicated ones, I would discourage people from starting there unless they've already explored alternatives and seen how well they work. And so, when people start off with prompt engineering, they hit the limits. The default today feels like it's to go to something like chaining or agents, but actually, I think this is another kind of common mistake, which is to underestimate the power of fine-tuning. So people have gotten so used to the power of these very large models that there's a tendency to assume that fine-tuning smaller models will either require more data that they can get their hands on, or that small models, it's anything smaller than GPT 3.5 won't be effective, so it's not worth trying. And actually, I think this is a really common misconception. Like, we quite regularly see customers successfully fine-tuning smaller models, often not relying on that much annotated data. So sometimes hundreds of data points is enough for them to get started, and thousands of data points can get you really good performance in terms of annotated data for fine-tuning. And when you've got a smaller model, you're getting the benefits of increased cost and lower cost. The consequences of not doing this, that's what my slide says, are increased cost and latency, reliance on models that are larger than you need, and the fact that you don't benefit from proprietary data. And by that, I mean that if you are fine-tuning and you're capturing feedback data in production, then actually this can give you a bit of a data flywheel where you're able to improve the performance of your applications quicker than your competitors, because you can, for your specific use case, get better at that task, right? The very largest models are very general in their capabilities, but if you're trying to generate a sales email or you're trying to answer questions about a legal document, you don't need GPT-4 to be able to do all of the other things it can do, like write poetry or answer questions about sports, whatever it might be. Those are not relevant tasks. So fine-tuning can be very effective. And we see this kind of often underestimated, and people are very surprised when they try this. We had a customer who spent, I think, 3 weeks doing different forms of prompt engineering. They tried retrieval augmentation, embedding their kind of history of data. And we asked them, if you have all this historical data to embed and it's not changing very quickly, have you tried fine-tuning? And they hadn't. And when they did, it outperforms GPT-4 on a much smaller model for their task quite quickly. I think they did 3,500 data points. So another kind of concrete example of this in practice is one of my favorite startups. I use this pretty frequently, which is a company called Find, which is a search engine for developers. So it's LLM-based search. They do, like we've discussed, retrieval first. They put that into a template, and then they generate an answer to your question. But they're very much focused on questions that are relevant to developers and software engineers. So their model needs to be much better at code and those things, but it doesn't need to be good in general. And they started with GPT-4. They gathered a lot of different, user feedback in production, and you can see that on the right-hand side. I just grabbed a snippet of all of their kind of feedback buttons that they have in the app. And as a result, they've been able to fine-tune a custom open source model And that model is now, or in the case I've written here, open source model. I'll fix that after. And that is now better for performance in their niche than anything that you could get from the closed model providers. It's not better in general, but it is better for their specific use case. And I think it's a really telling case study. And as a result, they have lower costs, lower latency, and better performance. And I asked them kind of if they had any recommendations on what the best performing open source models are. And they recommended the Flan T5 and Flan UL2 sort of family of models from Google. They also said they're exploring Falcon right now, but they've had a lot of success with those models. And I kind of mentioned this in passing, but fine-tuning builds you a level of defensibility that it's difficult to maybe otherwise get. And a very common pattern for doing this that we've seen in terms of the best practice that works well is people will generate data from their existing model. They'll filter that data based on some success criteria. And that criteria might be explicit user feedback. It might actually be another LLM scoring those data points for how good they are. And then they'll refine tune. And often they can run a few cycles of this while still getting improved performance over time. And so, I come to the end of my talk and really want to leave you guys with a message, which is that we need to draw the right lessons from traditional software with respect to building applications for large language models. So it's not that we want, in the beginning, I talked about people having maybe a casual or less rigorous attitudes toward things like prompt engineering than they might otherwise have compared to normal traditional software, because it feels like it's in natural language and maybe isn't quite as, it doesn't feel the same as code. I'm not advocating that we should copy all of the same things from traditional software, though. I think that actually we need, in this case, our own set of tools that are appropriate for the job, that have been designed from the bottom up, from first principles, with LLMs in mind. And I kind of jotted down some of the traditional software principles that you might have, but thought about why they're different in the case of LLMs, right? So the first point I spoke about, having prompt management and having a good way of handling that. We have solved this problem for traditional software. We have Git, we have version control. So why do we need something different? And in this case, the big difference with LLM applications is there tends to be a lot more collaboration between technical and non-technical team members. Prompt engineering is something that actually you often want a domain expert to be involved in. And also the speed of experimentation and updating is just a lot higher. So for traditional software, you write a spec, you can write tests, you get something going, and then you deploy it. And yeah, you're going to change and update it over time, but not at the frequency that you're going to be doing this for LLM-based models, whether that's fine-tuning or updating prompts. And then when it comes to evaluation and testing, obviously we do evaluation and testing for traditional software, but now we're in a situation where the outcomes are non-deterministic. There's a lot of different criteria for success because everything is so much more subjective. So it's much harder to write down an objective metric like accuracy or even just write a unit test than it would be compared to even traditional machine learning, where at least in you're doing classification or NER or something like that, there is a correct answer. Here it's not so clear cut. And then when it comes to something like CI/CD, we obviously want something similar for LLMs, right? We want to avoid regressions. We want to be able to make changes without worrying about it. But we need a different type of tool, partly because we want a much faster iteration cycle than we might for traditional software, right? You can go in and make changes in natural language to a prompt and have an impact from that almost immediately. We want to be learning from data. And so having the ability to kind of co-locate feedback data and be able to use that as part of this process is different. And it's just much harder to write unit tests. You can maybe use LLMs as part of this because they're quite good at evaluating their own outputs. But it's, there isn't a correct answer for a lot of the things we want LLMs to do, which is why we need to have something that's slightly different. So I would be encouraging people to think critically about being rigorous in their development of LLM applications, especially if they want to see success in production, but also to kind of acknowledge the differences in what they're doing now compared to traditional software. And that's really, what we've been thinking about as we've been developing applications at HumanLoop. We're trying to build the right tooling for this paradigm from the ground up. So thanks very much. And if there are any questions, I'd be very happy to answer them.
Dude, oh, you saved me. Your timing is impeccable. And I just have to say that you make my job much easier. So
I'm very glad, Demetrius. I had a little stopwatch up in front of me. I was like, if I can get the same stuff in, then I'll accelerate in the places where I can.
Yes. So now we have time for questions. There were some awesome questions that came through in the chat, and I get to ask you to them directly. First things first, how do you manage these so-called data leaks that you spoke of?
So data leaks, I'm not going
to... Or leaks, I think is what you said. Maybe I threw in the data there.
Did I mention leaks? Does someone mind just like clarifying what they
Hey, Drum, yeah, in a minute, tell us what exactly you mean by leaks, and I'll go on to the next question, which is a bit of an ethical one. It's a beefy one, so
excellent.
Get on your ethicist hat. What are your views on the ethics of GitHub Copilot sending telemetry data back to Microsoft? Is this an example of opting into alignment or something more sinister?
I think as long as people know upfront what they're signing up for, and you always get the permissions from users to capture telemetry, then I think it's fine, right? People have to be willing to give that. People have to give it willingly, and as long as it is willingly given, and everyone's like clear on what's going on, then actually it improves the service for everybody and everyone benefits together. But I think like where it's a bit sinister is if they were capturing these things without permission. So for me, that's the ethical line that I wouldn't want to cross. But as long as you make it clear to your users what you're doing, I actually think this benefits them.
So basically, if you say it, it's cool. If not cool. No bueno.
Bueno.
Yeah, let people choose. That makes sense. All right, so do you have examples of tools we can leverage for prompt management aside from general solutions like Google Docs, etc.? I think you may know a tool that helps with that. Is there? Yeah, it starts with an H, ends with a P.
In this case, like part of the reason I've seen this so much and thought about it so much is because this is part of the Human Loop platform, right? So part of what Human Loop does is it gives you a place where your team can iterate on prompts, find out what works, evaluate performance, manage CI/CD. Like the reason that I'm able to talk so deeply about some of these problems is we've been building tooling specifically to solve them. So I'd encourage you to come check it out. You can sign up and try it for free. And yeah, that's my main recommendation.
Few questions that came through about fine tuning. Is there a way? So basically, there was one that said, "I have a." I'm trying to. Every time somebody asks a question, then it pulls me back down. So I have a. Can I use a 16 gigabyte laptop with GPU without GPUs to fine tune Falcon? And I guess they're talking about, I mean, the small Falcon, I would assume.
Yeah, I would assume so. Honestly, I would assume not, but I don't know. As in, like, I'd be very surprised if it's the case. Like, we've been getting Falcon up and running, to try and include it as one of the models in the Human Loop playground and working with a company called Mystic AI that I'll give them a quick shout out to because they've been super helpful to us. And it's been hard work to actually get those models to be served and performant and have low latency and fine tune them. So, and that's operating on a lot of GPUs. So I'd be surprised if you can get the Falcon model, even the medium sized one. There's two, right? The smaller and larger, running on a laptop without GPUs at 16 gigs. But people are very creative, and maybe you can quantize it or do something smart. So I don't want to say it can't be done, but I'd be surprised.
Just, yeah, maybe next week somebody's going to come out with something cool, like run it on your phone. It's all good. So going to the question about, and I'm just checking time. This might be our last one because I wanted to get in a quick meditation during the break before we have Walid's talk coming up. There is an awesome question here from Matt. Specific version of the data leak question. How do you and Human Loop think about the model exposing private information that it's been pre-trained or fine-tuned on? If you fine-tune on docs that not everyone at the company has access to and someone prompt injects it to get the output.
Yeah, so this is a really interesting question, and maybe I can expand a little bit on just explaining what Matt means for people out there, because I don't know if everyone's kind of come across this issue before. But the situation that you would be in is you go and you gather a bunch of data and you fine-tune a model. And some of that data you gather may be private to, maybe a subsection of your company, but now it's stored in the weights of your model somehow. Could other people at the company exfiltrate that data that they shouldn't have access to, and how can you kind of mitigate or have that control? And the honest answer is, I think beyond fine-tuning separate models or not using instruction-tuned models, I don't think there is a very clear-cut solution to this yet. I think this is like something that people are still working on. So what we've seen, I haven't actually seen a situation where people have shared a fine-tuned model across people who wouldn't all have had access to the training data. So it's either been in cases where the training data was like publicly available, like Find, where they were fine-tuning on search results, or it's been within a company department where everyone has data access. If you were trying to control that, my suspicion is you might want to have something like adapters. So these are like lightweight things like low rank, basically changes to the model that you can fine tune and swap out, so that you could have multiple different versions of a fine-tuned model, of which you could control access in certain subsets of your company. But I think it's an unsolved problem.
Dude, awesome. There are a few more incredible questions coming through in the chat, and so I am going to direct you there. If anyone wants to talk with Raza, keep the questions coming. And
I'll jump into chat and I'll answer people there if people want to continue.
Here we go. There were some awesome ones. So, Raza, my man, thank you so much. And if anybody wants to know more about Humanloop, you just got to click on the Solutions tab on your left-hand sidebar, and you can go down and explore the booth, talk with some people, and also, if you're in London and you're at the watch party that's happening, what's happening? And thank you, Raza, for making that happen. Thank you for sponsoring this event. It is so cool to have you here. And of course, thank you for the wisdom.
And thanks so much for having me, and thanks for organizing an awesome conference.
There we go. All right, man. I'll see you later. And I know we are very tight on time. And Walid is supposed to start theoretically right now, and that was after a 20-minute break that we were supposed to have. So you can tell the one job that I am supposed to be doing, I am not doing well, but I feel like we all need just a minute to take a few deep breaths together, because I put that we're going to do a little meditation, and it's going to be guided by me. And so let's make it happen. It's going to be 2 minutes, 3 minutes maybe, but it's going to be a way for you to stop staring at a screen and have a little me time. So this is where I turn the gain down real low. You're going to have to turn me up, and I get the ASMR voice going on. And let's maybe even turn down one of these lights so it's nice and setting. Let's see. There we go. All right. First thing we're going to do is find a comfortable position. Feel free to close your eyes if it helps you. And in this meditation, we're going to do what I like to call, and many others like to call, box breathing. So the whole point of this box breathing is that you breathe in for the same amount of time as you breathe out. And at the top and bottom of your breath, you're going to be holding it for the same amount of time that you're breathing in and out. That may sound a little complicated, but trust me, as we get into it, it becomes second nature. So we'll just take a few deep breaths, allow ourselves to feel what's going on in our body, to notice whatever thoughts are going through our head. Start to hear the sounds around us. And for this box breathing, we're going to do a 4 count. So that means we'll breathe in for 4. We'll hold our breath at the top for 4. And we'll breathe out for 4. And hold for 4 at the bottom of the breath. I'll guide you along as we start to do it. Let's go with the inhale first. 1, 2, 3, 4. Hold your breath. 3, 2, 1. Exhale. 3, 2, 1, and hold it again. 3, 2, 1, and we're going to repeat that. 3, 2, 1, inhaling, now holding it. 3, 2, 1, exhaling. 3, 2, 1, holding. 3, 2, 1, and repeating again. Holding, exhaling, holding, inhale, hold, exhale, hold for the last time. Now relax your breath. Let it go back to normal without forcing. We're going to take a few more moments here before we come back. Take one last deep breath all together. Open your eyes. And back into go mode. Let's do it. All right, so hopefully that helped you look away from the screen for just a moment. I know we have been here for a couple of hours, and so that gives you a moment of bliss amongst so many moments of insight. Now I get to bring my man Waleed onto the stage, but before we do that, I gotta turn up my microphone to make sure that I'm not in ASMR mode anymore. You there? What's up, Waleed?
Hey, how's it going, Demetrios? Are you doing all right?
I'm doing great, man. I'm blissing out now after that one.
Oh, yeah. Now I'm all soothed.
There we go. There we go. Stretch it out if you need to. And wow, awesome. So everyone is very clear-headed now, I believe, for your talk. And they are ready, but we need to just school them on the fact that there is an AnyScale Ray workshop happening in person once we finish this conference today online, and it is happening in San Francisco. So we actually filled up the full conference. Sorry, the full workshop. The conference is pretty full too. I mean, there's like 2,000 people online right now. So that's pretty full, I would say. But we filled up the workshop. There's like 50 people on the wait list. I'm not going to be the guy that says it, but I bet if you just show up and you slip the doorman 100, you'll get in. All right, that's all I got to say. Waleed, take it over, man. It's all yours.
Hey, thank you very much, Dee. It's really great to be presenting at MLOps community and LLMs in production. I have an update. You know, obviously things have moved very fast in the industry. But the last time I talked at an MLOps event was a few weeks ago, 2 weeks ago, and we were just giving people a preview of Aviary. And now what I hope to share today is our first 2 weeks of the painful lessons we've learned building it, deploying it, and getting it running. So what I'll be talking about today is really about the lessons we learned. And this is one of my favorite quotes, which is that experience is a good school, but the fees are very high. So my goal today is to avoid you paying some of the fees that we did. So if you learn some of the things about what it takes to really deploy LLMs in production, or at least our experiences from it, then I will have done my job. So we're going to start off with something very simple, which is, there's lots of different ways to focus, how you deploy LLM in productions. But the ones we'll be talking today about are self-hosted models. In other words, you as an organization run and maintain the model, usually based on an open source foundational model that you've fine-tuned, or maybe you're just using it as is. But first, let's dig into the question of why you would want to use, why would you want to self-host anyway? Second is we'll talk a little bit our exploration and what we built, something called Aviary Explorer, which has been out now for 2 weeks. And then we'll share some lessons that we learned the hard way, right? First one is model selection is tricky. Serving LLMs turns out to be pretty hard in many ways. Be prepared for deploying more than just a single LLM, understanding the importance of GPU RAM, and finally, how do you keep costs down? And what we'll be doing is we'll be giving you a little bit of a behind the scenes look of how it works. We'll be showing you our dashboards, our tooling of our live production service, just to give you an idea of what we learned during this process. So the first question I wanted to discuss was really, and one other thing, we'll be doing lots of demos. So hopefully the demos don't die. So when you try to deploy an LLM in production, you really have 3 different choices, or 4 choices, but I think the 4th choice is kind of very rare. So you can either go to a commercial company like OpenAI, Anthropic. You can go to a hosted open source solution like Hugging Face, Mosaic, Octo AI. And again, these slides are super fresh because the Octo AI just launched yesterday. We'll talk a bit about Aviary coming forward and how you can do that. Anyscale is the company behind an open source project called Ray, and as well as a managed hosted service called Anyscale. And what we'll talk about today can work both ways. So everything I'll be showing you, except for one small thing, is completely open source, and you can have a play with it. The third option is really self-hosted. So usually what you'll do is you'll take an open source language model, like the language model du jour is, of course, Falcon, with its 40 billion parameters and the smaller 7 billion parameter model. And then you'll either deploy it as is, or you'll do your own fine-tuning on top of it. There's a small fraction of companies that are building their own LLMs from scratch, but I don't think that represents the majority. For those companies, they often end up using Ray with both OpenAI and Cohere, who are building those commercial applications using Ray, the open source toolkit that we've made available for distributed computing to train their models. But that's not going to be the focus today. So why would you want to use self-hosted LLMs? And the way we think about it is we're big fans of self-hosted LLMs at Anyscale. But we're not blind fans to it. We use GPT-4 for some things, and you just want to deploy the right tool for the job. But in particular, I think the advantages of OSS LLMs is you have control over your data. You might have regulatory restrictions, and you might just decide that, LLMs are a competitive advantage. And I don't really want to share it with a potential competitor. Who knows what OpenAI is going to do next? Second reason is cost. And, GPT-4 at the high end can be very expensive at 10 cents per 1,000 tokens. So we work with a company called Kappa, and they help us with document search for Ray documentation. It works really great. The only problem is that they charge us 25 cents per query, which is just ridiculously expensive. But they don't have a choice because the backend is GPT-4. So we want to be careful about costs. You never want to be in a situation where your vendor has locked you in, because that removes your negotiating position when it comes to cost. And finally, customizability. So you want to do things like fine-tune your models, but if you go to the commercial companies like OpenAI, they will charge you 6 times as much for serving a fine-tuned model as a non-fine-tuned model. So the one area that I think open self-hosted LLMs are not quite as good is quality. And this is something that's changing. There was a really interesting Google paper that said we have no moat, and they actually plotted the graph of how quickly open source quality is improving. Testing is starting to show that the gap is narrowing. So that's from places like LMSys and so on. And finally, we've been running some experiments. We're not ready to share the results yet because they're a little bit preliminary. But what we're seeing is open source is perfectly good enough for things like summarization and retrieval assisted generation. So it's not that they're plug-in replacements for the full power of GPT-4, But if you think carefully about your use case, you may be able to find a good fit. So just trying to summarize these options here, this is a chart that I hope you find useful as you're trying to choose, when do I use commercial APIs, when do I do self-hosted, and what the pros and cons are. Clearly, for example, the hosted approaches are easier to use. Self-hosted has some risks. Obviously, what I'm trying to do and what we're trying to do with Aviary is turn this sad face into at least a neutral face, if not a smiley face, to make it easier for people to build self-hosted models. So now let's dive into the lessons. The first lesson is, wait a second, it's great that you have a self-hosted model, but how do I choose the right OSS model? What size do I need? How much does each option cost? Where are the quality characteristics? Some models come with up to 4 tunes. Which of the 4 tunes do you use? So the first thing that we did is that we built some tools, and I'll walk you through those tools right now. So the first is Aviary Explorer, and that's you can try this out yourself at aviary.anyscale.com. And so I'm just going to give you a quick overview of Aviary, the tool that we built, and then we can. I'll also show you some of the command line tools that we've built. Right. So this is Aviary, and as you can see here, it allows you to choose different LLM models. You can choose different characteristics. We have certain options, like you can choose the fast option, which chooses the fastest LLMs we have. And then you can just quickly type on like whatever you want your prompt to be. And you can click. And then very quickly, you can compare these 3 LLMs and see which ones you find personally more acceptable, which ones work better. The latency is going up, I can see. Probably all of you are hitting the website soon. We'll see if we see the spikes. But you can see that the outputs of each of them, and importantly, we can measure things like the latency, the cost, and the tokens per, how much each of these models costs. And so that gives you a quick overview if you just want to kind of see on the surface. Of course, it's also possible for you to load your own models. So what you could do is you could also have fine-tuned versions of your own models that you put into this list, which we'll talk about later. The other thing we're able to do is very easily to kind of, we've allowed people here to vote. So, I might come here and say, you know what? Well, this one doesn't have 5 books in it. So maybe we'll just choose this answer. And this one's too verbose. So I'm going to choose this answer. Now, imagine what happens if we have people around the world filling that in. And what we can build is we can build a leaderboard of like, what are the best LLMs for this particular use case? Not only can we build a leaderboard, and there are other websites that have leaderboards, but I think one of the unique characteristics for us is that we've tried to characterize things like the cost, the latency, and so on, so that you can build a model. Now, there are some simplifying assumptions here, particularly that it doesn't fully include batching, and batching can have a 10x impact. So think of these as an upper bound. But what I can do, for example, is I can sort by the fastest, which also means the cheapest in terms of generating outputs. And you can see that Amazon Light GPT is pretty fast, but unfortunately doesn't rank very highly on performance. Whereas I think the superstar, and some of the models that we're seeing people want to use are things like like the chat model from Mosaic ML or Open Assistant. So let's have a look at those, what it looks like, in terms of the cost. And we see, not surprisingly, like that those are some of the most expensive ones. Mosaic Chat is not too bad. But you can also see that part of the reason that something like StoryWriter or Open Assistant are so expensive is not because it's the cost per token is high, but it's things like Open Assistant likes to generate like long answers, and the same thing for StoryWriter, which is that was what it was fine-tuned for. So we hope that you will find a tool like this useful in your selection of the appropriate model. Let's go to a live demo. This is that, so that's just the UI version. But what we can also do is we also have some command line tools. For example, if what you can do is we've created this Aviary command, and then Aviary backend can list all of the different models that it has available to it. This is the same model that you folks are hitting really hard right now. And you can get a list of models, but what you can also do is you can let's say that I have a bunch of prompts. So I'm going to look at something like example/QA prompts, right? I'm just trying to, what I might be doing is I might be working on a trivia bot, and I want to work out, are the answers good or not for these different questions. So what I can do is I can actually now run a query on this. And what I can do is just compare two outputs. So we said that Mosaic was a good one. We've also added a capability to compare with OpenAI. And it takes that input and it's now just going to sit there and process it, sending the Mosaic MLs to our backend, and at the same time, just sending those same queries to OpenAI. So that will take a few seconds, but very soon we'll be able to get the results there. And so we've asked it a few trivia questions, and now it's going to hit OpenAI to just show us what the results possible there are. But you can see this tool is kind of making it much easier for us to evaluate what the open source options are. And yeah, so that gives you an idea of like how we approach the problem of how can we help people understand what the right LLM model for them to use is. Cool. So I'm going to continue now. Hopefully, if we have time, we might see what the results there are there. But then the funny thing happened as we were trying to build this application. And that is that we found that deploying LLMs is harder than it looks. It's one thing to say, oh, that's a really great app. And then, that's very fun. But really think about what it took. It took, what we found the hard way was managing this aviary, so to speak, of 12 models was giving us headaches. And the initial assumption might be that what you just got to do is I can just download the model from Hugging Face and run that. And what we found is that it's much harder than that. You have to think about different definitions of roles, different markers, all that kind of stuff, different stop tokens, different accelerators that work for different models. Some need more GPUs, some need more GPUs, as well as support for things like batching and streaming. So that's the challenge we faced. And as we thought about it, we thought, maybe there's a way we can define a configuration that allows us to specify what we want and to prepare each model for production. And we were really excited about this because once we added this kind of model config abstraction, Demetrios, is everything okay?
You knew I am the bearer of bad news. Yeah, you were just sharing, you've been sharing Avery this whole time and you didn't share the CLI. So I'm realizing now that there was a few things that people missed out on.
Okay,
But
so
there we go. There it is.
let me rewind. Sorry for that,
Yeah,
folks.
that's all good, man.
Yeah, as I said, where we were was we ran this model. We tested OpenAI versus MPT, and it generated the output for us. So, let's put that model in a file called qa.json. And it has, all of the statistics of each of the models, what was the difference between one. And, we've also added a command called Avery evaluate. And what we can do is, again, this is the time to use GPT-4, is send those input to GPT-4 and ask it which of the answers were better. And very soon that should be able to produce a result for us and print a table that shows us what it thought the best results are. So hopefully that has given you an idea of some of the capabilities, and I apologize for the issue that we saw earlier. And I will remember to hit the share the tab button in future. Cool. So just in a moment, it will print a table, and you can see that it's basically scored each of these inputs and compared them. And in this particular case, this evaluation thing is still something that we're fine-tuning, but it gives you, you can see, looking at these results, that actually the open source results are not bad at all. They're actually very good for this particular type of application. All righty, let's go back to the slides and hit the share tab instead. So as I was saying, really, as a result of thinking about things in terms of model configuration, we were able to add support for a new LLM that came out in about 5 minutes. So let's have a look at those models and what one of those model configs looks like. So what we can see here is that we have a little config file for each of the different models. And you'll see that, in some ways, it's very similar, but you'll notice things like this. They'll use different strings to denote, what's the start of a string and the end of a string. If I compare it to the one for Mosaic ML, there's all this fine tuning you have to do. There's all of these settings that you have to make about, that use it slightly differently. Yep. And so you can see that there's differences in what we are trying to do, and the tweaks that we have to make to get particular models to produce reasonable values. But what we've done is effectively there's a little model config for each of the different models that we want to run. And ideally, and what happens a lot of the time is you just modify the model config a bit and it's able to run your new models. Or say you have a fine tuning model, you can do something like that. And it's just a change of the direction. Cool. So the third lesson that we learned was that you're probably going to deploy many models, more models than you think. So we thought at the beginning of this that we might have like 3 models. We might have like a small, medium, large. But very quickly, we found that we wanted to add more. Maybe there's different sizes. Maybe there's different fine tunes. Maybe you want to do A/B testing. And the other thing that we're seeing on the horizon is that there's a router design pattern where you don't have a single LLM, but you might have like 3 LLMs fine-tuned for different things. And then you kind of have like a router LLM that decides which of the 3 LLMs to call. Now, just that simple configuration, already we're talking about 4 LLMs. Cool. So very, very quickly, we started to realize that managing multiple models was very, very difficult. Each has different requirements and everything we needed. And could we make it so that deploying a new LLM was no harder than any other microservice? And that was really the genesis of the Aviary backend. And as you folks know, this is an LLM, there's kind of a very important DevOps principle, which is that you treat the things you're working with like cattle, not like pets. You don't have cattle, that you still care for them, but you care for them as a group. You don't ask a cow to come sit on your couch the way that you would ask a pet to sit on your couch, right? So this principle of treating LLMs like cattle and not pets really simplifies the management. And the declarative approach that we took of the model configs also simplifies that. So a model dies, it's okay. You can just load it from the model config again. It dies, Ray serve, and Ray, which is what the system is built on, has really good fault tolerance. So if one of the servers dies, it'll just bring up another one. And because of the features built into Ray and Ray serve, it's super easy. So what I'd like to do now is just show you a little bit about the real backend that's actually serving aviary.anyscale.com. So I'm going to click on share this tab instead. This is showing you the Anyscale, and right now the backend that you're seeing is actually this guy. And you can see that there's actually one service or one deployment for each of the different models. And then there's one kind of glue model called a router deployment that kind of holds it all together and redirects traffic. So this particular model, as we said, that's running in production, we're hosting 12 LLMs together, and we can click on any of them and get their statistics. But the thing that I wanted to show was just like the serve dashboard. So very quickly, you can come over here and you can look at, what are the statistics for like this service, what's happening to our traffic. And it looks like you guys have been busy. In the last 5 minutes or so, you folks have started to hit. And, we've gone from like 15 replicas to like 20 replicas very, very quickly. So that gives you an idea of like, how our backend works. We also monitor it in terms of like understanding how many users are using it. So I'm going to share this tab now. And this is, let me just do a quick refresh on this. This is our live traffic showing us, how many queries people have put in, what the token distribution is like. We realized that people were using us a lot for summarization, but also we notice that we're actually getting, you can see here just how spiky the traffic is. And that spiky traffic does not play well with LLMs, unfortunately. So this kind of gives you an idea of like, how it works, how we monitor it, how easy it is to switch. And you can very easily, I'm switching tabs now. You can very easily, let me see if I can clear this. You can very easily kind of deploy new models with this format. So I might, let me try this, and we'll run locally. This will probably take a while, but I can just specify the model config file, models, and let's say Amazon Light GPT. And very quickly, this model will load it up. So again, it's this kind of character of kind of making it very easy to kind of deploy these models and handle all of that particular issues. Cool. So let's go back to the slides. Lesson 4. It's all about GPU RAM, not about compute. So we have this page you can check out called llmnumbers.ray.io, numbers every LLM developer should know. And what you realize is that GPUs, how we use them when we're building LLMs is we use about half of it for model parameters and then half of it for working memory for batching. And batching is very important for performance reasons. Processing, if you didn't do batching, for example, you might see nobody else sees me.
Don't let me distract you, Wally. That was for the people that are waiting for the next talk.
Okay, cool.
You keep cruising, man. You're doing great.
All right, great. So it's all about the GPU RAM and really managing that. So you need this memory for both purposes. And that means that you have to think very carefully about how you lay things out in memory. So we often, how we dealt with that is we used bigger instances to allow for more efficient batching. So basically now we rarely use 16 gig GPUs. The A10Gs tend to be kind of our go-to GPU, and the A100s for the really big models like Falcon and Open Assistant that are 30 billion or 40 billion parameters. Often we'll need 2 of them because the parameters are so many they don't fit on a single GPU, and we'll run 2 GPUs in parallel. But the thing we're optimizing for is making sure there's enough GPU memory that we can do batching. And batching is where you might take 5 requests and send them at once to the GPU, which gets you much, much greater throughput at a small cost in latency. And so it doesn't really matter which GPU is faster. What the key thing to focus on is really which GPU has more memory. And generally, the A100s can be a bit pricey, but even the ATGs, going from a normal 16 gig GPU, which might be slightly faster, to a 24 gig GPU will probably give you a better performance improvement. And final lesson, cost management. So I want to tell you that, we like to keep 1 replica around. We can actually do scale to 0, but that introduces, a minute or 2 every time someone uses a new LLM. So we keep at least 1 replica of each LLM around just running so that they can get good results. And if you have 12 models, that's essentially 12 GPUs we have to get running. I know it might sound high, but it's actually after optimization. You just have to be very, very careful when you provision. So you really need to be able to auto-scale up and down, but that's not really the key problem. Because if your auto-scaling time is 15 minutes and you have a 20-minute peak, that's not going to be fun. So what we've done is we've really done a lot to kind of optimize fast loading and startup time. We locally cache the Hugging Face models, and we might use NVMe drives. These are very fast local drives to help accelerate that. You don't realize it, but Hugging Face, like any service, has variations in how long it's taking. So if you can run a local S3 and manage a local cache, then you can absolutely accelerate how long it takes for a node to come up if you're auto-scaling. And then the second thing is, this is the one part of this that's not open source. On our proprietary AnyScale service, we've optimized the crap out of starting up nodes, and we can start up nodes in like under a minute. So that's kind of within your system, you can optimize your fast startup time, or you can use Anyscale to do that. Cool. The other thing is that we very carefully fine-tuned the auto-scaling parameters. And we took advantage of raised serve capabilities, which is a very flexible system. So you'll see if I go and we have a look at one of those files again. And as we saw earlier, I just started a service with nothing more than an aviary run. And now if I do just the aviary models, it will tell me the list of models, but now I'm going to tell it that I want to use the local aviary host. And sure enough, we should see our local model. And our local model running on this machine only has LightGPT running on it. So it makes it very easy to load things up. But just looking at the dashboard over here and looking at the peakiness of the traffic, you can see that there's lots of variation. So if I look at the last 7 days instead, you can see that there's a lot of spikiness there. And we have to tailor for it. And so the way that we've done that is we've made it so that you can specify, what are the minimum number of replicas that you want? How often do you check to see what the look back is? So how frequently you're looking at those statistics, and also bias towards downscaling slightly slower, which costs a bit more, but it really prevents those types of peaks that you can't handle. So let's draw to conclusions now. What we've seen is that self-hosted solutions of LLMs have some advantages. If those advantages align with your particular use case, then it's a really good idea to use self-hosted options. But there are some things you need to pay attention to. You need to choose the right OSS model. You need to really think about what it takes to serve a model. You got to expect that you're going to be serving more than just a few models, and really think about GPU. And keeping costs down means you have to have things like auto-scaling. You need to fine-tune them. Now, as I mentioned, everything that's part of Aviary, except for that one little thing, which is fast node startup time, is open source. The UI is open source, the CLI is open source, the backend is open source. And so you can help us to build for the MLOps community a tool that allows them to more easily do self-hosted models. And so what's next? We're adding features like streaming, continuous batching, and more LLMs. So the key follow-ups here, you can try it out yourself. There's a open source for the whole thing. And if you want managed aviary, just drop us an email. And if you need some numbers to help guide your process on putting things in production, have a look at llmnumbers.ray.io. Thanks.
Dude, that numbers is so cool. I love that you all thought of that. And I would expect nothing less from you, Mr. Ali. That is just quality right there, man. And one question I had, that dashboard that you showed, that was basically, you had to set that up. Everyone is going to have to set up their own of those, or that comes right out of the box with Aviary?
So we have a public one that anybody can use at any time. If you want to run your own and choose your own models, you can do that too. We expect people to run their own Aviary. We've made it very easy. We can just give you a quick account and you can set it up on Amazon AWS very quickly. It just requires a Ray cluster to run.
Dude, so there are a few questions that are coming through here, and we are horribly late on time, as usual. So the panel that's coming up, they're being very patient with us, and because there's just too many good questions in here for me not to ask them. That was a great presentation, man, and awesome demo. Can you, okay, does it make sense to predict peak times and scale the cluster in advance? Is that possible?
Yeah, if you can, do it. you know, what we found is the peaks are very, very random. You don't know what time zone someone's going to be, you know, is interested in your system. We had an article come out yesterday, and all of a sudden the traffic quadrupled to the website. So the dynamic approach is probably the safer approach. But yes, if you want to, you can definitely just kind of say, I'm going to, you know, between 4 o'clock and 6 o'clock, I want you to have 2 replicas instead of 1.
Yeah. Yeah, exactly. If you can predict the future, get on it. There you go. That's basically the understanding that I got from your answer.
Yeah, and if you can advise me on stock trades, that would be even more amazing.
Yeah. Awesome. So last one for you, Waleed, and then I'm going to ask you to jump in the chat. And also, Waleed is on Slack, so if anyone wants to ask in the community conferences channel, just tag Waleed, and he's in there. But Gilad was asking, what would be the metric that auto-scaling is configured on? Traffic? How would you differentiate high memory consumption due to lots of small requests from a few large ones? Great question.
Yeah, I think that's something that we're still working on fine-tuning. One of the tricks with LLMs that's very different is, you know, a 2-word answer, you know, maybe a very short prompt has a very long answer. And that's where things like continuous batching become very useful. Because if you have continuous batching and you have streaming, it kind of evens that out, right? It's just, you know, what rate of tokens am I getting in and what rate of tokens am I getting out? And if you can model that, you can do that to more accurately predict things.
So good. Well, everyone, I am going to also, before I kick you off, Waleed, I want to say that AnyScale is an incredible sponsor of our LLM in production report that we just put out. So go get your hands on that, and thank you, AnyScale and Waleed. I gave you a whole lot of shit when you came on the podcast for not sponsoring, and you pulled through. You made it happen. You moved some budget around. So in case in case Avery goes out, it's because they probably spent too much money on this damn report sponsoring the community. So we need to help them. We need to help make it as reliable as possible. Waleed, dude, thank you so much, man.
It's been a pleasure.
This has been awesome.
And, you know, I'm really eager to answer your questions. Just drop me an email or just I'll be online on Slack to answer your questions too.
There we go. There we go.
See you later.
All right. See ya, man. It's been great chatting with you as always. It is a blast. And now I think that is a perfect segue into, because it feels like that was just like the warm up. That was a little bit of the sound check before we bring on our next guest. What's up, Shri?
Doing well, Demetrius. This looks like a great event.
Yeah, man. So I've got a shirt that I want to show you all, but I'm going to get everyone on stage. We've got Raul with his new microphone. And how you sounding, man? Oh, you got to bring it closer. Yeah, yeah.
It's right here. Can you get the ASMR fields?
Yeah, maybe not that close. A little too intimate for me right now, man. We've also got Manoj. I think it is very late where you are, but it looks light out. Is it already tomorrow where you are?
Fortunately, I'm traveling to, so I'm in Seattle right now. So it's the same time zone.
Whew. All right, cool. So that is awesome. And then where is my man Patrick? There he is. All right. Why am I in big? I am not the star of this show. I'm going to, as I make myself even bigger. Now, Patrick, what's up, dude? I love the Martin guitar in the back. That is awesome. I love seeing you all. And Shri, I'm going to leave it off to you. This is kind of a, what we would call a mix between a panel and a fireside chat. We've got so many incredible Kubernetes people in the same virtual space. And while you kick it off, I'm going to get this shirt that is so good. It is not the I hallucinate more than ChatGPT shirt. It is I got it just for everyone here. I don't know if you can see this. I got to make myself bigger, not because of my ego needs it, but because everyone should be able to see. That says, Kubernetes is a gateway drug. And that is what we are talking about. Kubernetes on running LLMs on Kubernetes. I am going to get off the stage now, and I'll drop a link in case anyone wants to buy that shirt and support the community. Shri, it's all yours, my man.
Thank you so much. Thank you so much, Demetrius. Hey, hello, welcome everyone. Thank you so much for joining this panel discussion fireside chat about large language models and Kubernetes. One of the more well-known instances of Kubernetes and LLMs coming together is OpenAI documenting a lot of how they've trained their models and actually serving ChatGPT and DALL-E and other models on Kubernetes. So I asked ChatGPT to write like a small humorous description about this session, and this is what it came up with. In a world full of errors, may your code be bug-free. May your containers be slim and efficient. And may they always sail smoothly like a rubber ducky in a giant data lake. Is this even possible? Or am I hallucinating? Well, on that maybe not so funny note, it's safe to say that there is a lot of work to do, especially when it comes to LLMs and humor. And maybe Kubernetes has a role to play in that. And that's just the perfect segue for us to kind of get deep into these conversations about how LLMs and Kubernetes coexist. How do they work, and so on. So before we get into the details, like it might be a good time to just have quick introductions. Manjot, do you want to go next? Introduce yourself.
Hey, I'm Manjot. I'm part of Lightspeed right now and investing in a lot of these new age LLM companies. So excited about that. But before that, life actually started as an infrastructure engineer, where I was building internal infrastructure libraries at Google. And from there, I became a product manager in the Kubernetes team. This was far into the Kubernetes 1.0 ages, when we were actually thinking about Mesosphere and other such things. So I was working primarily on networking and security, and eventually wanted to build something of my own, so left and started up in machine learning infrastructure. So and was lastly at Stripe.
That's fantastic. Welcome. Rahul, why don't you introduce yourself?
Yeah. Hello, everybody. I'm Rahul. I'm the founder of AI Hero. For me, Kubernetes is not just a great gateway drug. It is a way to just stay high all the time, right? So I actively think about how do you deploy the LLM ops stack. Apologies to use that phrase because it's not cool yet. But what exactly does training your own foundational models on Kubernetes look like? What does fine-tuning a large language model on Kubernetes look like? Or even deploying applications like the Q&As or search-based applications, agent applications on Kubernetes, and how that can help increase the velocity of what your company delivers or deploys is what I like to work on. Excited to talk to everybody.
Awesome. Thank you, Rahul. Patrick, what about you?
Hey, yeah, I'm working as an architect for a startup right now. We're focused on LM planning, which has been super fun to do. Historically, I've worked a lot in Kubernetes. I worked for Joe and Craig at a company called Heptio. We got acquired by VMware. Done a lot of stuff that put some features into Kubernetes and whatnot. And, over the last several years, gotten a traditional kind of machine learning 1.0. And then last year, been focused on generative AI, and now really kind of heavily focused on LM planning. So.
Awesome, thank you so much. And just for completeness, hi everyone. My name is Shri. I am currently an engineer at Outer Bounds. At Outer Bounds, we are building a large-scale machine learning platform for handling a fully managed platform for handling data science and machine learning workloads. So yeah, welcome everyone. And maybe we can start off just a little bit about like what are your impressions of first impressions of large language models on Kubernetes, especially maybe with respect to training. Where does Kubernetes come in? What does it offer? What is good? What's not so good? What do you think?
Sure, maybe I can kick it off.
Yeah, go for it.
So when Kubernetes was, as you all might already be aware, Kubernetes is basically inspired by an internal Google product called Borg. And it basically tried to achieve the same objective, which is how do you make sure workloads, are scalable, are reliable, you have containers, and how do you have an orchestrator so that you don't have to manage that infrastructure. And that's what Kubernetes was promising to do. You probably noticed in that last sentence, I never mentioned anything related to machine learning. So just a historical perspective here. Kubernetes did grow up without keeping core ML in mind, and it was more about general workloads, that traditional workloads that you might be running, your APIs, your microservices, etc. So it was very microservice heavy, and focusing on that architecture. But for sure, there are lots of, in the past couple of years, this is even before LLMs became super popular. In the last couple of years, we've been seeing a lot of these, products, libraries, everything come up that help you basically run your machine learning workloads on top of Kubernetes, because the principles remain the same. What are the principles? The principles are Kubernetes gives you an abstraction layer, an orchestration layer on top of your containers that abstract away hardware, right? So effectively giving you more reliability, scalability, and efficiency out of the box. Yeah.
Sounds great.
Yeah.
What about you? I think Rahul, you had something to say.
Yeah, and maybe I'll take a different perspective on this one. So a few, like maybe a month ago, we were talking in this community called Tribe AI that I'm part of, super intelligent people. And one of the recurring topics that came up was enterprises are looking to deploy and train the models in-house because they really don't want data to leave their VPC, right? And I think that is a business problem for which Kubernetes provides a good solution. Obviously, you have vendors, the cloud service providers, or even startups who have Kubernetes native solutions for you to deploy and train your machine learning models. But this is what, hopefully what Kubernetes allows you to do is have a cloud agnostic platform for you to train and deploy your machine learning or large language models.
Interesting. One of the questions, and maybe Patrick, I would love to hear your thoughts on this. Like one of the perspectives that gets talked about specifically with Kubernetes is that yes, it has options to run a lot of workloads in the machine learning domain land up being batch workloads. And there is, yes, Kubernetes offers support for running batch workloads, but oftentimes it seems like it's a little bit of an overlooked area, or at least something that hasn't yet gotten the attention. It was always about microservices and orchestration of services that are long running services, running servers, whether it is web servers, database servers, whatnot. But if you are talking about running batch jobs, yes, there is a Kubernetes job, go do something about it. The community has come up with other things like Argo, that have actually enabled some of this, but still not kind of sort of being the first class citizens for batch workloads. What's your take on kind of like, given that a lot of machine learning workloads are batch and Kubernetes offers some support, but not a lot, is there an impedance mismatch there somewhere? Is there something better that can happen?
I mean, I'd say a lot of machine learning 1.0 workloads were batch, and I would say more the 2.0, like generative AI, most of that's actually streaming. So I see there still is some batch use cases, but I think we're moving away from DAGs primarily into kind of like chains and whatnot. I think that's changed significantly. I would say, what Kubernetes is built for, which is microservices, you can almost think of LLMs, as they grow as microservices, where you have, these different parts of the models, these partitions that need to talk to each other. So you need to schedule containers and network them together, right? So it's really the same principles. It's just kind of being thought of a different way. So I think Kubernetes actually fits that use case really well.
Interesting. That's a good use case. That's a good point. What about things like, as we go deeper into kind of LLMs and, one of the backbones almost, so to speak, of LLMs has been use of GPUs. Pretty much every LLM that, at least from things that have, generally been talked about, always talk about how they've been trained on on GPUs, and then all these other conversations about GPU shortages and whatnot. Do you think Kubernetes helps there? Are there things that are better because of Kubernetes for using GPUs and being able to kind of train models there? Or are there are lots of other companies nowadays which don't run on Kubernetes but still provide you with GPU access? What does that happen? What do you guys think?
I can
go ahead. Yeah, go ahead.
Yeah, I mean, I think the biggest thing is cost, right? So I've worked a lot with startups, who are trying to build generative AI applications, and some of them don't want to use OpenAI for the privacy reasons or whatnot. And yeah, the cost of GPUs is horrible, right? I mean, to run these models, it's super expensive to keep these things running. The startup time's super long, right? So it's like you shut it off, you could have several minutes to try and boot a node back up and load the model weights into the GPU. Like that could all take a significant amount of time. So Kubernetes helps with this, where obviously we can scale nodes up and down, try to make that startup time as fast as possible. But I think there's a lot more work that can be done here. Right now, I'm kind of looking at can we like hot swap LoRa's or QLoRa's into models, right? So could we, instead of like having to wait to pull up a whole node, could we just run these base models and then hot swap LoRa's into them for special like fine tuning capabilities? So it's kind of where I'm heading with it right now.
Yeah.
Yeah. Go
Go
ahead,
ahead,
Manjot.
Yeah, just adding on top of what Patrick said, right? Spot on about cost being one of the bigger constraints and problems that needs to be solved with GPU access, right? So I think in the first sort of wave, in the first set of changes, and these changes are all weeks apart, but still, just support for GPUs was added, so that you can enable GPU node pools instead of your CPU node pools, which enables at least some GPUs to be used, but obviously that's not enough. Then you have these newer things like spot instances being available in the various clouds that can really help with making your infrastructure run cheaper. But even that's not enough, because just like with everything in infrastructure, the devil is in the details. So if you look at components of Kubernetes, and this is where, going back to what I said previously, right, it was designed for traditional workloads, not necessarily machine learning workloads. So going back to details of how Kubernetes works, something like scheduler, which I think Patrick briefly touched upon, how Kubernetes actually decides to schedule and provision nodes, pods, and everything else there can be a lot of optimization over there, because obviously there's cost, and there's also things like networking, how much data is being transferred between different nodes and different pods, and where they are actually located. So secondly, I mean, if you look at autoscaler, again, in fact, even funnily enough, with traditional workloads as well, we used to say autoscaler is the easiest way where you can shoot yourself in the foot. I think it's even harder to make autoscalers work with machine learning and LLM workloads. So I think there's a lot of work where templates can be provided, defaults can be configured well, and the right sort of parameters can be optimized when autoscaling an LLM-based workload.
Yeah, just carrying that thread of autoscaling. A couple of weeks ago, we participated in a hackathon where we trained or fine-tuned a large language model on top of Kubernetes with RLHF using the DeepSpeed library, right? And originally, our aim was like, hey, we're going to do this autoscaling thing and enable, make sure that works. The real challenge right now is GPUs are super rare to get hands on. So even if you want to autoscale, you're not going to get it. So a smart way to think about this is negotiate with your cloud provider to get to reserve those nodes that you need in advance, so that your workloads at least are deploying. And then on the basically that's the point with the autoscaling, right? I think the other side where the costing issue that Patrick mentioned and we talked about, I think, and this is speculative on my part, so we'll know in a couple of months whether this is true or not. So as you know, that H100s are going to be released and generally available or starting to get adopted, and we're going to see the horde of people start migrating to that. And guess what that means? A100s are going to be more available, cheaper, and so on, right? And so maybe the market will self-correct with availability, but remains to be seen. I think for now, either you can wait and watch for 2 months, or plan out a strategy where you reserve your instances, and instead of thinking about like over optimizing on autoscaling, try to get a repeatable platform in place on which you can rapidly deploy and iterate on. I think the iteration part of your model is where you should be focused, and not on the iterative, like the how correct or how awesome your Kubernetes platform looks like.
Interesting. So thinking about large language models, so Rahul brought up this point a little earlier, that if you think about large language models, kind of sort of there are 2 or 3 kind of big domains of work. One is companies or teams starting to train or training a large language model completely from the ground up, like literally everything from the data to training the whole thing. It can sometimes take months. OpenAI, for example, has documented how it took, I think, 3.5 months or something for them to get it completely right. Then there is fine tuning of the models, and then there is also prompt engineering. So 2 or 3 different domains of work. So Rahul, how does Kubernetes play a role in this? Does it make it better? Is any one type of work better suited for Kubernetes versus the other? Does that make a difference? And maybe even with GPUs?
And I think as architects and people who are designing these platform level solutions, there's no one right answer. There's always trade-offs. So the trade-off here is, Kubernetes is a great platform for you to be vendor agnostic, move fast, and be able to automate a lot of your workloads. But it's not. It comes with its own kind of challenges, right? Number one being, if you're a foundational model company, your data is in the petabytes. If you're trying to fine tune your models, obviously you can use PFT and LoRa to kind of fine tune only a small part, but then you still have to have the whole model in memory. Guess what? These models are really large. The containers that these would run on go in the tens of gigabytes. And so, big data, bigger models, and everything on Kubernetes just becomes a heavy lifting kind of effort. And so it comes with its own problems. Just yesterday, I had to SSH into the node to look at the journal CUDL to see what's going on. Like, hey, why is this pod not pulling fast enough? Because some nodes it is 15 seconds. Some nodes it's taking a minute and a half. And so, these kind of, especially when you're talking about 15 GB container sizes, things start getting really, really hard.
And kind of sort of everything then, follows that. Larger containers can mean bigger startup times. They also mean that it is potentially possible that, pods may not come up because that much disk space is not available. And then, many, many things that the cost can go up because you're pulling down, especially if every pod that starts is pulling down 15 GB of data for every time, you crash it back off. You're just adding on to cost, complexity, and everything. Can you maybe quickly talk a little bit about what do you think is a good data scientist experience if they have to use Kubernetes? What would be a good? I'm guessing data scientists are probably not very, very enthusiastic about wanting to deal with deployments and daemon sets and DNS resolution and core DNS and whatnot.
I think I can maybe answer it in one sentence. On the best experience for data scientists to deal with Kubernetes is not dealing with Kubernetes. So, which is where I think, and even organizationally, right? If you look at this, and Rahul and Patrick, feel free to chime in here. I think organizationally, what I've seen typically is there's a different deployment team versus a data science team that actually deploys these models and deals with all these complexities. In fact, funny enough, some organizations were telling me that in the past, at least with traditional machine learning workloads, they would write their models in Python. There would be a team converting that into runnable C code and then finally deploy. This just sounds, 100 steps for me that are not optimized. Curious to hear your thoughts.
Yeah, I think obviously traditionally it was use Python, right, from Jupyter and try to make that work as good as possible. I think what's interesting with generative AI is we're seeing it really stretch. We don't really need data scientists as much anymore, right? It's these models are so smart that now just regular old engineers can pick them up and start building AI apps, right? So I think there's this shift to where, I think Python's still ideal, but I think a lot of times it's going to be more actually taking those models and meeting engineers wherever they are.
And one good point I think about all of this is that, this is almost kind of the other side of it, which is on the one side there is complexity, but the other side of that Kubernetes gives you is composability. There are so many different tools and services that we talked about literally in these 8 minutes that we've had this conversation about different libraries, different tools, and the amount of innovation happening there. DeepSpeed, LoRa, PEFT, so many of them coming up. It's easier to get these up and running. It's easier to containerize this and kind of sort of deal with them within containers because with the isolation boundaries. compared to, let's say, saying that here is one GPU instance, 4 of you go and SSH to that box and run whatever you want. I'm sure everyone will step on each other's toes saying, I want Python 3.9, someone else wants DeepSeed version 4.7, and then it's just like, it'll be a chaos. So there are benefits of Kubernetes. There is also the complexity of it, but the composability and the extensibility that you get with it, to some extent, maybe even isolation, that's very appealing, but it probably comes a little later. Do you think we are there yet? Do you think there are teams who actually can benefit from all this, large scale platforms that can be built on Kubernetes?
Yeah,
AI platforms.
Yeah. So one quick point there. I think it's obviously SSHing into nodes kind of makes sense in ways, but if you look at the non-foundational model, and we've talked about most of these foundational models and fine-tuning kind of approaches here so far. The others, which I think Patrick was alluding to, was like, let's say you wanted to spin up a Q&A bot that you've created with some vector DB and some store data going in there, answers, maybe uses Azure's OpenAI bot or Anthropic's new SOC 2 compliant bot. Like, creating these services that can help support these kind of applications can also work with Kubernetes, right? I think that's like the flexibility. At the end of the day, Kubernetes is not the silver bullet. Like we everybody here agrees it's not. But there are these challenges that if you were doing this challenge on a regular node that you have set up, the community support is just not there. You try to Google search, you try to ask ChatGPT to help you out, it's not there. I think Kubernetes is just way more adoption and support that can allow you to debug. And I think that is part of the developer experience as well, and not just having a dev box and SSHing, but also if you get stuck, how do you unblock yourself?
Yeah, I think
that's a good point.
Sorry.
Yeah, go ahead.
I think it's still best in the business of having multiple services. And like Raul just said, you might be running a vector database, you might have a web app, and then you might have your LLM, and you need those all to coordinate to build your application. So there's still nothing as good as Kubernetes to like run those all in one place, orchestrate them together, and have like one coherent API into that.
Yeah.
So this are.
Go ahead.
Go ahead. Sorry, Manjot. No, go ahead.
I was just adding. I think you mentioned these 3-4 areas as well, right? In the previous question on prompt engineering versus fine tuning versus training, and then these service-oriented architectures. I think the last bucket I'll add there is inferencing, right? Out of all these sort of workloads, for sure, Kubernetes right now is far more, scaled, battle tested, I would say, for the training and the fine tuning parts versus the inferencing part. But coming down to the inferencing part as well, when you have, and I think at least the applications I've seen are still sort of figuring out exactly what that architecture would look like on having an external vector DB, not just for training, but also for actual inferencing. That sort of also fits into the service-oriented architecture for which Kubernetes was basically developed.
Interesting. So having said all of this, I think I'm sure there are lots of people who are maybe just starting out or who've always kind of sort of felt like, yes, we've been able to train models either locally or using some service, but we want to kind of standardize on something, and Kubernetes seems like an industry standard almost. What's a good place to start? Like, what would be your recommendation for where to begin, and how would they kind of, how would they go about doing this?
I'm almost hesitant to say this, but a lot of companies have come up with simpler, one-line kind of commands that data scientists can run to get started if they don't have a team that can help you set up the platform, right? So you just write your Python code, PyTorch code, or whatever you want for your training the large language model, and then just have a one-line command. They will take care of containerizing that code and deploying it on their Kubernetes thing, right? And so they are kind of taking care of the orchestration for you. I think that's a good place to start if you really want to get started and you don't have a team supporting you. But I would almost be hesitant to say that that's the best way in which you'd do a repeatable kind of
Yeah.
interaction. So once you deploy, like Manjot's good point about inferences, right? Once that large language model is an inference, then you have this human feedback loop that you need to think about, right? So people are upvoting or downvoting the replies that the agent is giving. Okay, what do we need to iteratively improve on? And now suddenly your data is again leaving your VPC to go into some other cloud. How do you connect all of that? Eventually, you're going to have a robust platform on top of Kubernetes to support all of that. And maybe it's not a bad idea to just have some help from somebody who's helping deploy this on top of your Kubernetes platform, or learn it yourself. I think there's enough resources available and upcoming that would be super helpful.
So
Sri,
fair point. I think what you're saying is there is a layer that can be built on top that to some extent hides some of these complexities that people are talking about, and it can provide that experience that people directly, you write your code and like whatever, run it with some special command or decorators or whatnot, and it eventually goes to the backend and runs it on Kubernetes. As time goes by, you might want to be interested in what is actually happening behind the scenes, and that'll be a good introduction to kind of start with something basic and then do this. Given that Dimitrios is going to tell us that in a few minutes, I also want to touch up a little bit on of these non-technical aspects, especially Manjot, like your experience. I'm sure there are people who have been thinking about, building companies and products that kind of sort of aid and assist data science and ML applications. Like, what do you see on the non-technical side? Like Kubernetes for LLMs, does that seem like things that have, that where products can be built that can, be good, viable businesses going forward?
Yeah, so actually, this is a great question and a great segue from the previous one as well, where there was utter silence when you asked us best practices. I think the main reason for that utter silence immediately was, Sri, there's no real answer right now. I think this space is moving so fast and everything is so recent that people are still figuring out, okay, what are the best tech stacks for hosting an LLM application in production? What is the best way to use Kubernetes or not? Like, what are the alternatives, right? So every day you see like new things coming up. Like there's CoVeev, the hosted model. There's Replicate, which is like completely like you don't have to care about anything, which Rahul touched upon, right? There's so much happening. And to answer your question on are there businesses possible? I think for sure there is. If there were ever a white space to create like a cloud offering from scratch, this is a very interesting white space. There's such a dearth of GPUs right now. There is also lack of knowledge on what is the best way to host, manage, and serve your applications, right? So there is a real white space right now in terms of being the thought leader that, hey, you know what, like you care about what are the big problems like in serving an LLM application, like broad, right? Forget Kubernetes, forget everything. Broad problems are hallucinations, right? That's one of the biggest core challenges for enterprises. Second big problem is cost, which Patrick also mentioned. And last can be just reliability and latency. So when someone thinks about creating the next, infrastructure platform to serve LLM applications, these are the broad 3-4 problems that they have to tackle. And there is a good chance that the answer under the hood will be Kubernetes. But I think the idea is to abstract these things away versus display all the moving parts.
Interesting.
Well,
what do you think about the case?
Sorry.
Go ahead, Patrick. Go ahead.
I was gonna say LLMs will probably be the abstraction on top, right? Which we're already kind of starting to see. We're probably gonna see that. I'd also say it really depends on the size of the organization, right? Startups are gonna really wrestle with the cost of Kubernetes, and the cost of LLMs is already really high. And if you add Kubernetes on top of that, it gets even higher. So, if you compare that to running something like a Cloudflare worker using OpenAI API, that gets a lot cheaper, right? So I think you have to kind of weigh like the size of the organization and the capital they have available. So.
Interesting. I'll take one question from the audience here. There is a question about, can you describe the pros and cons of Kubernetes for LLM training versus the pros and cons for using Kubernetes for LLM inferencing? So Kubernetes for training versus Kubernetes for LLM inferencing. What are the trade-offs? I think Rahul, you've done both of these to some extent.
Yeah, and this is a long question, but a long answer, which I'll try to keep short. I think when I'm advising my clients, I'm telling them about like I'm optimizing for velocity, and having a platform that is easily that's helping you deploy models faster. And I think that is one thing that I think Kubernetes is great on for training. For the inference side, I'd defer to Manjot. She had raised that point.
Yeah, no, I think the inference side, right? We've already discussed some of the challenges present in managing a model, as well as challenges in Kubernetes specific components on how they are designed today versus how they're supposed to work. I think one more challenge I'll mention is a lot of these, a lot of the LLM workloads might be using these, specific libraries and drivers that work with accelerator, some specific hardware component, right? And the whole point of Kubernetes and containers is to abstract all of that away. So I think the world is still sort of also struggling right now, finding that sweet spot of, okay, I need to abstract away hardware, but like this world does not quite abstract it away 100%. So inferencing, I think there's a lot of work to be done. If someone were to start building an application today, you are better off picking up some of these open source solutions present that at least abstract some of that complexity away. But I think we'll still see a lot of development, potentially new products and services being built here.
Got it. And there is also a little bit of this inferencing at times can be, real-time online inferences versus training being kind of bad jobs. So it goes back to one of the earlier questions we talked about, that Kubernetes for bad jobs it's of course it's there, it's useful, versus Kubernetes for inferencing can be like, server-based processes and whatnot. So there'll be some of that comes about. You mentioned about the abstractions. Like one of the abstractions that's available today is multiple open source projects out there. One of them that at least I'm involved in is called Metaflow, so that you can check that out. In case people are interested in kind of learning about abstractions that can deal with Kubernetes or hide the complexity of Kubernetes. But yeah, I think this was great, and we right on cue we have a person with a red hat here.
Pirate. We have a pirate. It's Demetrius. Not at all, man.
I've raided the ship and I have come to steal the show back. That was absolutely incredible. Thank you all, and I will remind everyone. Well, Raul, I may need to make new shirts now. Like Kubernetes is a gateway drug, or I guess Kubernetes is the way to stay high. That is, you can't really see it because of the lighting there. Maybe you might be able to see it. I'll throw up.
I wanted to make a joke about kind of sort of wearing your heart on your sleeve, but Kubernetes is a gateway drug trumps me there.
Yeah, it's hard to follow that one, man. That is so true.
I know.
But I did a little bit of a wardrobe change, and I busted out the "I hallucinate more than ChatGPT" shirt that you can get here. In case anyone wants to grab a copy of that, we've got it here. Folks on the panel, I must say, awesome. And Raul, I'm going to give you a shout out right now because you are running the after party in San Francisco. You got like a bus, or what do you got?
That's right. So if you're in San Francisco, you'd probably know Mission Bay has this awesome outdoor space called Spark Social. There's sun outside. It's a nice day for us to mingle. We have a bus, a double-decker bus that we'll be meeting up at. There's 120 people already signed up. So I think we can get a couple of dozen more. So just join us. Spark Social is a big place. This has been an awesome panel. Thank you, everybody, for your valuable thoughts.
Yes.
Thank you so much, everyone. This was a lot of fun and a lot of interesting conversations. Over to you, Demetrius.
Yep. And any more questions for these Kubernetes experts, the Kates, as they like to call it? I think that's what the cool kids call it. So I'm going to pick that up. Go ahead and throw it in the chat, throw it into Slack, wherever it may be. I'll see you all later. And hopefully,
thank you.
See you in a few weeks, because most of you, except for Manoj, were in San Francisco. I guess Patrick, not really. But anyway, thank you all for that excellent discussion. I am going to keep us moving because we are very much behind, and we are a good 20 minutes behind. But luckily, I'm the boss here, so we can do that. That helps a lot. Now I've got Anton to bring on the stage. And Anton, I made this little wardrobe change just for you because I felt like you would vibe with the hat and the pullover. and the I hallucinate more than ChatGPT.
That's a really cool shirt. I think I might have to get a version of that myself. Maybe you guys can send me some swag. That'd be sick.
There we go. We'll do a swag exchange. Speaking of swag, oh my God, I get to give out swag. I see some incredible questions coming through in this chat. Sergio Rio, reach out to me, man. I need to give you some swag. And for the other one, what do we got here? Nilanch. Yes, you mentioned that YouTube stopped, and it did because we are keeping it all on the platform. Reach out to me on the platform. I'll get you some swag. There we go. So, Anton, I think you got swag that you're going to be contributing to the stockpile, which is awesome. Chroma has been absolutely on a tear lately, and you are going to show us all about some of the embeddings and retrievals for LLMs. I am going to just let you take over,
Sounds
man.
great.
I'll get this this commercial off of the screen right now and let you share your screen if you want. I think, yeah, we got to make sure that works before I jump off.
Sure.
So feel free to share it. And then we are going to hop in to the next talk.
Great.
And
one quick question, Demetrius. Should I be able to see the chat from the audience?
No, so you got to go to the. I'll drop the link in.
Okay, so I actually do have to
recap.
go to a separate link. That's weird, but I'll take it. I'll take it.
Yeah. I mean, it's 2023. You think this stuff
Look,
would be solved?
video calling
after 3
technology,
years?
one of the hardest problems in computer science.
It's so hard, man. And
All right, drop me
anyway.
the link. I'll make sure that I have that open as well, so that we
There
can
we
do the
go.
QA towards the end. Yeah, I'm gonna stick to time. I'm gonna try to get this thing back on track. All right, let me just click this open, and then I'm just gonna make sure that I've got everything that I need.
Yep.
Later, and then I believe I have the chat going here. Yes, maybe, perhaps messaging disabled. I don't know.
We're looking all right. I mean, if you want to, I can also jump in when there's questions that come through.
That would be
and I'll
helpful.
relay them
Yeah, if
by
in
the
case
chat.
everything is broken, I would love to have a moderator who can see it.
That's my job, man. You are in luck.
All right.
That is me today.
All right, man. Definitely vibing with the outfit here. I'm gonna kick it off. Thanks very much for hanging around. All
Yep.
right,
See you later.
here we go.
ahead. You gotta share your screen still,
Yep.
though. I still don't.
How's
see it.
that?
Ah, there we go. Game on.
Game on. All right, excellent. All right. Hi, folks. Thanks for joining my talk today as part of this conference. The LLMs and Prod folks have been really putting on great events, and I'm glad to be part of part 2, despite missing out on part 1, having gone down with a pretty severe non-COVID respiratory virus for some reason. So today we're going to talk about using embeddings and retrieval for LLMs, and specifically I'm going to go into some of the techniques and challenges that you might face if you're deploying this kind of idea in your application. So let's get started, the basics. So what's the basic idea of using retrieval in an LLM context? The basic idea is rather than just relying on the model's trained knowledge, in other words, the data it was trained on, we can actually add additional context to the model's input by making sure that by pulling in relevant information relevant to our query to the model using a programmable memory module, which in our case is an embedding store. So what is an embedding? Again, for most of you, this is just a recap. But an embedding model is something that takes data of any kind of modality, could be text, images, or video, and returns a set of numbers. It's a dense vector. In other words, every entry in this vector is populated, and it's called an embedding. So when an embedding model processes a piece of data and creates this vector, that's called an embedding. And you can think of each embedding like a point on a map, and it's a map of meaning. That's the beauty of embedding models. Embedding models encode semantic, that is meaningful information. And they're trained in such a way that when they embed data, similar things are embedded close together on this map. Now, embedding models are usually working in very high dimensions, so 500 to say 1546 for OpenAI's Ada 2 model. So we can't really visualize their full dimensionality, but this is what one embedding model might look like when projected down to 2D space where we can see it. And we see things that, things to do with cities are close together, body parts, food, etc. in this map of meaning tend to lie close to one another. And we can exploit that fact. So this is how, you typically build a retrieval augmented generated system using an embedding store like Chroma. And we exploit the fact that things that are close together in meaning tend to be close together in embedding space by basically taking our query. So first we embed our data set. We then take a query from our application using an LLM, embed that query and get the embedding for it, then find the nearest neighbors in embedding space to that query, get the associated documents with them, and then use those as additional context to the LLM to generate our final answer. So in practice, what this means we're doing is rather than treating the large language model as a general purpose, general knowledge machine, we're actually relying mostly on its reasoning capability. So its ability to actually draw conclusions from and transform text into one form or another. So again, by providing additional context, we're essentially giving this model programmable memory. Now, we've made this very easy to try with Chroma. You can, go ahead and try it here. It's as simple as pip install ChromaDB, and these are all the commands you need to get going. We've built this deliberately to be as simple as possible, and it's very powerful. A lot of people are using Chroma for all kinds of applications, including document-based question answering, where you can basically interact with a large corpus of text using natural language in a nonlinear way, and that's very powerful in all kinds of domains like legal and medical and research, and even customer support or really sales automation, any sort of domain like that. It's a very powerful general technology. Another emergent place where we've seen this sort of retrieval augmented generation working, and this is a much more emergent category, but I think will be very powerful in the future, is in the category of agents. And agents are basically AI-powered automatons, for want of a better word, that use embedding-based retrieval as a store for the interactions that they've learned, the skills that they've learned, and as a memory for their environment and interactions, and that makes them very powerful. Very recently, a research paper came out called Voyager, which created a Minecraft agent and uses Chroma as the memory layer, which quickly achieves state-of-the-art performance. These agents are, fairly toy-like today, but I think in the near future, they'll actually be very powerful. So all of this sounds wonderful, right? It sounds like we have this great general purpose technology and we can go ahead and deploy it right away. And, the previous panel spoke about some of the infrastructure considerations and the requirements for building things like this. And those are understandable, but what I'd like to talk about in a little bit more depth today are actually the challenges around getting this right from the perspective of the models and the embeddings themselves. And these are some common questions that we receive from developers and teams building with embeddings-based retrieval with Chroma. And top of mind, of course, is which embedding model should I use for my data? There are plenty of text embedding models available, and some of those are specialized to particular domains like code. Some of those are general purpose, and it can be hard to understand which model you should be using for your particular task. Then the next question that we get, and this is again a very frequent question, is how do we chunk up our data? So typically, when you're using an embeddings-based retrieval approach, your data is going to be divided into chunks so that it fits into the target large language model's context window and contains the relevant information. But that can be difficult to do. So this is another challenge. This is a question we get asked very often. And finally, what we get asked quite often is how do we figure out if the retrieved results we get are actually relevant? And relevant actually means two different things. First, relevant might be relevant to the task that the user is asking the model to perform, but relevant might also be specific to the user. For example, one user might care about one attribute of say, they might care about how fast a given vehicle will drive, while the other one, a different user, cares much more about the miles per gallon that it can get. So the things that are relevant to search for differ by user. And that's a very simple example, but you can imagine many other cases like that where you have a retrieval augmented generation system, using embeddings-based retrieval as we've discussed here, and it needs to adapt to each user individually. And actually, that's one of the most powerful things about AI. It's very flexible. It can quickly adapt to all kinds of different use cases and users. So, well, here's the bad news. The bad news is today, nobody really has the answers to these problems. This technology is still very early, and obviously it's getting very rapid adoption today. It's an era of very broad experimentation. A lot of the best practices and tooling is being worked out right now today. The good news is that these are really important problems. And so there's a lot of investment, both in terms of capital and time and compute power, by a variety of groups around the world dedicating to answering them. And the fact that we have open source tooling, things like Chroma, to support that kind of investigation will accelerate how quickly we actually can answer these questions sufficiently well so that we can build great applications on top of them. So let's go into some of these questions in a bit more depth. So first of all, the first question is, which embedding model should we use? Now, the diagram on the right is actually 4 different embedding models trained in slightly different ways using the same data. And this is the sort of map of meaning that you get out of them. And what you'll notice is actually these maps are more or less very close in terms of layout to one another, up to basically a rotation. And there's some empirical research that's come out not that long ago, which essentially shows that embedding models tend to learn very similar representations as long as they have similar training objectives. So that's one thing to remember, that maybe the real sort of improvement you can get from your application isn't by switching embedding models, but in case you do want to go down this route, there are several existing benchmarks. So, I've got a few listed here, and hopefully the slides are shared later so you can click on these links, but they're called BEER and MTEB and KILT. These are existing benchmarks, and they are for what's called the information retrieval task, which is the backbone of embeddings-based retrieval augmented generation, has retrieval right in the name. And they're data sets, but they're also frameworks for benchmarking retrieval systems. And this will allow you to benchmark your own data with a variety of embedding models. And so how would you go about doing that? Well, first, you need to collect human feedback on the relevance of the returned results. This can be as simple as adding a thumbs up or thumbs down button in your application so that your users are essentially labeling the relevance of your data for you. That allows you to construct your own data set specific to your particular task. And then you can obviously embed that data set with a variety of different models and then run the retrieval system and evaluate the effectiveness of that retrieval system using any of the frameworks developed for these existing benchmarks. They are designed to be fairly straightforward to use, and you shouldn't be scared by the fact that they're developed for machine learning research. They're very relevant to production deployments of this kind of application. So the next question that we get is, of course, how do we chunk our data? There's a few things to consider. One thing that is a pitfall that I've seen a few people fall into is that the embedding model, just like the large language model, has a finite context length. It's a fixed context length. And so what happens typically if you input a document larger than the model's context length is it will get truncated, which means the embedding will only capture the meaning in the first part of the document before truncation. So you have to be careful with that. You have to really pay attention to make sure you're not throwing away parts of your documents. Now, the next thing to consider is, of course, when you're chunking, how do we consider semantic content? And what I mean by that is you don't want to be dividing in the middle of sentences or even in the middle of words, because you're losing meaning. You're losing the semantic content that allows the embeddings to actually function properly. And also, you're going to get garbled retrieval results. There are research results that show basically distracting content or partial content inserted into a language model's context window really degrades their performance fairly significantly. So you have to be careful around these parts of chunking. Now, the other thing to consider is a lot of the types of documents and data that we use as humans and we'd like the model to perform operations on already has a natural structure. Things are typically divided into chapters and sections and pages. And because they're designed to be read by a human, they're also nicely structured to be read by the large language model. And so you might consider using some of that structure in your chunking strategy. There's a few great tools built for natural language processing or for large language models in particular. The Natural Language Toolkit, NLTK, is one such thing, and it provides quite a few pieces of tooling that allow you to break things up by sentences or by sections or by paragraphs in an automatic way. And LangChain provides a few different chunking strategies, which are already pre-programmed. They're just packages you can run and chunk up your data automatically. Now, these are fairly basic ideas, and I think that there are more powerful ideas which are currently very much in an experimental mode, but which which we are experimenting with, and we hope to see more of the community experiment with too. The first of these, which is really exciting for me, is actually using the language model itself to figure out where the semantic boundaries are, where the boundaries of meaning are. And the way to do that is essentially have the model predict the likelihood that the next token is the one in the document. And when that likelihood gets low, in other words, the perplexity of that token, when the perplexity gets high, or when the likelihood of those tokens gets low, this means that, okay, the model is uncertain about what to predict next, which means probably, or perhaps, we haven't evaluated this yet, that's why it's experimental, that perhaps this is a semantic boundary. This is where the meaning, basically where the previous section of meaning has wrapped up and a new one is about to begin. And you might consider using that as a chunking boundary. We can also try using informational hierarchies. So again, oftentimes the sort of data that we use as humans tends to have a natural hierarchy, just like it has a natural structure. So for example, you could first summarize, ask the model, or do it in a human way, summarize each chapter in a book and embed the summary of each chapter. And then when you find that your retrieval step, selects a particular chapter as the nearest neighbor to the query, you can then look at the paragraph embeddings of that entire chapter in a different collection and find the paragraphs inside that chapter which are relevant to the query or the task at hand. And finally, sort of a different approach, which is, again, highly experimental. We've been trying this lately. You can try to use embedding continuity. So what I mean by embedding continuity is that basically, you can look at the distances between generated vectors as you feed chunks into the embedding model. Because again, by definition, the semantic embeddings that we generate, if their meaning is similar, they'll be close together. And you can try to find meaning boundaries by looking at the distances between the previous and next chunks as they're generated. This is very similar to sort of like a time series analysis, but in higher dimensions. So again, some techniques worth trying. And then sort of a very interesting question right now for application developers, and this is one of the things you really need to figure out to make your application robust, is the given retrieval result for a particular query actually relevant? So the traditional approach in information retrieval here is called re-ranking, and there's a great re-ranking model out from Cohere AI, which is worth trying, and there's other re-ranking approaches because, again, information retrieval is a historically relevant task. You can also add human feedback to your re-ranking model to essentially train the re-ranking a little bit more for your particular task and domain. And of course, you can use heuristics to augment your retrieval as well. Things like performing a keyword search alongside the query, and then taking the best results according to the re-ranking model between the keyword search and the semantic search over embeddings. Or you can already scope your search if you know something in the metadata of the query. So if you know that the user is asking about a particular part of your documentation, you can already scope the search to only that part of the documentation so that irrelevant results from other parts don't get shown up. Chroma supports metadata filtering out of the box. So I think the real question here is there some sort of algorithmic approach? And what I mean here by algorithmic is something that we can just run without too much tuning, which actually uses some inherent property of the data. So what the key insights here are is the relevance of a result depends not just on the embedding model used, but also the distribution of the data in that particular data set. And so at Chroma, we're working on an algorithmic approach to this relevancy problem in embeddings-based semantic retrieval. We hope to show you something interesting fairly soon. We'll be open sourcing that and letting people just give it a try. So that's a quick overview. I think now is a good time to open it up to Q&A. So I'm going to stop sharing my screen here, and I'm going to come back to you guys.
Yeah, nice. So I can see chunking being an issue for languages where the action verb tends to come at the end of the sentence. Have you thought about that?
Yeah, look, multilingual embeddings are one of those big open questions right now. I think Google has put in the most effort to make their embeddings really truly multilingual, and that's not surprising given Google's global reach. But things like chunking according to the sentence structure of the language, like for example, you can imagine, non-European languages, and I mean chunking even beyond the placement of actions and verbs, but also even just the meaning of characters, right? If we're talking about some East Asian languages where a character has often much more meaning than an individual English word, then the chunking strategy has to be fundamentally different. This is kind of why I like the model-based approaches more, because good language models should be able to model those semantic boundaries so long as they're trained on text from those languages. That's part of why I'm bullish on the more experimental approaches here.
Makes sense. Okay, so for chunking, I find that NTLK or LangChain quite often cut off a paragraph in the middle. GPT-4 with proper prompting actually does better with chunking. Is there a way to use an LLM model to do chunking and convert to embedding in one shot?
Yeah, so there isn't a model right now that will produce that will basically act as a language model and produce embeddings at the same time. I think there's definitely a future for that. I think that one reason we haven't seen this yet from the API providers is basically if you have access to the embeddings and the output and the input of a model, you can reverse engineer that model with enough API calls. You'll be able to distill it much more effectively because you know the internal state. But that aside, I think, I've presented at least one approach to using both an embeddings-based chunking strategy and a model-based chunking strategy. I think if you have access to a local model where you can also, get the probabilities of the next tokens from it, although I think OpenAI still provides that over the chat interface, it's worth a try with that perplexity-based approach that I mentioned. But I don't think there is a one-shot model-based approach. These are things that you'll have to build for yourselves. If you do build it, please let us know what the results are. We're very interested in this direction.
Nice. There we go. Submit a PR. There we go. PR is welcome.
Look, please, genuinely, the sort of contributions that we're getting from the community right now is one of the reasons it's so gratifying to be in open source. We're developing this technology together as a community where there is nobody better placed in the world today to figure out what to do with these technologies than the people trying to build with them. The era of sort of the machine learning researcher in the ivory tower with sort of $1 billion of compute completely dominating what's possible and dominating research is over. You now have access to these APIs. You are equally at the cutting edge as anyone at OpenAI.
So good. Yes, I love it. All right, so we've got some awesome questions coming through here. I'm going to keep it going for another 5 minutes, and then we will. You were true to your word, man. You are like a clock. TikTok, and I appreciate that because I am not. I have been all over the place on timing today. Now, let's see this. Not to get into a pissing contest, but what are the benefits of Chroma over PG Vector?
Yeah, that's a really great question. And this is something that is really important to how we're building Chroma. So PG Vector is designed primarily for a semantic search use case. It's great, it's great in the case where you have a fixed data set that is updated infrequently and you already have your other data in Postgres. So if all you're doing is, for example, semantic search over a fixed data set, PG Vector is fine. Now, there's two issues with PG Vector. One is the recall performance of larger data sets is not great, and it requires a lot of tuning to get right because it uses basically a clustering and inverted index approach to do approximate nearest neighbor search. What that also means is if you have online changes, online mutations coming into your embedding store because you want to store and understand user interactions. It's kind of the beauty of AI that you get to interact with it. PG Vector's performance will degrade very quickly. But Chroma is built from the ground up, and we use an algorithm called hierarchical navigable small world graphs, which is a mouthful every time I say it, no matter how many times I say it, which is a graph-based data structure. It exploits the structure of embedding space in a graph-based way to provide good computational efficiency, but it allows us to scale and deal with mutations online in a much better way. And so we're more suited for the sort of application-based use case where you have a lot of user interactions and your data is being updated online. Yeah, I would say those are two key differences. The other part, of course, with Chroma is a lot of these problems or sort of challenges that I've identified in my presentation today are things that we intend to build into the product. Our core product hypothesis is essentially you shouldn't need an infrastructure engineer to run this, and you shouldn't need a data scientist to get this capability. All of this should be built into the product that you use, and that should be Chroma.
Yeah, that goes back to that idea of the researcher in the ivory tower. It's like, let's get this into everyone's hands, and let the community run with it. And
Yeah.
we've seen how powerful these communities can be.
Yeah,
So-
strong believer in the open source community's power in AI.
And I will say that is a perfect segue into a big thank you from our side for you guys sponsoring this event. I mean, Chroma has sponsored this and the community, which is huge for us because it helps us create more events like this. And also it allows us to do all kinds of in-person events. So I can't thank you enough. I mean, it's a, what do they call it? The opposite of a vicious circle. It's a virtuous
cycle. Yes.
Cycle. That's it. Cycle. There we go.
Yeah.
The cycle is strong. So
Yeah.
there's a few more questions coming in. And since we do have the time, I'm going to ask them.
Sure.
Any advice on chunking / embedding of code? For
Yes.
example, embedding a whole code base to do some LLM assisted information retrieval.
Great. Yeah. So there's a couple of things that I touched on here. One is which embedding model to use. There are a number of code-focused embedding models available. OpenAI would really love you to use Ada 2 also for code. It is trained for both. It's unclear whose wins currently. Do the benchmarking, report your results. We'd love to know. Now, in terms of chunking the code base, the great thing about code is you automatically have a lot of structure. You can chunk by function, you can chunk by class, you can chunk by file, right? And so you can leverage all of that structure, and it depends on what information you want to feed the language model. I think this is actually a great candidate. And if you're doing software engineering best practices, none of your files are too long, none of your functions are too long, so it's more impetus to do things the right way. And so I would genuinely try chunking across those semantic boundaries, like specifically saying, okay, we're going to chunk by function, we're going to chunk by file, and then maybe connecting all those functions. This function belongs to that file, and then maybe if we call that function, we'll also pull in its documentation. So this is the other piece. If you have documentation for your code base, you can tie that in to the actual definitions of the functions and return both of those to the language model together. That's one of the things that's really powerful about this kind of base retrieval. You can send in one query and get both kinds of results together. So that's basically my advice is try a couple of the code embedding models. And then if they're succeeding for you, if they're returning relevant results, chunk up on the basis of semantic information. Code is highly, highly structured, and there's no reason not to leverage that structure.
Yeah, that's such a great point. That is, take advantage of it because language is not quite like that. So you got to love it when you can.
Yeah.
Michael was asking, same question as I had for Sam at Redis, any hints and tips for embedding tables, whether that's encoding them or otherwise?
Yeah, so this is actually another challenge which I neglected to put in my slides, but it's becoming an increasingly interesting topic. So obviously a lot of the world's data today lives in these structured databases, right? We think of them as algebraic data structures, so your SQL tables, et cetera, JSON blobs. And as far as we've been able to figure out, the embedding models don't deal too well with tabular data directly. So there's a couple of interesting approaches that we're trying here. The first is grab your tabular data and then give it to a language model and have it summarize it in natural language and then embed the natural language description. And then you can add, a pointer to the actual table in the metadata. So you retrieve in natural language and then you're able to query the appropriate table because now you know what you need to query. Now here's the other part. Large language models are great at what you should think of as sequence-to-sequence tasks. And one sequence-to-sequence task is taking a natural language description of information you're looking for and transforming that into a SQL query, given the sort of the description of the columns and the structure of the table, right? And SQL, because there's so much SQL available online, they're pretty good at generating SQL statements. So this kind of two-stage approach might work for you. I think that trying to embed tabular data directly currently doesn't work very well. In the future, I think, so here's what I think is going to happen in the future. I think in the future, all of these sort of hierarchical kind of discrete steps that you have to engineer into your application will be handled by some sort of model whose entire purpose is to figure out what information is relevant to the task and then perform computation over that stuff. But we're not there yet. And the way to get there is to generate as much data around these kinds of tasks as possible, so we can start training those models and start operating with them and understanding what they need. It's a fundamentally different class of model that we need here, but I think it's, and what's more, I mean, for me personally, one of the parts of the definition for AGI is it's a system that understands when it doesn't know something and knows how to seek and then integrate information. Right. And so the kinds of models that can perform information-based retrieval and synthesis, they're also in the path to AGI. So these experiments we're doing today might actually lead us there tomorrow.
So anyone that is playing the drinking game with me, take a shot. He said AGI. There we go. That is what we're doing. But
do note that I don't believe we're there yet.
Yeah, I got that. That's a strong disclaimer, right? But there is a part of me that wonders, like, how much value does that actually bring, or is it just over engineering, like a hammer looking for a nail type thing?
Which part specifically?
The using a vector database, like on the tabular data,
right?
And
yeah, I think actually what you want is not necessarily to think about this as a vector database or about tabular data. The task that you're trying to perform is retrieving the relevant information for the target language model, right? That's what you're doing. So wherever that information lives right now is the right place to keep it, right? You just have to find a representation that allows you to retrieve it. Now you have to preserve the fact that you can really flexibly query these things. So if that means emitting SQL from a natural language query, if it means doing basically keyword search because the language model can figure out which entities are in your query and then search for those entities as keywords in your database, or the semantic-based vector search, these are all valid techniques. I don't think that there's an over-engineering here. I think that this is, because we have these different types of data and they're represented differently, we ultimately have to transform our natural language request, our natural language task, into something that's understandable at the data level. So it's just different ways of doing that.
Yeah, great answer. Last one for you. Cool. And we completely ate the prompt injection game. We're going to do that tomorrow. It's been postponed because this conversation with Anton has been incredible. If you wanted the prompt injection game, that was on stage 2 today. We did a little bit of improvising like a jazz band, but that's what we're good at, running these virtual conferences. This question from Manoj. Manoj, this question's awesome. First of all, hit me up because you deserve some swag. So we're going to get you some Chroma swag. And anyone else's question that I asked Anton, we're going to get you some swag too. So hit me up. There's more questions in the chat, Anton, and I'm going to direct you there once we're done with this. So keep the questions coming.
All right, here we go.
The last question for you. Manoj is asking, is there a limitation on how many different heuristics we could try to co-locate embeddings?
This is a great question. I love this question for a variety of reasons. I founded Chroma, I spent probably the last 7 years of my career in robotics. And the number one thing that you learn about robotics is that all heuristics are brittle. If the heuristics worked, you wouldn't need a model to actually be able to get the results that you want. And I think something very similar is true here, which is why I'm talking about a future where models actually handle a lot of the tasks we want them to perform. Now, there's another implicit part of this. I don't think today there's a limit. I think it's necessary to experiment and find out what works so that later we can generalize these things into actually usable tools. So for now, I think just use as many heuristics as get your application into a usable state, and then see what information you can extract from those heuristics. Now, the broader question here is this question about co-locating embeddings. I'm not sure if this is what's meant, but there's a very interesting result, which has been folklore for a while in sort of the AI community, and there's been recent empirical research about this, where it seems that embedding models tend to learn similar representations, and when they learn different representations, it seems that an affine transform, so in other words, just a matrix multiplication between two vector spaces, is enough to transform one type of embedding from one space into another embedding space. And learning those transforms, because they're just a single matrix multiply rather than a large, deep neural network, is much, much cheaper. And what that means is if you have pairs in two different embedding spaces, it's probably possible to link those together. And that has a lot of implications for multimodality. It's got a lot of implications for per user relevance tuning, things like that. So I hope that addresses the question.
Awesome.
All right.
Very, very cool, man. So I'm gonna direct you to the chat now.
Yep.
Now you gotta go to the
I've
chat
got
and chat with
I still
people
have
that are
messaging
there.
disabled. I don't know what that means.
You may have to fill out your profile
Oh,
and
okay.
then you'll get your messaging.
Okay.
You got to give us your email so we can send you some
You already
swag.
have my email. All right.
We gotta, you know what we're gonna do? We're gonna send you some Chroma SDRs. They're gonna chase you down and see if you want to buy some managed Chroma.
All right, I'll complete my profile. I'll hang out in the chat with the folks for a little while. Thanks, Demetrius. Thanks for helping moderate here.
There we go. I'll be in SF in 2 weeks. Hopefully we can
Oh,
meet
sick.
up.
Yeah.
And
Send me an email. We'll get it
right
done.
on.
All right, man.
All right, man. I'll see you
That was fun.
later. And hopefully everyone knows that I was joking about giving away emails. We're not doing that. We are not sharing your emails with people. That's not happening. Don't expect a bunch of random people to be emailing you after this one, despite a lot of pressure from some marketing teams. Not Anton's and not Travis's. Where are you at, Travis? Hey.
Hey, how's it going, Demetrius? I think we
I
met up
am
last
great,
week.
man. How you doing?
Good.
Dude, so let's talk for a minute before we jump into your talk. We had an awesome panel like a week ago. It was me, you, and a few others at the Snorkel event. That was great. And now that was like the warm up. That was the sound check, or what? Now you're gonna keep it cruising.
Yeah. So I mean, definitely we had some hints in that panel talk at some of the things that we're thinking about at Predibase and some of the things that we're building in the open source with Ludwig. And so yeah, I'm really excited to now get to share some of that with some slides and a little bit of demo at the end as well.
Excellent, dude. So if anyone wants to check out Predibase, you have a whole lot of information on the, where is it? Right here on, if you go to the Solutions tab on the left of your screen where you're watching this, throw that on there, boom, click the Solutions tab and you will see Predibase is on there. You can enter the virtual booth, but if you're just looking to watch this conversation, Travis, I'm gonna hand it over to you. And before I do, I'm gonna mention, so I'll let you share your screen while you're doing that. I'm gonna mention to everyone that we actually had your good old co-founder on the MLOps Community Podcast, probably like a year ago, I think. Time flies when you're having fun. But if anyone wants to check out the MLOps Community Podcast and hear more from Predibase and how Piero and the team, Travis's co-founder and the CEO of Predibase, thinks about machine learning, MLOps, and open source. Also, we got into like the idea of how you want things to be flexible, you want it to run out of the box, and you want it to be simple, but you want people to be able to turn the knobs if they know what they're doing. And that resonated with me. Obviously, 1 year later, I still remember that theory and that idea. And so I love the ethos there. I'll let people scan this QR code if you want to join us in the MLOps Community Podcast. We drop them once a week. But now it is your turn, Travis. I see that you shared your screen. I'm going to get this off of the screen and I am going to leave it all to you, man. I'll be back in about, I think it's, what are we at? 10 minutes? We've got 30. Yep. We've got 30. All right.
All right. Awesome. Thank you, Demetrius. And yeah, thanks everyone for coming out today. So I'm Travis from Predibase. I'm the CTO and co-founder. We're a company that came out of Uber's AI group, working on the machine learning platform known as Michelangelo, and also the applied research teams. We worked on a number of open source projects there, including Horvath, a distributed training project, and Ludwig, which is a declarative low-code framework for building deep learning models, including large language models. And so today I'm going to talk about what we've done in the open source with Ludwig for large language models, as well as what we're doing in Predibase, which is all about building and customizing these LLMs using our declarative interfaces. And so the promise there is that you can get to something that is customized for your particular task with LLMs in less than 10 lines of configuration using a YAML-like language. And so in this, talk, not webinar, in this talk, we're going to be starting with a little bit of framing on MLOps versus LLMOps. You know, like I think of this talk were held, a year ago, we'd be framing it as ML ops in some way, but now everything is very much oriented towards large language models and what these things can do for us. We're also going to talk about what it actually means in practice to build and host a large language model. And then I'll go into different options that you have in terms of choosing the right type of customization for your task, whether that's zero-shot learning, prompting-based strategies, indexing, which was what the previous talk was covering, or even fine-tuning, so actually training models yourself, using a base large language model. And then I'll also give you a live demo, knock on wood that everything works, covering some of the features in Predibase that we talk about in the slides. So first, I want to go back to the origins of this kind of type of problem that we're trying to solve, which is traditionally been based on using machine learning. And so with machine learning, we have this whole now domain of ML ops, which is all about productionizing these systems. So trying to get to production, keep things live and fresh in production, where the artifacts that we're putting in production are these systems that enable us to derive insights from our data for performing useful tasks for a business. So like deriving insights about which customers are likely to churn and being able to then take an action like prevent them from churning in some way, like giving them a promotion or something like that, or recommending products to people to buy when they're browsing our apps, things like that. And so traditionally the MLOps journey kind of looks something like this. You have a user that wants to transform some data from a very large data set into a snapshot. They do some exploratory data analysis on that. They engineer some features from that data. Then they create a model on top of the training data, evaluate it on top of the test data, and iterate on this until they're generally happy with the performance, and they deploy it, and then the model is available for real-time and batch prediction. And so the important thing that I want to call out here is that the value comes at the very end, right? The value is once you have something live in production that you can actually start generating predictions from. And so all of this part, which is typically like days, weeks, months, maybe even years long process, is all just costs that you're sinking into it until you can finally actually use something for solving a problem. And so when I think about what LLMs really do to change the game is that they basically take this entire upfront cost and kind of move it away in some ways. And so, you see this in practice with, systems like ChatGPT that I'm sure everyone here has used, is that, you have a system that performs a lot of these machine learning type tasks that is just out there to use, and you never had to do any work to get it to produce useful output, right? Because companies like OpenAI and other companies that build LLMs like Google and Facebook or Meta, et cetera, have already done all that heavy lifting for you, right? And so when we think about the new LLM lifecycle, it really starts with building these foundational large language models, which has a self-supervised training component over unstructured data like the whole internet, has an instruction fine-tuning step over a labeled data set with like curated examples that you want the model to emulate. And then there's also a reinforcement learning through human feedback step where you try to get the model to refine its output to be tailored towards human preferences. So like not saying things that are offensive or illegal, and making sure that generally the responses match what the company hosting the model wants the outputs to look like. And then once this is done, you have the model living in external registry, like something like the Hugging Face Hub, right? And then you can deploy it as this large language model box here. And then all these sorts of tasks open up for you. You can do prompting on top of that model. You might want to do indexing where you have an embedding model that looks up relevant examples from an index and uses it to enhance the prompt for what we would call like retrieval augmented language modeling or in-context learning. And then you also have a fine-tuning step that you can do where you take your labeled data and you refine it, and then the output becomes another model that now lives in an internal registry that you can similarly host, and then this becomes a flywheel, right, of continuous improvement in theory. And the other nice attribute of this is that you don't have to start anymore with the training. You don't have to start at fine-tuning. Like you can start by prompting, you can do some indexing, and then as you go, you can build up a labeled data set by providing feedback or providing annotations on the results from the model, and slowly work your way up to a data set without having to pay that upfront cost. But one thing that I want to call out that's very important here is that this whole part in the bottom left here is really the kind of general intelligence part. It's like you're building this foundation model that knows how to do all sorts of things, like which might be your task, but might also be things that you don't care about, like generating poetry or whatever. And in most cases, you don't need this general intelligence, even though this is the part that's most expensive. What you really need is this solution-oriented flow here, which is all about getting the model to do something specific for your organization, right? And so when we then think about what the LLM ops lifecycle looks like in practice, it's really something more like this, which is just that previous diagram with all of the pre-training work cut out. And really the journey is all about choosing which of these refinement steps you care about in order to get good results. Now, certainly some people actually are interested in building a large language model from scratch. Today, that typically is a very costly endeavor that can cost tens of thousands, hundreds of thousands, millions of dollars. But the nice thing is that, because these systems are general purpose, most of us don't need to do that. Most of us can take open source models like the Falcon model that came out and fine tune them to our specific tasks without needing to spend all that upfront cost again. But in practice, building and hosting these open source LLMs is still quite a bit of a challenge even after the model's been initially trained. So, on the surface, you think about hosting the LLM for low latency, zero-shot inference. But as you start to go deeper, you can think about building the information retrieval layer for doing few-shot inference and doing chunking of documents and document retrieval. You can think about doing distributed training to do the fine-tuning over larger data sets of labeled data. And then you can go all the way down to building the models from scratch with the pre-training and the RLHF and all that, if your use case really requires it. So there's lots of complexity to this problem that sits beneath the surface. And so what we're trying to do with Ludwig and Predibase by extension is make this whole process a lot easier to work with through declarative interfaces. So declarative is all about, if you think of languages like SQL, it's all about saying what you want, kind of describing your problem, describing your desired state, and then having a compiler system and an execution engine that sits underneath that translates that into some actionable model training process or model inference process to solve the task, right? So for example, in Ludwig today, coming out in our new version 0.8, you can specify a zero-shot configuration using a model like the Llama 7 billion model. You can describe what kinds of inputs you want, what kinds of outputs you want, what your task description is, and you can start getting value without having to do any training. You just basically can throw it at a data set and start getting predictions about like what was the intent from the user based on the inputs, the input text. From there, you can expand to indexing in few-shot with just a few additional lines of configuration. So you can say, I want to do semantic retrieval. I want to take the top 3 most relevant examples and insert them into the prompt. And then you can also transition over to full fine-tuning by just adding an additional training section where you say, I want to do fine-tuning, and all of your normal supervised machine learning parameters then become available, like what optimizer I want to use, what learning rate, etc. And so normally this would require quite a lot of infrastructure to kind of transition between these different points. But with Predibase, we want to make it as simple as just, okay, I'm going to change a little bit of my configuration, and now I have a very different type of task configuration and model configuration. And so this is all Ludwig, but which provides this low-code interface, no reinventing the wheel, while also providing quite a lot of depth to what you can do. And then what Predibase layers on top is an enterprise platform that manages infrastructure, data, deployment, things like that. And so we have data connectors that can connect to Snowflake, Databricks, S3, all sorts of different data lakes and data warehouses. We have a model repository that tracks all of your experiments and all the trained weights from fine-tuning and other processes. And then we also have an interface for querying these models that allows you to run interactive analyses, like do a zero-shot prompt or a batch prompt over a subset of your data, or do index-based querying in a UI. And then we also have the whole managed infrastructure layer that sits on top of all this that provides the serverless training and prediction capabilities of the platform. And so what this looks like in practice, we have multiple different entry points. There's a UI, there's a Python SDK, there's also a command line tool. And so from the command line tool, if you want to deploy a model, like let's say Falcon 40 billion, it's very simple. You just say pbase deploy that model, and then you can start prompting, what are some popular machine learning frameworks. From there, batch prediction is similarly as simple as being able to take your prompts and then now apply them over a data set. So for example, given this input, provide a rating, and then you have a bunch of unscored examples, which lives as a data set like a CSV file or something like that, and you want to do batch prediction over them. That's as simple as running a query over a data set. And then if you want to enhance those prompts with an index of some sort, that's also similarly as simple as just providing an index that exists in Predibase to your command, so that instead of just using only the context of the input and the prompt, you also now have the ability to augment that prompt with other relevant examples to help it improve its responses. And just to kind of make this a little bit more concrete, for example, you might have a sample input that's like, let's say we're trying to predict hotel reviews, something like that. The hotel was nice and quiet. That could blah, 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 like that could be the input. The task is, given the sample input, provide a rating. And then what Predibase is going to do under the hood here is we're going to go to our index and fetch the most relevant examples to help you complete the task. And then from there, we'll feed that to an LM and make the prediction. And so if you saw the last talk, I'm sure you're very familiar by now with this kind of retrieval-based approach. But one thing that I think is very interesting about what we're doing at Predibase is that we're applying this specifically to doing task-based workflows like supervised ML or classification or predictive tasks, and providing an interface that's very similar to what you would do if you want to do just traditional supervised machine learning as well. And so being able to swap between those different strategies to trade off between cost and time and compute resources and performance. And so when you're ready to formalize this, we represent these sorts of configurations as models in Predibase. So you can create a zero-shot model definition from your configuration. And then similarly, you can create a few-shot model definition as well with just a very simple command line interface. From there, we also support fine-tuning in the platform natively. And so for folks, very quick primer, if you haven't done fine-tuning before, is essentially taking a pre-trained model, providing some examples of inputs and outputs that you want. And then from there, the model weights will be adjusted to be better at outputting the type of thing that you're interested in. And translating this into a configuration in Ludwig and Predibase is just as simple as giving a specific trainer type, and then specifying some hyperparameters, optional hyperparameters like how many epochs you want to use, what your optimizers, et cetera. And so the promise of fine-tuning is really about being able to achieve better performance on your tasks and also lower latency in some cases. Whereas if you got good performance with Falcon 40 billion without fine-tuning, and zero-shot or few-shot prompting, that might be good enough. But ideally, you might want to increase the throughput or decrease the latency by using a smaller model. And oftentimes, fine-tuning a smaller model will give you good, if not better, performance at a much lower latency cost. And there are different ways to fine-tune. I think most people often imagine that when they talk about fine-tuning LM, they're thinking about fine-tuning the full text-to-text model. So you have an encoder that outputs some embeddings, and then you have a language model head decoder that sits on top that generates sequence output. Certainly for some cases, like generative cases, that's very useful, but oftentimes what you're trying to do is something like classification, right? Where you have a fixed number of categories that you want to classify into. And in those cases, you might actually be better off doing something like chopping off the language model head that generates text and instead just taking the hidden state of the model and then attaching a classification head on top, in which case you have a few different options. You might want to fine-tune the whole thing together, or you might want to fine-tune just the classification head and leave the original encoder frozen. And so thinking about like how to do these different things with PyTorch, even like frameworks that make this very easy, that sit on top of PyTorch, can often be a little bit of a problem, right? But the nice thing about, again, with Ludwig is that we make it very easy to transition between these different things, again, through the declarative interface. So if you want to do this sort of full text generation fine-tuning, it's as simple as a config that looks like this. Whereas if you want to train, a model that just uses the large language model's encoder, you just specify that as an encoder in your input feature, and then have an output feature that's specified as category, which attaches the category classification head. And then similarly, if you want to freeze the LLM parameters, which will speed up training, you just have to specify that the weights are trainable equals false, which will freeze the weights and therefore give you better throughput. And one thing I want to call out is that setting trainable equals false, you might think, why would you want to do that? Wouldn't it always be better to adjust the weights? And from a strictly performance-oriented view, like most of the time, training the weights is going to give you better model performance. But I want to point out that it is much, much faster and cheaper to not train the weights of the model if you don't have to. And so I always recommend starting when doing an experiment with not training the weights of the LLM. And so just to give you a comparison point, like here's a training duration for one test. This was on, I think, an IMDb reviews data set. It took about 60 minutes to train with full fine tuning, and then going all the way to some of our optimizations that we provide in Ludwig and Predibase, which is automatic mixed precision plus cached encoder embeddings. We got that down all the way to just an order of less than a minute, actually, to do the fine tuning, which is pretty crazy because at that point you're just doing one forward pass to generate the embeddings, and then you're just fine tuning a bunch of fully connected layers on the bottom. In addition to that, we have other state-of-the-art techniques in Ludwig available with single parameters, like parameter efficient fine tuning methods like LoRa, which is essentially a way to augment the model architecture with certain trainable parameters. But doing this is, there are frameworks that make this easier, but still like a non-trivial thing in most cases. But with Ludwig, again, it's just one parameter. And we also provide distributed training with model parallelism and data parallelism out of the box. So for example, using DeepSpeed, that's as simple as just specifying a backend configuration in Ludwig, or if you're using Predibase, there's no need to specify this at all because we do all the right sizing of compute for you based on the description of the model that you provide. And so we'll do the selection of DeepSpeed and the selection of compute resources for you. And with that, I want to get into a quick demo that shows you how some of these features work in practice. So let me switch over to our Predibase environment for a sec. And so this is where you land in Predibase. You have the LLM query editor. And here I've selected a model of Vicuna 13 billion. Not important which model, you have lots of different ones available. This one's just for demo purposes here. But here you see that I previously queried the model, what is machine learning? And it gave me a response. Now, again, going back to the hotel reviews data set, I might want to ask a question like, what are some popular hotel chains? And then from there, I'll go ahead and query the model. And okay, so generated this response, which was there. Some include Marriott, Hilton, Hyatt, etc. So it looks pretty good. Now, what if I want to ask something a little bit more specific that might be something about a data set in particular? So for example, what are some hotels with poor Wi-Fi? Now, the previous response was something that the model already knew because it had seen it in its training data when it was originally trained, right? But in this case, we're asking about something it doesn't know. And so its response is, as an AI language model, I don't know anything about what hotels have poor Wi-Fi. And then here are some things that might help you with your answer, but sorry, I can't help you. So at this point, you might think, well, now I got to fine tune this model, but actually it's not the best place to start in most cases. Like what you probably want to do is instead just augment your model with some domain specific data without having to do any fine tuning. And so for that, we provide this parameter here called dataset to index. And then once I specify that, I can go ahead and send this query off to the large language model. And then the first thing it's going to do is index the data if it hasn't been indexed before, and then go ahead and do the in-context learning and retrieval process on the fly. And so here now you see that says based on the given context, we see that, the American Inn had poor Wi-Fi, Best Westerns, Carmel Townhouse Lodge, etc. And if you look at the raw prompt that was submitted to the model, this one's a little bit not formatted particularly great, but you can see that in there was all the attribution needed to kind of give you a sense for why the model ultimately came to the conclusion that it did. Now, once I do this, this is, I think, like a very good way to kind of get to know your data and do some qualitative type queries of your data. But oftentimes what you'll want to do is transition to something a little bit more quantitative as well, like prediction. And so what I can do is show you an example of trying to predict specific hotel review scores. So for example, you could say like, given a review, which in this case I know is in my data called reviews full, predict a rating on a scale from 1 to 5, and we'll go ahead and send that query off and see what happens. And just to give you a little bit of a sense for what exactly is what the data looks like under the hood, what we can see is that, I upload this data set here, is that we have a data set of reviews on a scale from 1 to 5, with about half of them being 5, and then a bunch of review text that go along with them, with the median sequence length being, or mean sequence length being about 112, and then all the content of the reviews sitting here of various forms, right? And so if we look at the responses, we see that it predicts like, oh, I think it'd be like a 4 out of 5. I think it might be also a 4 out of 5, 2 out of 5, etc. But you'll notice that the responses are not really in a format that we're particularly happy with, as the model's very verbose. It's adding a lot of filler words that we don't really care about. So one thing you might want to do is iterate on the prompt to try to get to something that more accurately reflects the format that you're interested in. And so here I just have a prompt that I spent a little bit of time iterating on myself that shows, okay, here I've managed to get the model to output something that looks a lot closer to what I would ultimately want. So which is something like, a particular format. And so now instead of the model kind of spewing a bunch of, verbose stuff, it just gets straight to the point. The review is 4, the review is 3, etc. And now at this point, you can see that if you compare it to the ground truth, it's in most cases not too far off from the actual review score. So at this point, what I might want to do is formalize this as a task definition in Predibase. And so that's where you get into the model repos that exist in Predibase. So here we have a model repo for this particular task that shows a 0-shot, a few-shot config with random retrieval, and a few-shot config with semantic retrieval. And in the interest of time, since we're running a little bit low on time, I won't get too much in the weeds here. But you can see how I took my same prompt and then specified it as the prompt for this model, and then told it that I want my output to be a category that has this vocabulary. And additionally, I can provide some validators that kind of validate that the output matches what was in the output of the response in a particular format. And if I want to then go to doing few shot with semantic retrieval with random retrieval, it's as simple as saying I want to do retrieval as random, k equals 3. And if I want to do then semantic retrieval, it's as simple as saying, I want to do semantic retrieval. And the important point here that I want to emphasize is that you can see also the progression in performance as you go from models that are doing just basic 0-shot with 37% accuracy, all the way up to the semantic retrieval, which gets you to 66% accuracy. And then if I want to go further, we can start to look into fine-tuning techniques, where I can say, create a new model from latest. And it drops me into this UI, which is our model builder UI. So I select a large language model as the type of model I want to build. And then from there are all these parameters I can select: the model name, the prompt template that I want to use, retrieval strategies, and then my various adaptation methods like LoRa or AdaLoRa, and then all of the different parameters, which come with reasonable defaults, but that I can configure beneath that. And then all of this is also fully modifiable in YAML through the config editor, which exists here. So so all the options available from 0-shot, few-shot, fine-tuning, all in one platform, and then all the ability to deploy this model back into production, so you can start querying again from the original editor, completes the loop so that you have it all integrated in one place. And I'll go ahead and stop there and open it up to any questions from folks. So thank you.
Right on. Very cool. Thank you for showing us this, and your prayers were answered because the demo gods were very nice to you this time around, huh?
Yep, no crazy errors from what I saw, so it worked out well.
That is awesome. So it takes like 20 seconds for what we're saying right now to be seen by the people in the chat. So I'm gonna go ahead and ask a question that came through, and Michael actually already answered it in the chat, but it might be good to talk a little bit more about like fine-tuning different models, and it doesn't matter if there's different model architecture or size or any of that. Like, what do you need to keep in mind when it comes to the fine-tuning piece?
Yeah, that's a good question. So I'd say that with fine-tuning, the most important part is definitely the data. I would honestly say that most of the parameters, you don't really need to play around with them too much in most cases. Like with fine-tuning, your goal is really to avoid kind of screwing up all the background knowledge that the model already has, so that catastrophic forgetting problem. And so when you use like these parameter efficient techniques like LoRA, because you're only adjusting a minimal set of weights, it really helps with that part of the problem. I would say that the much more important thing is to make sure your data is in the right form. And then after that, I would say it's important to make sure that you use the right type of fine-tuning technique for the problem as well. So again, I think a lot of people often start with like, I have a text classification problem. Let's fine-tune a large language models to output text that looks more like the type of thing I want to predict. In most cases, you'd much rather just get rid of the large language model output and then add that classification head on top, rather than try to stick to a text-to-text model, right? So choosing the right technique for the task is also the most important thing to consider. But then from there, in terms of like specific model architectures and things like that, I would say that the important thing is to try to start with something that's small enough to get the job done, because, you know, in terms of like the iteration velocity, trying to start with like fine-tuning a 175 billion parameter model or something for a classification task, it's going to cost you a lot and probably, you know, won't do any better than a smaller model if the task complexity is you know, bounded enough, right?
Yeah, be pragmatic. That is a great call. And also, you don't really know what it is until it comes out. So it's kind of like a crapshoot. You can, if you do it like what you were talking about with these gigantic models, then it may cost you a ton of money and it might not even be that good.
Yeah,
so
absolutely.
Aware of that.
So I think oftentimes a good strategy is to, you know, a lot of these models come in different sizes, right? So like Falcon 40 billion, Falcon 7 billion. I think a good strategy in a lot of cases is like use Falcon 40 billion for doing prompt engineering, find like a prompt that gives you pretty good results, then try fine-tuning Falcon 7 billion with for your particular task, using that prompt as the input prompt. And you'll find that it's in some ways you're kind of distilling the model at that point into like this smaller model to predict similar to how the original model predicted. But you'll find that actually it probably does quite well at the task at that point compared to the 40 billion one.
Excellent. All right, last one for you before we keep it cruising. Does Predibase work with self-hosted open source LLMs? If the data is sensitive, does the data have to go to the Predibase server?
Great question. Yeah, so we have two different ways of deploying Predibase. We have a SaaS version, which runs in our cloud, so you don't have to manage any infrastructure yourself. But for the particular type of use case that that person asked about, we also have a VPC, so virtual private cloud version, where all of the compute runs in your environment, and so no data ever leaves your environment. So if you have sensitive data in AWS, for example, you can actually run the part of Predibase that processes the model for training in your data plane, in your AWS environment, and none of that data is ever crosses the boundary into our environment.
So good. Yeah. Airtight. Make it that airtight gap, and then get all those SOC 2s and those SOC 3s and all that fun stuff complied with. You're golden. So, dude, Travis, this has been awesome, man. I appreciate you coming on here, and I appreciate the demo. If anyone wants to continue the conversation with Travis, of course, you've got the chat, but you also are in Slack, I believe. So feel free to tag Travis in the community conference channel, and we're going to keep it moving right now. Also, I mentioned it before, but I'll mention it again. hit up the tab on the left called Solutions, and you can find out more about Predibase. And that's all. Thanks, Travis, man. I'll talk to you soon.
Thank you, Demetrius. Bye.
And so with that, we're going to keep it cruising. And I will remind you all that there are in-person events that are happening in correlation. No, that's not the word I'm looking for. It starts with a C, but my brain's starting to not work because I am on one side of the world right now and it's getting a little bit late. And there's other people though that are on the other side of the world and they're just starting their day, which is awesome. So there's the San Francisco crew and there's the West Coast crew. And I believe our next speaker is somewhere around the Bay Area. Did I get that right, Tristan?
That's absolutely right. I'm from Oakland. I'm sitting in Oakland here, so near SF.
There we go. All right, so I gotta tell you a little story about Oakland. Totally not what you think it's gonna be. No, I live in the middle of nowhere, Germany, right? And there's like 100 people that live in my town. And in the next town over where I go running, there's a guy, he's got to be from Oakland. He's just got gigantic Raiders everywhere. Everything is Raiders. And it is, it's so much so that one day I'm going by and he's having a barbecue outside and I'm just like, dude, what's the deal? Huge Raiders fan. He's from the Bay Area also. And I realize now after saying that story, it's not as good as I thought it was going to be.
Well, we definitely have some Oakland pride here.
There we go. Oh man. So Tristan, we're cruising. We're gonna start slicing it up and doing some 10-minute lightning talks. I'm gonna throw 10 minutes on the clock. And of course, if anyone wants to learn more about what you all are doing at Continual, you've got a booth in the Solutions tab. So hit the left hand button. It says Solutions, and you can go through and you can find all the different booths that we've got and all of the cool stuff. There's great different swag that's being handed out, and there's all kinds of insights that you can find. So Tristan, before I take up any more of your time, man, I'm gonna let you cruise through this and I will jump off the stage. I think, yeah, I see your screen being shared and it's actually, I'm seeing myself right now on my screen. So I'll let you go to your slides and I'll share.
Switch over my slides.
There we go. I see your slides.
Go full screen here.
Full screen and
thank you, Demetrius.
Right up. All right, man. I'll talk to you soon.
All right, awesome. Well, will be a quick one, so 10 minutes or less. And today I'm really excited to talk about building production AI copilots. My name is Tristan. I'm the co-founder and CEO of Continual.ai. If you want to see what we do, check us out at Continual.ai. We're building a developer platform for generative AI with a focus on helping people build AI copilots for their SaaS applications. I previously was a CTO for machine learning at Cloudera. Built one of the early MLOps platforms that was called Sense, which Cloudera acquired, which is basically a short introduction in a way of saying that I've suffered for the last 10 years in trying to make AI and ML easy by building sort of standard MLOps tools. And today I want to talk about something different that I'm extremely excited by. It's a basic belief that the software experiences that we all are going to have across both our consumer applications, but more importantly, I think our business-to-business applications are about to fundamentally change. We're entering an era of AI copilots. And what does that exactly mean? And what does it mean for us, both as consumers of these applications in terms of how our experiences will change, but also more importantly, what I want to talk about is how does it change for builders, people that want to put AI into the world, how do we go about doing that? So a few observations first up off the top. I think MLOps, traditional MLOps will mostly be irrelevant. I think AI copilots will not replace existing applications, and I'll talk about that in a little bit. And I think there will not be a single personal AI copilot that rules them all. So it's not that we're going to only talk to ChatGPT, and ChatGPT is going to orchestrate every single application. Instead, I think what we're entering when I say the era of AI copilots is an era where every single application out there within every single vertical domain will be enhanced by its own specialized, customized, tailored AI copilot that has connectivity to the data that's sitting inside of that application
the APIs that application has, and is deeply tailored to the workflows of the end user, whether that's a marketer, a salesperson, a doctor, a teacher, a student, a scientist, all of the mechanical engineer, all of those things will be using their own AI copilots. This is an example of Epic. I mean, this is an example of why I believe that AI copilots are going to be embedded into existing applications rather than replacing the applications or having a single AI copilot for all applications. This is an incredibly complicated domain-specific application with a tremendous amount of data around, in this case, patients. And I don't think there's any way that a single AI system or conversational interface is going to replace this. Instead, what's going to happen is these types of applications are going to be fundamentally transformed. Now, what do we mean by fundamentally transform these applications? What are these AI copilots going to look like if they are embedded into these traditional applications? I think there are three emerging patterns for how AI copilots get embedded into the applications. The first is one that we all know and love, which is, or know and certainly love more and more over the last 9 months since the introduction of ChatGPT, which is the conversational experience into applications. And so we're starting to see this in more and more of applications already today. Copilot Chat, Copilot X Chat, or GitHub's Copilot X is introducing a chat experience beyond sort of the autocomplete experience that they have. And the chat experience, while I do not believe it will replace the entire application, does have incredible use cases around knowledge discovery, ad hoc querying, information retrieval, and it's a very natural user interface that everybody is used to. So I think that what I foresee happening is that every application will add a conversational user experience on top of their existing application, both connected to the underlying data, connected to the APIs, and then specialized to their particular application context. The second dominant pattern I see is not just having an AI chat on the sidebar, but actually trying to put AI into the micro workflows of individual users. And so here's an example from Hex. I think this is one of the best examples of what I would call a Copilot command or a Copilot action. And here they're showing how you can write analytical queries, using sort of, in this case, still natural language to a SQL query. And that can give you relatively complicated SQL queries, or it can do other things, for instance, fixing and suggesting fixes for mistakes or suggesting improvements. And so here you're seeing a Copilot commands in the analytical domain, but you can also think about the similar experiences that you might have seen in, for instance, Notion, around writing content, which has similar sort of type of functionality and user experience. The final one is, I think we're also going to see an increasingly more and more Copilot automations. These are full automations of user workflows. This particular one is, again, from GitHub Copilot X, which is, in this case, doing automations on a pull request. So as soon as you open a pull request, there's an event-driven agent or workflow that gets kicked off that looks for bugs, improves, makes the code review suggestions, summarize what's inside of the code review. And so increasingly, I think we're going to move to a world where copilots not only we can ask copilots for things, but they'll also automate our work. The net user benefits here are help illuminate or enrich the information inside of our applications and provide insights, help us complete tasks and streamline our workflows, and then finally help us fully automate tasks and potentially even work autonomously with limited or no intervention from the end user. So the question then becomes, okay, these are putting production AI systems inside of the applications that many of us are building. How do we think about building these particular experiences? And I want to argue that there's thinking about it holistically as the AI inside your application as a co-pilot system provides a unifying view to thinking about how to embed these different types of user experiences into your applications, still being powered by a core engine that is connected to the data, the context, the APIs of your individual application or of the individual application domain.
So a Copilot, production Copilot system, we've been working on several at Continual, but a production Copilot system really, I think, has 3 layers. So the first is the user experience. We need to think about how are we going to embed the AI experience into the user workflow. And as I just mentioned, I think there are 3 primary user experiences: the conversational experience, which is chat or a chatbot; a command-oriented experience, which is often in line to a particular workflow, or where you're trying to do a sort of a one-turn task, not have an ongoing sort of interactive conversation with the system. And the final one is automations, a way for these systems to have automated processes that are continually reacting to events that are happening inside of your application, and enriching and enhancing and automating the information inside of the application. So the front end is those user experiences, and that's traditional sort of user experience design. They then, I think, will come into a router. So the way we think about it is these different user experiences talk to a common router, which routes it to the internal AI system that is most tailored to the particular domain. So you may have your text to SQL engine that may go to a particular agent behind the scenes that is specialized in doing text to SQL. You may have a conversational support bot that may be a slightly different agent. So from multiple user experiences, you'll go into a router that will then go to multiple potential agents and interaction. By agents, I mean a system that has the capability, an AI system powered by typically a foundation model like the OpenAI ChatGPT models, that has both the capability to respond to natural language to queries, but also the capability to decide on what tools or functions to call. And so the layer below the agent would be your plugin layer. And so this is, I think, what OpenAI is doing here, and the announcements they actually just made earlier this week are the right architecture for building these, or the foundational architecture for building these AI copilots. So OpenAI just announced function calling. That allows the agent to decide and make a decision on what function or plugin to call, and the information to pass into that underlying plugin. Plugins provide a unified interface to all of your external systems, and so that could be your data. So you could use a plugin to connect to a search index or a vector index and look up additional context. You could use that plugin to store information into the data set. You could use it to connect to an external system. So if you were connected, for instance, your sales system and talking to an external service API, you could do that. And it also allows you to talk to more deterministic workflows. So if you have workflows that are very specific, you can build and have those plugins actually connect to those internal workflows. And then finally, you can actually make this whole system recursive. You can have agents that talk to agents. And so if there's a specialized agent that itself potentially has a limited set of plugins, you can actually create a hierarchical system of agents. And as these Copilot systems become more and more sophisticated, I think what you'll see is this sort of general architecture, and then this recursive nature to this architecture, so you can decompose different elements of your stack. So on the final side, we have observability and guardrails. Of course, observability and across this entire process is incredibly important. So what are the top challenges to putting these Copilot systems into production? I think there's really honestly just one, and that's reliability and performance. And so I just want to give a few tips in terms of different ways to kind of that are sort of relatively straightforward in terms of ways to make sure these AI copilots perform well. So the first one's obvious: start simple. Even simple AI copilot features can significantly improve products. I've talked to actually multiple founders who have put AI copilots into their products and have seen like significant uplift from basic plans to premium plans, and ultimately user satisfaction. Observe and watch user behavior like a hawk. So when you're starting out, every single conversation or every single action, you should honestly just look at it and see, is it working? Is it not working? You can honestly, without structured testing, you can fix a lot of problems very quickly by observing the actions of your users. The final thing that I would call level one, which are these easy fixes, is isolate complicated areas of your domain. For instance, if you're doing rich analytical queries, into narrower sub-workflows or agents that can be tested more formally, more easily. And so don't try to make one agent that does everything and decides everything, plans out everything. Instead, decompose it where you have more control over some areas, but maybe more dynamic planning at a higher level. In terms of level 2, as you become more sophisticated in production, what do you need to do? The first is build automated evaluations and integrate them into your CI/CD system. So particularly if you're doing difficult analytical queries or difficult automations, you really need a formalized evaluation system. How then do you get feedback and improve your system? I think one of the most powerful ways is actually to build and maintain build a system to maintain and dynamically inject few-shot examples into your prompts. So this is a great way where you can collect feedback, see problems, propose solutions, and not pollute your prompt as a huge prompt, but instead dynamically inject the kind of closest examples that you have into your prompt. And that can create a data engine for your application without getting into the complexity of fine-tuning your own model. And finally, try to create delightful and magical experience. One way that we've seen this being incredibly powerful is you actually treat your front end like another plugin API that the agent can manipulate. And that actually can change the user experience and make the user experience quite dynamic. So with that, I guess this is just a call to let's build AI copilots into our applications. And if you are interested in doing this for your own application, or just interested or business, and you're interested in copilots in general, or have thoughts on this general topic, please email me, Tristan@continual.ai, or you can sign up for early access to our platform at continual.ai. Thanks a lot.
So I have so many things. First of all, I love this idea. Second of all, it feels like what I've seen being implemented with this idea has not worked as of yet. And there is this huge desire for it, but it is like, yeah, I mean, you mentioned OpenAI has just come out with it, so hopefully that makes things that are built with these plugins and all of this, these functions more stable. But it is something that I really wonder about. I mean, it's no small feat to try and take this on, Tristan. What gives you the confidence, man? I can't believe it.
Well, I think the critical thing is, we believe that basically these AI copilots are going to enhance your existing applications, not replace them. And that's not to say you can choose and pick and choose, hey, what are the workflows or what are the sort of the challenges that a user might have where the AI can enhance it, right? So we're already seeing, for instance, that just to do basic support queries, right, this sort of like chat with your docs use case, it actually makes a ton. That's very simple, right? You can implement that, in LangChain or something, pretty quickly yourself. It's a little bit hard when you get to production to kind of make it a production system, but the basic kind of idea of chatting with your documentation actually is a really, really useful product feature, right? It's a better way than searching your docs in many cases. And then I think with Hex, you can see an example of like a very narrow use case. For instance, fix your bugs. If you have something that executes wrong and you have a type error, and then you can fix that right in line. And often you can't see that you're missing a comma somewhere, but it can immediately do that. I think ultimately these things are going to become incredibly rich, right? These autonomous agents that people are, kind of getting excited about will become actually things that work. Right now, that's not the case. But if you think about the next couple of years, that I think that will be the case. And I think all software will have this idea of, my software AI or my software copilot inside of them as part of a core feature of the product.
Yeah, it's so good. I mean, you hit the nail on the head in the LLMs in production report that we just put out, and I will do a shameless plug right here if anybody wants to download it, free, no email needed or anything. But we just put this survey out, right? And it's the report that I've been grappling with this data for the last 3 months or so, even more probably now. And it's very much that question of what parts of my workflow get fully replaced and what parts of my workflow get augmented, and where and how do I know what each part is? Like, it's not clear at all right now. So I think we're exploring this unknown together, trying to figure out what exactly is it that is going to get replaced, what's going to get augmented, and how can we find that out?
Yeah, no, absolutely. And I think it's going to be both. I mean, I think even, you can say it'll be 99 replaced, but that's still a version of augmentation. So I think a lot of stuff will become more and more automated. Copilots, I do think, will shift more and more towards this fully automated sort of task completion. But, you will still interact with them potentially conversationally for sure. I think everybody will have a conversational interface. And then there'll be all these sort of enhancements as well into the product. But that all can, I think, be powered by the idea of a co-pilot system, you know, where that has that connectivity to the data, the APIs, it's making decisions around what to do. I think there's sort of a unified way to sort of think about how do you build that if you were an application builder. But we're certainly still in the early innings.
100%.
For sure.
So, all right, man, I've gone way over on time because I love this agent idea and I love talking to you. I'm going to kick you off now, though, lovingly, and I will see you when I'm in San Francisco in 2 weeks.
Thank you.
See you. We're just going to keep cruising. Don't forget, in case you thought it was any different, I hallucinate more than ChatGPT. It is out, and I've got Sumit coming onto the stage. There he is. What's up, dude?
Hey, Dimitrios. Love the t-shirt.
Thanks, man. So, you are one of the few people that I hear talking about recommender systems or just recommendation engines with LLMs. And I am so excited by this topic because, again, going back to this LLM in production report, in the use cases section, when we ask people what are they using the LLMs for, recommendations were actually one of the strong use cases. So it is, I would say, in my mind, at least the work that I see you sharing, you are at the forefront of this. And I love that you are here and you're going to school us on a little bit of it. I'm going to put 10 minutes on the clock. I'll be back and I will see you soon, man.
Yep, thank you so much. I hope you can see my screen. Yeah, awesome. So hello, everyone. LLMs have emerged as these powerful tools for a wide range of NLP tasks. And recently, there has been a significant interest in the recommendation systems community on using these LLMs to enhance various aspects of recommendation systems. Today, I'll briefly highlight how large language models are being used in recommendation systems, why should they be used in the first place, and what are some of the associated challenges. So before we begin, a little about myself. My name is Sumit Kumar. I work as a senior research engineer, a senior machine learning engineer now at Meta, and I mainly work with content recommendation platforms. Previously, I worked as a recommendation systems MLE at TikTok, NLP research scientist at Amazon, and a speech recognition engineer for Samsung. So one of the big motivations for using LLMs for recommendations is that LLMs encode a massive amount of external knowledge that can supplement the user behavior data that we commonly use in recommenders. So for example, because of its web scale knowledge, an LLM can recommend a user to buy turkeys when it is Thanksgiving, but a traditional recommender system may not be able to do that if there is no logged click behavior that relates turkeys with Thanksgiving. And LLMs have shown strong zero-shot and few-shot capabilities, which can help a lot in recommender systems where we often deal with challenges like data sparsity and cold starts. And we can also utilize the high-quality textual feature representations from LLMs to more effectively model the text data that we handle in recommendation systems, such as user profiles and item descriptions, and so on. So one way to understand or look at the current state of this line of work is to categorize it into discriminative and generative approaches for recommendation. In the discriminative paradigm, the language models have mainly been used to provide embeddings for the downstream tasks. BERT series of models usually fall in this category, which are rather smaller language models, and they can be further classified into fine-tuning and prompt tuning. In fine-tuning, the pre-trained language model is tuned with data specific to the downstream task. For recommendations, this data usually contains user item interactions, item descriptions, user profiles, and other contextual information. In prompt tuning, the tuning objective of the downstream task is aligned with the pre-training loss. So for this presentation, our focus will be on the generative paradigm, which can be further categorized into non-tuning and tuning methods. Non-tuning work includes prompting methods, where the researchers assume that the LLMs already have the recommendation capabilities, and they try to trigger these capabilities by introducing specific prompts. In context learning, these prompts also include some demonstrative examples. Tuning work includes prompt tuning and instruction tuning, although the delineation between the two is not very clear, but some of the literature calls it prompt tuning when the parameters of the LLMs are being fine-tuned on a specific task, and instruction tuning when they are tuned on multiple tasks with different type of instructions. This is an example prompt from this research paper from Alibaba, where they evaluated the ChatGPT's zero-shot and few-shot recommendation capabilities. In this prompting method, the prompt consists of a task description that describes the recommendation task in natural language, a behavior injection component that injects user item interaction information into the prompt, and an output format indicator. The same paper further added some demonstrative examples into the prompt to get these recommendations from a ChatGPT in few-shot settings. And this study and a few others have shown that zero-shot and few-shot recommendations can beat random guessing, but or maybe some carefully designed heuristics as well, but they still cannot surpass the performance of a traditional recommendation model that is trained specifically for a given task and task-specific data. So to overcome these shortcomings, several researchers have proposed frameworks to fine-tune large language models with recommendation data. These frameworks use user item interactions to create instructions that are then used to fine-tune the LLMs. There are also several frameworks that take a foundational model approach, such as this P5 model, that extensively pre-train their model on a number of recommendation tasks with the same language modeling objective, and everything is under, of course, text-to-text paradigm. Zooming out a bit, in the recommendation space, LLMs have been used for data augmentation, for encoding text features. They have been used they've been used as a conversational tool that also decides whether to continue talking to the user or to call the backend API to further refine the current set of candidates. Some researchers have also used them as read anchors alongside the traditional retrieval model. And in many papers, they have also been used directly for generating recommendation outputs. So why should you use an LLM for recommendations? Well, LLMs' external world knowledge can supplement the behavior data and recommendations. And in few-shot settings, they can adapt to new information without having to retrain or change the model architecture. Their zero-shot performance can help in mitigating some of the data sparsity and gold start issues that are very common in recommender systems. And through a chat-based interface, users can now directly interact with the recommender system component, and they can also use natural language. And they can do all of this. When you compare it with the traditional recommender system, they only are passively involved through implicit feedback. And as a byproduct of chain of thought reasoning, LLMs can justify specific recommendations in natural language, which can increase the transparency of the recommendation algorithms. And using LLMs can also simplify some complex feature engineering steps, like some of the feature preprocessing and the embedding methods. And I believe it's equally important to be aware of some of the problems with this theme as well. LLMs may recommend items that are not present in the candidate set, and they can be highly sensitive to the design of the input prompt. They may give you an answer that is in incorrect format or very verbose when you simply ask for a yes or no question or a rating on a scale of 1 to 5. They can also be highly sensitive, like I mentioned, to the input prompts and deciding how many demonstrations to include in the prompt. What kind of demonstration to be included is also an open problem right now. And IDs ID-like features have been very successful in the traditional recommendation models, but incorporating them into prompts can be really challenging. There have been lots of research papers on that theme as well. And online recommender systems are real-time services, and they are extremely time sensitive as well. But these prompt generation and LLM inference steps, they have significant amount of time cost as well. There can be a huge gap between the universal knowledge that's encoded within the parameters of LLM and the specificity of the user behavior patterns that we see in the private domain data. And of course, data security is another related concern. Limited context lengths with some of these LLMs can make it really hard to incorporate a substantial amount of behavior information or the sequences into the prompts. Some studies have also shown that if there are some popular items, for example, best-selling books that might appear more frequently in ChatGPT's pre-training corpus, they're also more likely to be ranked higher when ChatGPT was used for ranking tasks. Some LLMs have also been shown to have position bias, where changing the order of the input items significantly changed the LLM's ranking output as well. So that sort of makes them suboptimal for re-ranking. And some of these LLMs have been shown to generate harmful content, reinforce social biases, and exhibit unfairness to sensitive attributes like gender, race, and so on. And of course, there are already lots of research work on how to potentially mitigate some of these problems. And using LLMs for recommender systems has been a very active recent research area. And there has been lots of exciting stuff happening. But that's all from my side for today. If you'd like to reach out, you can find me on my socials mentioned here. I also write a blog and a newsletter on various information retrieval topics. Thank you for listening, and thank you, Dimitrios, for inviting me.
Dude, you're too kind, man. How could I not have you on here? It is my honor. It's so cool to see this, and I love it. So I'm going to be in San Francisco in 2 weeks, and I hope to see you in person. And for now, I'm going to kick you off the stage because it is super late where I am, and I'm trying to finish at a decent hour. I appreciate this, Sumit. We'll be in touch, man. Thanks so much.
Thank you so much.
Anybody that has questions for Sumit, throw them in the chat or throw them in Slack. We're going to keep the lightning train rolling for our final talk. And the best part about this talk, well, maybe not the best part, but one thing, a nice little trick about this talk is that our guest, our presenter today, is actually tomorrow. What's up, Mon? How you doing?
Ooh, hi. Sorry, that's my dog at the back.
Your dog
Hi,
wants to
yes,
go out.
it's tomorrow for me, so it is 16th, and it is late for you too.
Yeah. Wait, what time? So you're in Australia. We're just gonna say that right now. You're gonna take us home, starting your day. I'm finishing mine. There's a lot of people in California that are just finishing up lunch, I believe. But what time is it where you are?
It is 8:10 a.m. So it's a decent time.
Yeah, that's not too bad. That's not too bad. 8, that's respectable. I am glad that I didn't give you a time that was 3 a.m. or anything like that. So we did all right. Anyway, you've come to talk to us about some really awesome stuff. I just saw your screen, but now I don't see it anymore. What happened? You might have to share it again.
Ooh, let me try.
That's the fun part. Yeah. Ooh. Where'd it go? Where'd it go? If it makes you feel any better, I'll tell you the stories that I have these big lights right next to me, and I didn't realize that for the last hour, there, I see your screen now. For the last hour, I've had my window open, and so now I've got these gigantic bugs that are just flying around. So in case you see me swatting while I'm talking to you, that is because I've got these gigantic bugs flying in my ears. Anyway, I'm gonna leave it to you. You're gonna take us home, bring it on strong, and let's see. I'll be back in 10 minutes.
Thanks, and nice to see you back again. So yeah, thanks for having me. All right, so I will be going through a little bit of our journey of building code completion tools within GitLab. I am an engineering manager who looks at a group called Model Ops, and we started this journey on building code completions through a tool called Code Suggestions. pretty much around for 6-7 months, and yeah, we've learned a lot through it, and just want to share through all the learnings together. So before we go into exactly what code completion tools do or not do, or the architecture of it, code completion tools, what they are, they write, complete, recommend the code you want. It is fundamentally very, very close to the heart of any developer, and using AI as an assistant in decision making for developers to help them provide that judgment. There's a lot of talks on how do you use it, what do you consider it usable, what part do you augment. But in general, when you're deciding on the outcomes of these LLMs for code completions, there's basically 3 areas. Will this code that a AI assistant completion agent or recommendation be honest, which is consistent with facts? This is beyond just evaluating for is the code correct. Is this honest to the developer who's developing? Is this harmless? And is it actually helpful? So accomplishing exactly the goal of the coder. So the coder can code fast, and instead of writing 500 lines, can actually write 1,000 lines of code for a usable feature. That's sort of what a code completion tool and how we actually decide on LLMs and based on these outcomes of these 3 different metrics. Now, I want to actually focus on the last part. Does it actually help to get to the goal of the coder? To do that, I do want to talk about a framework on how you can do evaluated, building a decision time framework to make these LLMs in production useful. And keeping in mind, a lot of the LLMs, other than ChatGPT, whether it's third party or open source, we don't necessarily constantly feed them the training data to judge the quality of the good, bad, and ugly. So then how do you actually then take these third-party open source LLMs, make them write code that are much better than an average coder can actually do? So that's sort of a goal that we want to achieve together. Okay, so some fundamentals, obviously, of choosing the right raw LLMs, as we probably call it. Things we want to look at is obviously the objective is code completions, code generation, recommendations code for developers. So this is all probably everybody by now probably has a better sense. We want to look into the parameters, the training data. This is really, really important to just get a sense of, just on a raw side, how much data, how much of the internet has been gone into this building this model and getting some smarts into this prediction machine. When you go through a completion tool, we want to look into what kind of evaluation benchmarks are already there with the LLMs that you've chosen. If it is open source, we want to understand the model weights. Are this flexible? What kind of tuning frameworks can we do? Or even for third party. Cost is obviously another thing, and latency. I see a lot of posts where we say we want to also assess quality, but I do think that this is a really hard one on how you can actually assess quality without really evaluating in and scale. And how do you actually then use these efforts of work on prompt engineering at scale and do almost like continuous training, continuous prompt engineering? So to get to that, I do want to first look into what an LLM architecture from a perspective can look like, where you basically, in this world of LLMs, you're not just choosing one, you're choosing many based on the factors we discussed before. And let's say you have an open source pre-trained LLM that you can also feed in further data to tune it. And then you also have certain third-party LLMs as well. And what you're then doing a full architecture of starting from the left, you're taking the data, additional data to enhance your pre-trained LLMs. You're downloading, let's say from Hugging Face, wherever, full raw data sets, partitioning, pre-processing, tokenizing, all the way into an environment where you're training it, tuning it, having those layers of checkpoints. Then it goes further into there's two engines running parallelly into it, is also then the prompt engine almost, where you are instantly with every code a person has written, you're going through the same layer of what we call a prompt library or prompt DB, of then looking into how do you deconstruct that code into tokens, understand what was then finally committed, and then get a better sense of a scoring mechanism of ranking. Is this a good average code developer understanding? And then going into some sort of a gateway where we have a prompt engine, post-processing, a validator, calling the models based on the input the user's doing, whether it's through the third party or actually through your pre-trained model. Now, the orange boxes are something we'll go through in the next few slides as well, as to how do you actually have a continuous evaluation and inference as part of this architecture. So focusing on the evaluation, how do you kind of do it in scale without the human eval benchmarks, and starting with that, and let's say you've started that and you've also done few more of few short examples, and you've done a little bit of user base, and then you want to understand how to version control it, scale it, do it continuously, have a CI/CD, continuous training, continuous feedback to consistently keep on dialing up the accuracy for your use case. Now, to do that, those orange boxes on the left is a way we would probably have a mechanism to continuously loop that, which would include prompt inputs to tokenizing, to understanding the similarity based on a developer, to storing it, to evaluating it, and then using that as a smarts to actually have the output. For example, let's say we have on a historic database, we've dissected a large model code to understand a token of completion, what a to understand how you build an XGBoost model. Now, we've seen that historically in a code base of a company that many developers have, developer 1, developer 2, developer 3, like that. They have different ways of writing the same code. They have different parameters, evaluations, and everything. And then what we've done is we've ranked these algorithms based on the code commit and similarity and agreed on what is an actual agreeable developer output. That then is then evaluated with how the LLMs, open source, third party, tuned is outputting through a technique where, based on the objective, we've used cosine similarities, you can use Spearmint or however, based on the prompt as well as the code through. Now, this engine, so the prompt is here, model XGB. We then know what an actual agreeable developer output should look like to understand how to map that to a quality. And then we know how each of these elements are giving, outputting it and matching that, and then sending the right output to the right to the user. Now, this makes probably sense in just one line, and a lot of times I see people having manual spreadsheets to looking into prompts and how to evaluate it. But imagine this, having this in scale as engines. And that's the beauty of having this sort of a microservice engines added to your layer of full architecture, where you can do this in an infinite loop on an instant basis to keep on dialing, let's say, your code completion usefulness, to harmfulness, usefulness, all the benchmarks, and then instantaneously keep on helping with the evaluation part of it. So this is something that can help, just doing it at scale 1,000 times in that continuous fashion. Now, on the serving then is basically what we call in the reinforcement learning of it. So imagine from that evaluation, then we go into, yes, we know what is the actual developer. We know what the LLMs are giving. Now we want to know if there are prompt templates of prompt tunings that we can do on an instantaneous basis, have a prompt validator, rate limiter output. If that can't be done, strengthen it to a fine tuning of the LLMs. Again, continuous loop, having it version-based, control-based. Each of these can be a microservice connected through a CI, and having that prompt validator, rate limiter becomes a key to really understand the user input as well as the output, to then put that full continuous loop, where you may start on the fact that at a certain level, you've started on the raw LLMs of a combination, giving you a 10% acceptance rate for coders. Then you sort of take this evaluation benchmark and then continuous prompting through reinforcement learning in a loop. And just like an Amazon recommendation engine, you're constantly dialing up this accuracy of usability to then get to that output. So then let's go back again now, putting that inference and the prompt of how this whole becomes that loop. Training data, completion data, continuously. And with code completion, you will always have code. There will always be a coder writing code. So you can continuously add this and keep on adding to this data for evaluation, for prompt inference, for ranking, for understanding what are those three decision time frameworks, how does that impact every code to get better in using LLMs for code completion. That's all I actually have today. I do want to end by saying that it is one of my lines that in this day and age of LLMs, data is still the oil. It is very difficult to imagine this, that with sufficient data, there will remain things that only humans can do. So in the journey of LLMs, this is still the key. This has not changed. Thank you so much for having me. I haven't put my details here, but I can put it on the chat. If anyone has questions, feel free to reach out to me in the MLOps Slack community channel, as well as on LinkedIn.
There we go. All right, Mon. Thank you so much. That is so cool and so valuable. I love to hear this journey, and I appreciate you sharing it with us and being very transparent. And now you get to go off and enjoy your day while hopefully it's sunny where you are. I know it is winter, right? That's another.
It is.
So maybe you're getting a nice winter day, and we are going to close the party for now, but we'll be back in action tomorrow, same place, same time. And we've got a whole nother lineup, but in case anyone would like to know, I will be singing more songs. I know you probably want to know I'm on. I will have more songs. You missed it because you were probably sound asleep, but I created a few improvised songs, and now hopefully I'll sing us all a lullaby and put us to sleep, and we will get out of here. Actually, no lullaby. I'm ready to go to sleep right now, to be honest. My brain has stopped functioning. I'm calling it quits. I'll see everybody tomorrow. And Mon, thanks again.
Thank you.
All right. And just in case anybody doesn't know, we have the in-person meetups happening all over the world. Mana's in Australia. We have in-person meetups happening in Sydney and Melbourne. And we also have some meetups in, oh my God, in like 37 cities all over the world. So basically, if you're in Europe, we've got actually some in Lagos, Nigeria too. We've got some in, obviously all over the US, and then some in Canada. And it is incredible how awesome this community is and how big it has grown. Don't forget, if you are in Berlin, and I imagine you're not awake still, but maybe you are because I am, and I'm in Germany. If you're in Berlin, we're having a hackathon this weekend. If you're in San Francisco, there's an after party that's happening right about now. You can go ahead and get started. Our workshop that we were doing with Ray and the AnyScale folks, that's totally sold out. So I just got word that there is a wait list of like 60 people. So that's not able to happen right now, but if you would like to do that again, just hit us up. We can organize more. And yeah, this has been great. I want to thank you all for joining us. I also want to mention that we created this LLMs in Production report. So if you want to see what I've been spending the last 3 months of my life on, there you go. There's probably still some typos, even though this is like version 25 of the report. I still, every time I go over it, I find typos, which is a lot of fun. But if you find one, point it out to me and we'll update it to version 26. So thank you all for joining. This has been awesome. I'm seeing in the chat people telling me that I need to go to sleep, and they are right. So we're going to end it there. We'll see you tomorrow. And yeah, I mean, wow, tomorrow, who do we have? Oh my God. Just by the way, let's just look at it real fast and just, I'm going to get excited. So keynote number 1 is Sarah from Einstein. She leads the Einstein group at Salesforce. I am so excited about that one. I don't know why, but I am so excited to hear what they are up to. And then keynote number 2, we've got Samyam. DeepSpeed, maybe you've heard of DeepSpeed. He's going to be talking about that because he is one of the co-creators of DeepSpeed architecture. I am so excited about that one too. I mean, this is the coolest part about the whole conference is that there's too many good talks going on. Oh my God, there is just too many good talks. We've got Shreya from Guardrails. We've also got Omar from Hugging Face, and of course, Andrew from Surge AI. Surge, let's just, if you know, you know, Surge AI is absolutely killing it when it comes to the front end and data labeling of these LLMs. I also said that I might lead a yoga break. I'm probably not going to do that because we didn't do a lot of breaks today. And so I'm going to bring some of the, we had like quizzes on the speakers and games and funny things that we're doing. So we're going to do that in the break tomorrow. I'll update that. Oh, huge one. I got to give a shout out to Arvind Srinivas, the CEO and co-founder of Perplexity AI. He's coming on tomorrow to talk with us. And don't forget Maxime, the creator of Airflow. You know, Apache Airflow, just a little tool called Apache Airflow. He now has another open source tool called Promptimize that he's going to be talking to us about. And then Replit. You thought we weren't going to have a LLMs in Production conference without somebody from Replit. We've got Bradley from Replit. I am so excited. That is just my track, all right? Mind you, Lily's got her own track, and we've got workshops that are happening. So it's going to be nuts. I am super excited, and now we're going to call it quits. That's it. I'm getting out of here. See y'all later. Feel free to grab a shirt. I'll leave it up there if you want to get the I Hallucinate more than ChatGPT shirts. They definitely they get comments, that's for sure, when you go out into public. All right, see y'all later, and have a good night.